Hey all of you, hope you guys are great and welcome back to Complete Solidity course. This course is going to be entirely based on project. We're going to learn everything about Solidity, all the syntax, and then we're going to cover some important interview questions which you have to know, because if you apply for a job they're going to ask you these important concepts about Solidity. Then we're going to see a couple of more example on each and every topic. Then we're going to build project on that particular concept. So before I go ahead and start everything about this course, that how we're going to navigate, I just want to share one research paper which was happened recently in decentralized finance, and the reason why I'm making this course is entirely based on that paper. Okay, so before you start learning any technology, you have to ask yourself that why you want to learn that specific technology and how it's going to contribute in your career. And the reason why I have decided to make a course on Solidity based on entirely this paper. Okay, so this paper was published by Gary Scale and it's on the decentralized finance, that how decentralized finance is going to shape the entire economy around the world. Okay, so they have explained everything, they have shared all the stats. So you can see they have explained the decentralized finance, what is web3 cloud economy, next phase of crypto growth, so innovating across banking. So they have explained everything, that how decentralized finance is going to change the shape. And this research paper was published in 2021 in November, and at that point of time you can see that how many people are already involved into this DeFi state and how many transaction is happening by every single month. So they have explained everything. I will share this entire report to all of you so you guys will have a complete understanding that why you should learn. So my entire focus of this course is going to be towards decentralized finance, that how you can build automatic bots which can automatically do trading. So most of you will find that there is a companies, they are allowing you to do flash loans, liquidity pools. So those kind of concepts we're going to cover, and we're going to touch in deep that how you can create your own bot which can do all the trades. And that's why I have decided to cover this entire Solidity course, because before we move to that advanced concept we have to understand everything about Solidity. Okay, so here I will share this entire report so you guys can read, and then you can continue with this project, with this course. Okay, so this is really helpful for me because when I read, I opened my eyes. Okay, wow, that there is a lot of things is going in the crypto world, especially in decentralized finance sections, not only in the NFT. Those are the good thing, but this is going to be change the entire shape of the economy. So I will share this report to all of you so you guys can have a complete understanding. And now let's come to the course. Okay, so this Solidity course will entirely based on project, mainly focus on decentralized finance. So this is how I have planned to take this course ahead. So every single topic we're going to cover in Solidity, every single syntax, what it does and how we can utilize that in our smart contract. Okay, so every single lecture will divide it in 4 parts. In the first part we'll have an introduction of the syntax, we'll see the couple of examples in the second part. In the third part we're going to cover some important interview questions which will come around that particular syntax or that particular concept. So this is how I have planned to take this course forward. So I believe that you will learn a lot of things in this complete Solidity course, because you have to have a better understanding if you really want to become a good blockchain and smart contract developer. Okay, and now let me give you a complete overview of Solidity, that how it came into existence, what type of language it is, and what type of similarity you will find with other programming language, and on which type of virtual machine you can run this Solidity code. Okay, and what type of tokens you can build, and what type of token, what type of file extensions, application, contract, data types, contract types, Solidity compiler, easy to learn, smart contract, decentralized finance, ICO, DAO, programming component. So these are the few things we're going to cover before we move to actual practical code. Okay, so from the next video, there are a few things you have to know as a blockchain developer and a smart contract developer, because when you will apply for an interview, in that they're going to ask you this basic terminology, that what are the other alternative languages you have besides Solidity to build the smart contract, what are the performance rate, why Solidity is more preferable than the other programming languages. So that's all I'm going to cover in this video. So hope you will have a better understanding so you can easily able to answer this important question in your interview. So before we do that, let's talk about what are the other alternative we have to build the smart contract besides Solidity, and what are their performance ratio. So let's start with Rust. According to the Stack Overflow, Rust is one of the most popular and beloved programming language. You can not only write smart contract, but you can build applications, computer program using Rust. In short, Rust is a low-level static type programming language, and because of that, it's fast and memory efficient in an industry where scalability and performance is everything. This is the simple smart contract written in Rust. We have state variable and we have functions. So if you know that how the Rust works, then you can easily able to understand this smart contract. So the disadvantages we have with Rust for writing the smart contract, that it's fast, no doubt in that, but it's fairly a new language. You won't find communities which can help you. So if you are starting up creating a smart contract using Rust, and if you will stuck somewhere, you won't find the community which can help you to figure out the problem. And on the other hand, you won't find library support. So if you're writing your smart contract in Solidity, you will have bunch of libraries which you can utilize it. But in Rust, there is no library which you can use to build your smart contract. And the second alternative we have for writing the smart contract is Viper, contract-oriented Python. This programming language was introduced to target the Ethereum virtual machine, and it has some core features like such as event, notifier, listener, custom global variables, and global contents. So there are a couple of good things is there in the Viper which you can use to build a smart contract. Viper was never introduced to replace Solidity as a smart contract programming language. The developer of the Viper, they built this Viper programming language to provide support in terms of security. So there are a couple of loopholes we have in Solidity, and the developer who find out and they provided this particular language to fix those security loopholes. And the core feature Viper provide, and that's what make the smart contract even more secure, like modifier, inheritance, inline assembly, function and operator overloading, recurring function, infinite loop, and binary fixed point. So these are a couple of features come with a Viper which you can use it in your smart contract to make it more secure. So this is the simple smart contract which is written in Viper. You can have a look. It has a similar structure, but there is a difference in the syntax and the way you point out the comma and bracket, okay? But this is a simple smart contract written in Viper. I'll provide you a couple of examples in the description in the link so you can check from your end. And the third alternative you have for writing the smart contract is Go programming language. And this language was introduced by Google to build application on Ethereum blockchain, and you can easily able to build any kind of computer programs. It's quite similar to Rust, okay? So all the functionality you find in Rust, that same features you're going to find in Go language. And the fourth alternative you have for writing the smart contract is Yell. So it's just like a Viper. It was introduced to build support to the Solidity programming language in terms of security. And now let's come to the star of the show, Solidity programming itself. Solidity is a contract-oriented high-level programming language, and this language was highly influenced by C++, Python, and JavaScript. It was designed to target Ethereum virtual machine. Solidity is a static type programming language, which means all the variables you're going to define in the smart contract, you have to be very specific. It cannot be changed once you deploy the smart contract. That's why it's called static type programming language, not dynamic type. It supports inheritance, it supports libraries, it supports complex user-defined data and other beautiful features which you can utilize to write your smart contract. And the best part of writing smart contract in Solidity that it contains multiple contracts. But all the contract within a file share a single namespace, and that's give the power. In 2014, when Gavin Wood proposed the Solidity programming language for writing the smart contract which can run on Ethereum blockchains, so the main funda was for creating this language so it can build a token which can run on the Ethereum blockchains. And you can see that we are in so early stage of this language that we haven't reached the release 1. We are still using the 0.8 version of Solidity. And now let's talk about some of the important components of Solidity. So let's start with the keyword first. So in Solidity, there are some special keywords in there. So you cannot be used as a variable name like keywords like contract, library, interface, pragma, and modifier. So these are the reserved keyword which is there in the Solidity. So you can use as a variable name in your contract. And the second one we have is identifier. So you can define any variables, any function in your smart contract as a name. So that could be the unique identifier for that particular function for the particular variable. Okay, so that's the two terminology we have called the keywords and identifier. And now let's come to the third one, which is a literal. So literal is actually a data type which you define in your smart contract like number, string, and boolean. So these are the important things comes in your interview. Okay, so the interviewer will ask you that what is literal. in terms of Solidity programming. What is identifier? What is keyword? Okay, so that's the thing you have to keep in mind. And the last one we have is punctuation. So it just represent the symbols which you use in Solidity programming. So if you have done coding in JavaScript, then you will find the exact same structure, exact same column, semicolons, bracket, which you will use in Solidity smart contract. Okay, so these are the 4 points you have to keep in mind: keyword, identifier, literals, and pronunciations. So you have to keep these technical terms because this is the term I'm going to use while going through this course. And now let's talk about some of the important feature of Solidity, that why we should use Solidity, how it's going to help us, what kind of program we can build. Okay, so let's start with the syntax. If you have code in JavaScript, you will have the same infrastructure, same pattern, same syntax to write the Solidity smart contract. Okay, so that's the first point we have here. And the second point is file extension. So every programming language had its own extension. So for Python, for JavaScript, for C++, so they all have their own extension. In the same way, Solidity does have its own extension .sol. And the third one is application. Solidity can be used to create contract for various purposes such as voting, crowdfunding, building auction, multi-signature wallet, NFT marketplace, or some kind of financial product. Okay, so when you will go to the interview definitely going to ask you, because I was asked once I gave the interview for the very first time. So they asked me this question, that what kind of application you can build using the smart contract. Okay, so you have to be creative. Okay, you don't give this generic name that voting, crowdfunding, auctions, multi-signature wallet, because everyone knows this. You can say about that you can build a Uniswap application which can do the trading, or you can create a trading board which can look at the price of the ethers, and on the base of the price chain they're going to do the transaction. Okay, so you can talk about those things. Don't give this generic name. So there is a lot of things you can do. Whatever application you see in the real world, you can create a smart contract, and that smart contract can control the entire functionality of that particular applications. In case of Instagram, in case of Facebook, you can build application like that. And the fourth point is contract. So the Solidity program which you're going to write, it will follow object oriented programming language. So if you have follow the classes in JavaScript, it's going to follow the same structure, but in that we have a couple of variables access. Like we have access of variable, we have access of modifier, we have access of function. Okay, so it will follow the same classes structure which you followed in the JavaScript. So that's the basic thing you have to know. So when someone will ask you that what kind of structure it's going to follow, you can say object oriented structure is going to follow for writing the smart contract. And the fifth point we have is data type. Every single programming language has its own data type: array, boolean, number. In the same way, Solidity does have its own data types, like unt stand for unsigned integer, int stand for signed integer, boolean we have fixed array or dynamic array. Okay, we have enum, we have struct, we have different type of data type which you can use in Solidity. And the sixth point we have is contract deployment. So whatever contract you're going to write in the Solidity program, you have an option to deploy on the Ethereum blockchain. You can use it Polygon blockchain, because all of these blockchain can accept the smart contract, and it's follow the same protocol like EVM, Ethereum virtual machine. Okay, that's the only thing you have to keep in mind. And the seventh point we have is Solidity compiler. And definitely when you will sit for an interview, they're going to ask you this simple question, that what is Solidity compiler? So Solidity compiler is nothing but the Solidity version which you are using in your smart contract. Okay, so right now you have seen that we have a lot of version. We have started from 0.4 and right now we are using 8. So there is a lot of changes came into the programming language in the Solidity, and whenever you can pick any specific compiler to write your smart contract. Okay, so make sure you have to be very specific. Whenever you write your smart contract, you have to pick the 8, because that one is latest, and because in the earlier contract we had a lot of bugs which can create a overflow and underflow problem. So make sure to use that 8 compiler. So this is the answer you can get, that we should prefer to use compiler 8. And number 8 is easy to learn. Solidity is a fairly easy language which you can start learning. If you be focused for the 3 month, you can be a master on Solidity programming language, because this entire language is influenced by existing language. So if you have little bit knowledge about any previous language like JavaScript, Python or C++, you can easily able to learn this language very fast. Okay, so before you start learning this language, you have to focus on at least JavaScript. Okay, at least JavaScript. And now let's talk about the contracts which you can build using Solidity smart contract. So right now in the real world, you will find that most of the exchange have their token, ERC20 token, ERC21 token, ERC1715 token. So you can create contract and you can have your own token which can get regulated and you can make money out of it. Okay, so that's the one funda we have. You can build an application using the smart contract which can entirely control by the smart contract. Okay, you can build contract which can be run when a certain condition fulfilled. Okay, so you can use for many things. Whatever you can see right now you're doing on web2 platform, that's all you can do on a web3 using smart contract. And the most common uses you will find right now in 2022 when it's come to the smart contract, like you can able to build your decentralized exchange where user can buy coin, trade coins, and that contract will communicate straight away to the Ethereum blockchains. Nobody is involved in that. It will allow user to facilitate all the transaction exchange. The second option you have is you can launch your own ICO. So okay, if you have your own company, if you have your proposal, and if you want that the user should contribute in your project, so you can launch your own ICO, which stand for initial coin offering, and you can raise fund from that. Okay, it's just like a stock market. And third one we have is DAO. Okay, you can create a decentralized autonomous organizations. You will define the proposal in that contract will control every single thing. Those who will be a part of the DAO, they have the right to give vote, and on the basis of their vote the contract will decide that what action need to be taken. Okay, so you can do bunch of things. Don't need to worry, we're going to do all of these things. We're going to build application on each of this topic. We'll launch our ICO, we'll build our DAO, we'll build a decentralized exchange, we'll build all different kind of application. Okay, and that's the only thing I want to cover about the Solidity, that what are the competitive language you have, what are the things you have to keep in mind, how it's going to help you when you will write your smart contract in Solidity and when you will not write in Solidity and write in other programming language, and what are the problems you will face. So hope you will have the complete understanding and you are taking note. Okay, so whatever I have covered, make sure to take note of this, because these are the questions we'll definitely going to ask when you will sit for the interview. Okay, from the next video I'll give you a complete overview of Remix ID, that how you can utilize that online tool which is so powerful for building a smart contract. Every single functionality and every single features Remix ID offers you, we're going to have a complete overview of that. And after that we're going to see a sample Solidity smart contract for housing. Okay, so after that we're going to cover that. So hope you guys have liked it. If you are new to my channel, hit like and subscribe. That will motivate me a lot. And do leave your like and thought. What do you think about this course? What topics you want me to cover and what project we should build? So see you in the next video. In this video, you will learn that how you can use Remix ID to test your smart contract, to write your smart contract, to deploy your smart contract. What are the Web3 provider Remix ID provide you, which you can use to connect with different blockchains, whether you want to use injected provider, whether you want to use MetaMask, Ganache, Haddad, localhost, all the providers you will find in this Remix ID so you can test your smart contract. In this video, I'm going to give you a complete overview and what are the setups you have to do to be on my footstep to continue in this course. Okay, so make sure you open your Remix ID in your browser. So here I've opened the Remix ID in my browser, and the very first thing you have noticed this scam alert. Okay, so don't need to share any important credential with anyone else. Don't get into trap of liquidity and pulls. So they have given some tips which you can follow to make it secure your account. Okay, and here you will find some feature plugin which you can use to write your smart contract. So we have Solidity, we have StakeNet, and bunch of plugin we have. We're going to explore each one of that. From here you can easily able to create a new file, new folder, and you can connect to localhost. Okay, so if you want to use your localhost browser to create a test your contract, you can do that. And if you have any confusion about Remix ID or any particular feature which Remix ID provide, you can simply visit their documentation. You can easily able to visit the channel and some feature website if you want to take the reference of that. Okay, and from here you can easily able to import any file or any libraries. So we have GitHub, IPFS, HTTP, RPC, URL. Okay, so they have bunch of options. We're going to explore this. Okay, and here we have our terminal. So all the contract will deploy, all the transactions, logs, that's all we can able to find right up here. Okay, so we're going to see this in basic overview of this home page. Now on the right hand side you will find that we have our workspace. Okay, so if you click on this here you will find different workspace. So if you want to create a new workspace, you can create. If you want to connect with the local host, you can do that. If you want to go with the default, you can do that. So make sure you go with the create new one. Okay, and here you have to give the name. You can pick that what you want blank, open zipling, ERC21, ERC7021, ERC5050. So okay, here you will have bunch of options which comes with supportive template which you can use it. Okay, and here you can give the name whatever you want. Okay, so I'll say SOLIDITY Solidity course, okay, because all the codes we're going to write in this. Okay, so here you can see we got our project workspace ready. This is the name we have given. Let me close all this open folder, and that's the script. So if you want to test the contract, you can do it right up here, which we're going to do. From here you can do the editing from delete, and if you want to import any file from the workspace, you can do that. From deployment, you can do that, and you can simply copy it. Okay, you can simply copy a URL from the GitHub and you can paste and you can import the entire file here. Okay, so that's how you can create your basic workspace. Okay, so if you click here, you will come back to your workspace. If you click on this, from here you can do the basic settings like file extension and what are the things you need to exclude. Okay, here you will have important. So this is the very important thing. Here you will find all the Solidity compiler version. Okay, and that's very important. Make sure you should always use the latest Solidity compiler version. And but if you have any previous code, suppose you have got any smart contract which is written in previous version, so make sure to come and simply change the compiler version as well, because by default it will select this. But if you using different compiler version and you have in different in your smart contract, and if you're using this, that will throw an error. Okay, so make sure you can easily able to change your compiler version from here. We're going to do time to time. Okay, and make sure to make it on auto compile, so whenever you will write, it will automatically compile and save, and you don't need to do anything here. Okay, from here you can easily able to do the important setups. Okay, let me expand this and let me show you what we have here. So here the environment we're going to use is this Remix VM London. You can use this Berlin, and here you will have all the providers. So we have injected provider, we have harded provider, we have Ganache, we have boundary provider, connect wallet. So we have all these provider. We can use it to test our smart contract. Okay, so if you want to use harded, which I have used a lot in my previous NFT marketplace project, so if you haven't watched that, I'll link the complete tutorial so you can follow that. Okay, so we're going to use each of these provider in detail, but we'll start with this normal Remix ID provider London one. Okay, and from here you will have to pick your account. So Remix ID provide you close to 10 account, and each account contain 100 fake ether. So we're going to use each of these account to switch between the accounts and do the testing of our contract. From here you can easily able to set the limits in your contract. Okay, so whenever you want to have a limit in a function, like this much gas fee you're going to pay for calling the function, so you can set the limit for that as well. From here you have multiple currency, which is in ether. This is way is the lowest, GUI is the uppest, and then Feni, and then we have the ether. Okay, so we're going to do all the transaction in terms of ether, so make sure you select this ether, and from here we can easily able to take it up and down. Okay, and here we're going to have a contract. So when we're going to compile it, we're going to use it at out, and here you will find all the transaction log. You don't need to worry about this, and here you will find the deployed contract. Okay, and from here you can easily able to do the debugging. Okay, and that's the very important feature, because this tool will allow you to see that what data you have in which function at the time of deployment and when you are calling the function. So you can easily step by step navigate to the entire function and you can check the value. Okay, and the same thing we have done when we are building the NFT marketplace API, and that I have explained that how you can check the every single value in the API and the data is flowing. Okay, so this is a very important tool which we're going to use a lot, and you don't need to worry about this. Here you can stop and run the code, which we're going to do exactly, and here you will find all the libraries. So we're going to use a couple of libraries to make our work very easy, and this is the general setup. Okay, don't need to worry about it. And that's the only thing I wanted to cover about this Remix ID, because it's really powerful. If you do all the same thing in the code, we can do it very easily, but it's more time consuming, and we have this powerful tool which we can use right in the browser and test and deploy in one go. Okay, so that's the tool we're going to use a lot. When we're done with the entire course with all the syntax, then we'll move to the project, and that we're going to use our code editor and do all the thing. Okay, so hope you guys have found this video valuable. You have understood that what are the things we have. If you want to find plugins, where you have to go, how to create a workspace, how to import different resources from different places like IPFS, GitHub, we're going to do that all. So hope you guys have found this video valuable. If you have still any question, down, do leave in the comment section. And that's the only thing I want to cover in this video. In the next video, I'm going to show you the sample smart contract which I have built for the hotel industry. So we're going to have a look at that contract, that how we can write contract in the real world. So before we actually move to the syntax part, we have to have an understanding that what are the things goes into that for writing a smart contract. Okay, what are the syntax we are using? Okay, so I'm going to give you a complete overview of the contract which I have built for the hotel industry. So let's move to the next video. This is the simple smart contract we have written for a hotel industry, and this contract keep the track of entire activities happening in that particular hotel. So it will keep the track of the hotel tenant with an address, it will keep the track of hotel landlord with an address, it will contain the information about the number of rooms are there in the hotel, number of agreement, number of tenants. So it will keep all the track of this important information. And here you can see, here we have this struct which has this multiple data type. Okay, so we're going to talk about all these data type which you can see in detail. In this video I just want to give you a complete overview that how contract look like and how you have to build the contract in Solidity. Okay, so this is the struct for room. Okay, so every single room will have a unique ID number, unique agreement number, unique address. So all the data we're going to define inside this struct, and who is the tenant, who is the landlord, whether the room is vacant or not, when the time of booking, then security deposit, payment per month, address, name, agreement, room ID. Okay, so all these data will define to every single room whenever we add into our hotel. Okay, and mapping is huge addition to the Solidity smart contract. It is just act like an array. Okay, so every single room will have this unique properties. Okay, so if we want to find out the entire details of this particular room, all we have to do is to pass the room ID into this mapping, and we can easily able to access all the data you can see here. We're going to do this in practical. Okay, so this is the room we have struct for the room, this is the mapping for the room we have. Now we have another struct for the agreement. Okay, so whenever any user will have an agreement, they book an hotel room, all this property will assign. So it will have a unique ID, agreement number, room name, address, monthly payment, deposit, all the thing will assign automatically. Okay, and we have a mapping for that. Okay, so if you have an ID and you wanted to find out the information about the agreement, so you can pass the ID of this and you will have the information. So mapping generally act like an array. Okay, we have nested mapping which we're going to talk about. Okay, just follow along with me what is happening here. And we have another struct which is a rent. So whenever any tenant will pay the rent, all the property would be assigned to that particular payment. So it will have a unique ID, unique agreement, and all the information. So if we want to find out the information about that particular payment, we can simply pass the ID here and we'll get all the information. And here on the top you can see, here we are keeping the track of the total number of rent we are receiving into this contract. Okay, so we can easily able to access from here as well. So this is the agreement and here we have the rent. Let me close all this and close this one as well, and we have a mapping for the rent as well. And this modifier is a huge addition into the Solidity programming language. It allows you to write more secure code because your contract will contain a lot of sensitive data, money. So it's always very good that you have to write more secure code, and in that scenario modifier plays a very important role. So what it does, it will keep the abstraction. For example, you have a condition which you want that user should fulfill, and then you want to execute the code further. Okay, so in such scenario what do, you can take the abstraction of that condition and make convert into a modifier, and all you have to do is to call this modifier wherever you want, no matter in how many function. Okay, so this will save a lot of bug in your code, and you can easily able to write less code and you can check multiple condition with the same function. Okay, we're going to have a complete detail on this. We're going to find out that what are the ways we can write the modifier. You can see this is the simple way I have written, and what are the places you can add modifier. Okay, in your smart contract. So here I've created multiple modifier. First one is for the landlord. So I have to check certain function should be called by the landlord, not by the tenant. Okay, we have a not landlord functions, we have a not only while vacant modifier, we have this enough rent modifier, we have this agreement fee modifier, we have the same tenant modifier, we have this agreement time left modifier, we have the agreement times of modifier, we have the rent times of modifier. You can write your smart contract without using this modifier, but it's always great that you should use it because it's allow you to write more secure code. Okay, and here we have the very first function which allow us to add room into a smart contract. In that we have to pass couple of data. We have to pass the name, address, rent cost, security deposit, and we can simply changing all the data here. You can see here we are calling this struct we have created for the room on top here. So here we have the room, this room struct, and we are updating all this data whenever any room get added into our contract. Okay, and that's all you can able to find here. Okay, so we are increasing the room number, we are making to vacant to true, and we are updating all this data. Okay, so we're going to talk about each of these data type, each of this function, and how we can call the struct, everything in detail. I just want to give you a complete overview that how the smart contract look and what are the function exactly there and how this contract is happening. Okay, so this is for the add room. We have the same, we have another function for the sign agreement. So if anybody wants to book a room into this contract, so this is the function they're going to call. All they have to do is to pass the room ID, and they have to follow this couple of modifier which we have to add it here. Okay, so this function cannot be called by the landlord, the one who created this contract, and the one who tried to book the hotel room. They have to have enough money, and it only, and this booking can only be happen when the particular room is empty. Okay, so these are the couple of conditions we are checking, which we have extracted as a modifier here. Okay, so you can see how life saving it is, and here once we are passing all these things, we are simply updating all this data. Okay, so we are updating all this agreement data here, which is very simple. Okay, right now I believe that it makes complicated, but this is very simple. We're going to cover in detail, don't need to worry about it. Okay, so this is a sign agreement function we have, and now we have another function called pay rent. So if a tenant want to pay the rent, so all they have to do is to call this room ID number, and it will do all this check, and then they can simply update the make their payment. Okay, here we are changing all the state. We have another function for agreement completed. Okay, so whenever any agreement will happen, it will happen for a specific time period, so that's why we have the timestamp in our struct. Okay, so on the base of that, we are checking that whether the agreement still exists. If it exists, then let it be like that, but if it exceeds then the normal agreement time, then they're going to simply transfer the entire deposit. Okay, so here we are simply tenant transfer to the security deposit. So they are transferring some money which the tenant has provided as security deposit, and they are taking from there. Okay, so that's what we are doing here. Here we have the last function, which is called agreement tenant. So if a user don't want to be in the hotel and they want to cancel the agreement, all they have to do is to simply make this call. Okay, they have to pass an ID, it will fulfill all these conditions, and it will come true. Okay, so that's the simple smart contract for a hotel industry. You can add hell lot of things. You can add a lot of security. Right, this is a very simple smart contract we have built for the hotel industry. Okay, and you have noticed one thing, that here I have used this 0.5.16 version, because when I was learning, this is the contract I had built exactly at that point of time. Okay, so this is what I have built. So I thought let me give you a complete overview in the same contract which I built at the very first time when I started learning the Solidity smart contract, and this is the version I have used at that point of time. Okay, but don't need to worry about it, because very soon I'm going to build an application using the smart contract, because we have the smart contract, and we're going to build a web3 application where a user can come and book hotel room. Okay, so we're going to create an application on that. So if you guys really want me to create using what technology, whether I should use TypeScript, whether I should use React, Next.js, so do let me know what technology should I use to build this entire web3 application. Okay, it's going to be a very good portfolio application which you can add in your resume. So this is how the smart contract looks like in the real world, and don't need to worry. Again, we're going to have a detailed discussion on each of these topics, each of this address unit, struct, variables type, how we have to write more secure code in details. Okay, we're going to take one step at a time, because I want you to understand everything in detail. Okay, because when you will go to the interview, right now Solidity and blockchain is in the early stage. Okay, so nobody has the deep understanding in terms of security, in terms of language. So you have to know every little thing about the Solidity smart contract, so you can easily able to answer, because they're going to ask you more in the technical side. Okay, so you have to know that how to use struct, how to retrieve data from the struct, how to update the struct data, how to use mapping, how to use nested mapping. So all lot of things we have to do. Okay, so you can see this is the Pragma Solidity version I have used in my contract, and the moment I will come in the deploying section, you can see that here where it is. Here you can see that it will automatically discharge that I'm using this Pragma Solidity version, and it will pick this here. Okay, so here you will find all the Solidity version which you can use to write your smart contract, but I would recommend you to go with the latest one, which is 0.8.70. It's a recent delete, but this is the program we have written in the call, say 5. It's a 5.16. Okay, so this is the one we have used.
So make sure no matter what Solidity version you use, make sure to check it from here and try to use the latest one, because that will come with a lot of security and good stuff. Okay, so that's the only thing I want to cover. I hope you will have a complete understanding that how the smart contract exactly work in the real world and how you can create, what are the conditions you have to fill. Okay, so when you write your smart contract, the very first thing you have to do is you have to picture the entire contract, that what you exactly want to do with that smart contract. In case of folder industry, you have seen that we have keep the important information in consideration, like tenant, landlord, number of room, agreement, rent, and according to that we have built all the functionality, that there should be an agreement struct, there should be a room struct, there should be a payment system. Okay, so you have to always write down that what are the functionality you want to have in your smart contract, and then you can build on top of it. Okay, and that's the strategy we're going to follow, because from the very beginning I want you to think that how you have to write, and how you have to write the smart contract, not only just writing, how you have to make it more secure, because that's the most important thing. So I don't want to extend this video too long. That's the only thing I want to cover in this video. In the next video, we're going to write the first function in our Solidity smart contract and how you can write your own function. Okay, with that said, I'm ending this video. Let's move to the next one, where we're going to write the first application in our Solidity smart contract. So let's meet there. Hey all of you, hope you guys are great. So in this video, you're going to write the very first smart contract in this Solidity course. Every single video will be divided in 4 parts. In the first part, we'll talk about the theoretical part of the syntax. In the second part, we're going to do the practicals around the syntax. In the third part, we're going to see some real world smart contract examples which have used those syntax. And at the end, we're going to cover a couple of interview questions related to this particular topic. So this is how I'm going to plan every single video right from here. Okay, so here I have opened my Remix ID. Make sure to do that. You can able to code along with me. So first thing we have to do is to provide the license identifier, and this is the general convention which you have to follow. Okay, it's going to be MIT. Okay, so to know what this MIT is, come here, and here you can able to find all the details that what this MIT stand for. Okay, it's actually a copyright and it's free to use. You can easily able to use this software to write smart contract. You can modify as per your contract. So I will provide the link of this GitHub repo in the description so you guys can check. And you have to keep in one thing in mind, that the compiler version you use in the Solidity smart contract, it should be equal to 8.13 and less than 9. Okay, so and this is the updated one, so make sure to always use the latest compiler version. And here we're going to take this pragma Solidity, and then we're going to define the compiler version which we want to use. And as you can see, this arrow up means that take this version, and whatever version above this we can use that as well. Okay, so this arrow up means like take all the version above this 8.18. okay, so that's what it is. Okay, so I want to take 13, not 18. So this is the Solidity version we have here. Now we'll come here, and now we have to create the contract. So to create the contract, there is a keyword in Solidity by the name contract, and then you have to define the name of your contract. Okay, so make sure you should always give your contract name in capital letter. Okay, so I'll say my first contract, and this is the dynamic block. So if you have coded in JavaScript classes, then you will find the similar structure here as well. Okay, and now I'm going to define a couple of state variable here. We're going to talk about each of these variables, each of this data type in detail in the further videos. Okay, I just want to show you that how you can build the simple smart contract and build your first smart contract. Okay, so I'm going to take this string, and it will have no data. And here if I come here and if I deploy this, click on this account, I'm going to choose this one like Remix VM London, and now I'm going to deploy this contract. Okay, pick the contract and deploy. Here I will get the transaction, and you can see right now I have nothing here. And because to access this data, all I have to do is I can simply come here in the ABI. If I copy, you can see this is completely empty. I don't have anything. Whenever you will compile your code, it will generate the ABI of the smart contract which we have written. In that you will have all the data. Okay, I believe that this sounds complicated right now, but I want to explain everything from the beginning. Okay, we're going to have a detailed discussion on each of these ABI and bytecode and how we can utilize it. Okay, so right now we don't have anything here. We're going to remove it, and if we look at the bytecode, you can see this is the bytecode got generated. So we have the function debugger. It's entirely empty. We don't have any data because we haven't written any functionality, anything like that. Okay, so it's completely empty we have here. So okay, so this is our bytecode, source map, everything we have here. Now delete this one, and now what we can do is let's come here, and right now you can see the balance in this contract is 0 because we haven't have any ether into this contract. So now what I can do, I want to see the value of this string hey. Okay, so for that I can use this public keyword, okay, and it's an inbuilt keyword in Solidity smart contract which allow you to create a getter function. Okay, we can easily able to access this data by creating a separate function which allow us to fetch the information. But if you use this public keyword in your variables, it will automatically create the getter function. Okay, so we have a detailed discussion on this, don't need to worry about it. Okay, just follow along with me. So now if I deploy the contract, if I delete and deploy the contract one more time, and here you can see right now I got this hey because of this public keyword. Okay, and this public keyword will generate a getter function for me. So if I click on this, I can see the data type I'm getting, and there is no value in that. Okay, there is no value in that. So now we have to assign a value. So you can simply assign a value like this. You have an option to assign the value right in the state variable sections. Okay, so you can define the value here, hey, dollar, and that's okay. Okay, save it, delete it, and deploy the contract one more time. And if you click on this hey, you can see I got the value. Okay, so this is how you can easily able to access the data of the state variable and how you can define state variable. Okay, so this is one way. And now what I want to do, I want to take this unt, because there are multiple data types. We have boolean, unt, array. Okay, we're going to have a detailed discussion on this. Just follow along with me and understand that what are the things we can do in the simple contract. Okay, so I'll take this unt, and this time I have to change this value to 4, and make sure to change the name. So we have to change this name to something like num. Okay, so let's make it num, and no sorry. And now we can deploy the contract, and you can see here we have the contract. If we click on the header lot number, okay, so this is the data we can easily able to access with the help of this public. So I believe you guys have understood that how you can easily able to access the data without calling any function using the public keyword. We're going to talk about each and everything in detail later in the video. Just follow along with me. So this is the one way to get the data, and let's comment out this. In the above example, you have seen that the data is predefined, but I want to add the data based on the function or on the contractor. Okay, so what I can do, I can simply comment this, and I'm going to remove this value. Okay, value. So if I come here, and now I'm going to update this data with the help of constructor. Okay, so constructor is a keyword in Solidity which will run every time you will deploy the contract. Okay, again we're going to have a detailed discussion on this, so just follow along with me. In this we have to pass this data. Okay, so what I'm going to do, I'm going to pass the string. Okay, string memory, and we're going to pass this hey. Okay, so we're going to receive data in this constructor, and we're going to assign this to our variable. Okay, and now we have to receive the number as well, and now we have to update the data. So hey, and we have to update the number as well. And this is the another way which you can use to update your state variable. Okay, right now we don't have anything in our state variable, but when we run the contract, when we deploy the contract, our state variable will get updated. Okay, so this is the constructor we have, and now everything is looking fine. Now what we can do, let's come back and let's try to deploy the contract. So here make sure to select the contract, and here we have to pass this data inside this. Okay, because in the constructor we have to pass this hey and number. First one is string, second one is unt. Okay, so this is the data we have to pass. I'll type something like dollar, and the number I want to give 23. Hit on transaction, and if I open the logs, here you can able to find the transaction weight successful. And if I open the details, you will find the entire details of this transaction which you have done when you deploy the contract. So you will have the address, you will have the name of the contract, the gas amount you have paid, all the things you can able to find in the logs. Okay, and here you can see this is the data we have passed, a string and number. Okay, deported. Okay, and if I come back here, and you can see if we call this function hey, you will see dollar, and if we call this no, here we have the number. Okay, I believe this makes sense to all of you. Okay, so this is another way to update your state variable with the help of constructor. And now let me show you one more example. So we have updated the state variable with the help of constructor at the time of deployment, but now what we're going to do is we're going to update that state variable with the help of function. Okay, we have a dedicated videos for every single topic, every single syntax we are using in this contract. Okay, so here I will create a function. I will call say add info, because this function will allow me to add the information in our state variable, those variable we have created. Okay, and inside this we're going to simply pass the same data. We have to pass memory, we have to pass the number. It's going to be a public, and we can simply call this and update the data. Okay, so we'll say hey, we have to pass the number as well, and that's it. Now this function will simply update the data of the state variable. Okay, So come here, let's remove this and let's deploy the contract. So right now you can see we don't need to deploy, simply close this one, hit on the close this one, and right now you can see we don't need to pass any data at the time of deployment because we are not going to update the data with the help of constructor. Okay, we are going to do with the function. Okay, so click on this deploy, and here we have the function, and here you can see we have this hey is empty and number is empty, but in add information we have to pass the data. Okay, so let's come here, pass the string. I'll say $, and here I'm going to pass number transaction. You can see transaction went successful if you click $, and if you click number. So this is how you can easily able to add the data and update the state variable with the help of function. Okay, so that's pretty much very simple things we are doing here. Hope these all things are making sense to all of you guys. Okay, this is the basic examples I have given that how you can use write a simple smart contract, create a variable, update the variable at the time of deployment, at the time of function calls. Okay, so you have bunch of things which is coming on your way in this course. Okay, so these things looking good. So hope this makes sense to all of you, and that's the only thing I want to cover about this sample smart contract which we have built in this video. We're going to have a detailed discussion on each of these syntax we have used here. Don't need to worry about it. We're going to cover a lot of things about every single concept which exists in Solidity. So that's the only thing I want to cover. With that said, let's move to the next video. In this video, we're going to build a simple smart contract which will count the number of NFT. Okay, so let me show you what we're going to do here. So let's come here, and I'm going to take this contract and I'm going to give the name to this contract is NFT count. Okay, so that's the name I'm going to give. I will take a state variable, I will make it public so I can easily able to see the value, and I will take number of NFT. Okay, so this is the state variable I have taken, and now I will create this function. This function will increment the NFT number. Okay, so I will create this function and I will call add NFT. In that, we're not going to pass anything, we just want to increase the NFT count. Okay, so it will become public because anybody can call this function. Okay, and we want to simply update this NF plus 1. So here what we are doing, we are taking the number of NFTs and we are adding 1 to that. Okay, so whenever someone will call this function, it will keep increasing that NFT count. Okay, so that's the add NFT function we have. Now let's write one more function. This will allow us to decrease, okay, delete the NFT count by 1. Okay, so it will say delete NFT. Again, it become public so anybody can call it, and -1. So right now we are making it public so anybody can call, but in the real world application you should always check for condition that the one who created the NFT, they have the rights to delete the NFT only, or maybe the moderator or maybe the owner of the smart contract have the authority to delete any kind of information from the smart contract. Okay, but right now I'm just giving you this simple example. We're going to build certain logics around this in the later videos. Okay, so this is for the deleting, and now let's write one more function which allow us to see the number of NFT we have created. Okay, to fetch the data of this number of NFT. Okay, you can do it by this using the public keyword, but it's never a good idea that you should make it public, this sensitive information. You should always try to retrieve data from with the help of function. Okay, and allow certain condition on that, so only certain people, a certain authority individual can have the access of this information. Okay, so let's write the functionality for that. So I'll say check total number of NFT. Okay, we'll write the function, we'll say check total NFT public view. And the reason why we have used view here, because we want to see the state variable. Okay, we have a detailed discussion on this view keyword, that why we use view keyword and what kind of operation we can do with the help of view. Okay, so make sure to use view, and then we have to return this because we want to see the data. Okay, and here we're going to pass the data type, that what we want exactly return, and here we're going to use this return keyword. Okay, return keyword, and we're going to pass this number of NFT. Okay, so these are the 3 functions we have written which allow us to check the NFT count, which allow us to add NFT and delete NFT. Okay, hope things making sense to all of you. That's why I have included this one more small sample smart contract project so you guys can understand that how things are taking place. Okay, so that's looking pretty good, and now we can start testing this one. Come here and let's try to delete the old deployment, and this is the account I'm going to take, and I'm going to take this account number 3rd. Okay, and now let's deploy the contract. You can see this is the deployed contract. If we open it, here we have all the functionality. So if we click on this, right now we have this 0 balance. If you click on this check total, we have 0, we have nothing in there. If we click on this, still we get the 0 because here we have used the public keyword, so it's create a getter function. So that's what it is. Now if you click on this, If you come here, you can see the transaction event successful, and if you click on this check total, here we have one. If you click on this, here we have one. If you click one more, 1 2, no matter how many times you will click, it will keep increasing the number. Okay, and click in number. Okay, and deleting, increasing, deleting. And this one is a very important functions in smart contract, because sometimes what you have to do is you have to keep a track of certain IDs. You have to delete IDs, or you have to add IDs. So these kind of function plays a very important role, which allow you to create new ID for every single logic which you want to build, or every single condition you want to build. Okay, so that looks pretty fine. You can see we can delete, we can add, and this contract is absolutely working fine. Okay, so check, add NFT, so all these looking fine. We're going to have detailed discussion of this unt data type function, pure public return, so we'll have a detailed discussion on these. Okay, I just want to give you a more practical example so you guys can understand that what are the possible things you can do. Okay, and that's the only thing I want to cover in this video. Hope you guys have found this video valuable. If you are still any confusion and doubt, do leave in the comment section so we can discuss on that. So let's move to the next video. Like every programming language has its native data type, in the same way Solidity has its data type. So there are generally two types of data types in Solidity. One is value data type. In that you will have boolean, integer, fixed point number, address, byte and string, enum. Okay, so these are the value data type. And the other data type we have, it's called reference data type, and in that we have array, struct and mapping. Okay, so we're going to cover each of these in detail, that how you can create array, how you can create boolean. So the first data type we have is boolean. Okay, this is how you write bool, and we are making public so we can able to see the data value. Okay, so we'll type hey. Initially I'm not going to change the data type because the default value of this boolean is false always. Okay, and the second one I'm going to take is boolean and I will make it public, but here I'm going to change this data type to true. Okay, so this is boolean, but this time it's true, not false. So this is the way you can define boolean in your smart contract. Okay, let's come down. Now we're going to talk about the other data type, which is uint, and uint stand for, let's say, unsigned integer, meaning no negative integer, only positive. Okay, to write the unt variable, this is how we can do it. We'll take this unt 8. Okay, so we have couple of range. We have unt 8 is the lowest one, then we have unt 16, unt 24, and it will go all the way to unt 256. Okay, so let me show you what I mean by that. So the unt 8 will range from, let's say 0 to and 2 multiplied by 8 and minus 1. So okay, so whatever value you will get, that's the range of this unt 8. Okay, so hope this makes sense. So this is the range of unt 5 and the range is 255. Okay, so if you do the calculation, you will find that it's 255 is the range of unt 8. Okay, and this one becomes 16 and I will make it 16. If you come here and if I paste here, so this is the range I got it. Simply copy and I'm going to paste it back here. So this is the range of the unt 16. Okay, which is very important because we're going to use the same things, because we have to define explicitly about the data variables, and that will help us to save gas fee. Okay, so this is the thing which you have to keep in mind, because sometimes what happen that the problem will come in terms of underflow, overflow. Okay, so we have to deal with that as well. So this is the unt 6 we have. Now let's take another one. We'll take this, let's say unt 256 is the highest one. Okay, and the range lies between, let's say, we'll take this one, 256 minus 1, and same thing, we have to copy this and let's find out the value. So paste and simply copy this one. It's a huge number. Okay, so this is the range of unt 256. So hope this thing's making sense to all of you. Okay, and the reason why we take different ranges, because it will allow us to save gas fee when we deploy the smart contract. So that's the only thing you have to keep in mind, but it's always better that you should go with this unt 256. So this is how we can define unt 256. And now let me show you that what data we have exactly in this. So let's make it public, unt 8, and I'm going to assign this the value to 8, and this will become, let's say, 244, and let's make it to 8. Okay, and by default it will take 256. Okay, so whether you define unt 256 or not, if you write only unt, it will take 256. So that's you have to keep in mind. It will always take this 256. So let's simply comment out this portion and let's try to find out the data. Okay, simply come here and deploy the contract. Let's deploy it. Here we have the contract, and here you can see we have hey. We have hey is false, because that's by default the boolean value is false. Okay, false. If we click on no, we have this true, because we have assigned hard-coded value. And if we click on u, we have this data, you can see 1 2 3, we have this unt, and this is the value we have, and if we click on this, and this is one we have it. So hope this thing's making sense to all of you, that how you can define the boolean, how you can take this unt, and unt only stand for positive number, no negative, and that's the important point you have to keep in mind. Okay, now let's come here, and the second data type we're going to take is, it's also a number, but in case of negative. Okay, so because sometimes we need a negative number in our smart contract to do certain calculation. Okay, so for that we have int number. So we have, let's say, negative number are allowed from int type. Okay, so this is the type we're going to use if we want to add a negative number. Okay, and let's talk about the range, that what are the range we have in this as well. So again, it will have the same range. You can define 256, and the range lies between -2, and it will go to 255, and you have to do this -1. Okay, so this is the range you will have from the negative to the plus. Okay, so if you want to do the calculations, simply remove this one and copy and come back here and paste here. So this is the positive, and the same way this is the negative. All you have to do is to add the minus negative sign. So you can go in the negative till here, and you can go positive till here. Okay, in this 256. So that's the important point you have to keep in mind, because this is the question, 1 marks question you will get in your exam. Okay, so that's what we have here. That's the range. Now that's the one type. Let's replicate this, and if we make it to 128, so same thing we have to do here. We have to make the changes to 128, and the range will automatically lie in between that range. Okay, so this is how you can define multiple range, whether in negative and positive. And now let's take this real application. So we'll take an example. We'll say -1, and we'll say this value, and again we'll take another one. Okay, so this is the 3 int variable level we have taken, minus and plus. Okay, and we have to make it this I. Okay, I, otherwise it will throw an error. So this looks pretty fine. Now let's come here, deploy the contract one more time, and if you can see here, we have a lot of things. So if I click on this UA8, so this is what I have here. We have I. You can see I can easily able to go back in negative because of this int. But if I do the same thing with the unt, I'll get an error. Okay, if I click on this, I can go into a negative. If I click on this, I go into positive as well. Okay, so that's how we can use negative and positive number with the help of int and unt. So that's how we can define. Let's come here. Now let's talk about min and max value in number. Okay, so there is a simple way which you can use to find out the minimum and maximum value of a number. Okay, so that's, we have operator for that. So let's come here. We're going to take this variable int public min int, and here we have to define the type. So the type we're going to take int, and we'll call this min. Okay, so this will give the minimum number of a integer, and this will give us the maximum number. All you have to do max, and here we have to change max. Okay, and sometimes this becomes very helpful, because if we want to do certain calculations and we want to prevent the condition of overflow and underflow, in such scenario we can explicitly define that we don't want a number which can exceed this limit. Okay, so in such scenario you can take this one. Okay, so this is the why we have simply deploy the contract one more time, and let's have a look. If we come here, you can see here we have the 4 functions. Hey, let's call this max, and you can see this is the max number you can take in this 256. Okay, if you define only in, that will take this 256 range. Okay, so this is the range. If you do this minimum, you will have the minus signs, but the rest is same. Okay, so this is how you will get the maximum and minimum number in Solidity smart contract with the help of this function. Okay, so hope this makes sense. Comment this out to all of you guys. And now let's talk about a couple of more examples. So the second data type we have is the array. Okay, and just like other programming language like C, Python and JavaScript, we have array. We also have array in Solidity smart contract. So let me give this command. In Solidity, the data types bytes represent an sequence of bytes, and generally they are 2 types. Okay, so there is no difference between a byte and a string. Okay, byte is more gas efficiency, so when you will use byte instead of string, it will save you gas at the time of deployment. Okay, so you can take a array as a byte, or you can take a array as a string or as a number. Okay, it's totally up to you. Okay, so now let's come here. Here we have this fixed size bytes array. Okay,
and the other one we have is dynamic size byte array. Okay, so these are the two types of array we have. One is the fixed size, which you will define explicitly that you want only 5 arrays in that particular array. Okay, or it could be a dynamic based on the function. Okay, so these are the two types of data type array we have. So that's the array. Now let me do this command. So when you define byte, okay, in smart contract, it's represent dynamic bytes. Okay, so that's the only thing you have to keep in mind. That, but if you want to explicitly define that you want only fixed size array, then you have to set the number. Okay, we're going to cover everything about this array as well in the later video. Okay, so I'll take byte 1, and by default I will don't add anything, and this will become byte B. Okay, simply deploy the contract, and let's try to have a look. Here you have these two functions. Okay, so let's simply comment this one, and I make it public so I can able to access the data. So let's make it public. I'll say public, and this will become also public, and let's try to have a look what we have inside this. Let's deploy the contract, and here we have that calling this function, and you can see this is how the byte data will represent. Okay, it will start with 0x, and then it will have the data. Okay, if you call this, it will have this data. So this is the default value. Now what if I want to add value into my byte data? You can do it very easily. Okay, so simply comment this out, and I'm going to replicate it, and I'm going to assign predefined value. So I'll take this. Okay, because this is the data, this is how I have to add the data. Start with 0x, which represent the byte. Okay, and then you can add the data whatever you want. Okay, so let's define this as well, and simply comment this portion, and now let's simply deploy the contract and make the call. If you call it, you can see here we got the data. Okay, and this one is more memory efficient. Okay, so instead of string, we're going to use this byte a lot in our future smart contract. Okay, you all know that computer can understand only binary code. Okay, so this is how this code will represent. Okay, so we'll start with 1010, and this is so on. Okay, and if you want to know about this binary code, you can simply do Google, and you can easily able to find and learn more about it. Okay, so this is how it will represent in the Ethereum virtual machine. Okay, so that's the byte code we have, looking fine. And now let's have a look to the other data type we have. So the other we have is address. Okay, so we'll come here and we'll take this address public, hey, and we'll take this address public, and we'll assign the address. Okay, so I'll come here and I'll go back to this. Here I have the address, so I can simply copy, and I want to show you the difference that when you have an address and when you don't have the address. So I will go to simply pass it without code. Okay, so it's a Solidity programming language in that you don't need to pass this address into a string. You just pass it like this. Okay, so that's the addresses we have. Now what we can do is simply deploy the contract, deploy on, and here we have the transaction. If I click on this adder, you will see that this is the address which we have defined here in the contract, but by default we don't have anything here. Okay, so this is how the address will represent when there is no address. Okay, so this is how it will look. Hope things are making sense to all of you guys, understanding that what we are doing exactly. I'm just going a little faster because these are the basic things, and we're going to get into more detail when we have a dedicated session on each of these data type and when we use in the function. Okay, so simply comment this out, and what I can do, and now let's check the default value of each of this data type, because in Solidity there is no concept of null and undefined. Okay, so what are the predefined data we'll get when we'll use any one of these data types? So let's have a look on that. So I'll say default value, I'll first take the boolean, and the default value is going to be false. Okay, let's say false. We'll take another unt, and its default value is going to be, let's say, 0. Okay, this will default value 0, and we'll take the int, it will also become 0, because this is the default value we have for the number. There is no concept of null and undefined. Okay, if you don't provide anything, you will have 0. And let's take the address. So this is what we'll get, 0000 with this. Okay, that these are the default value we have for each of these data type. Same goes for the array, byte size, same goes for that. Okay, but these are the most common used data types, and that's why I'm covering this one as well. Now let's come here, upload this, and let's look at this. If I click on this false, here we have the false. If we click on this unt 0, we have 0. If we click on hey, here this is the address. By default address we get this 00, and the last one we have this number is a 0. Okay, so hope these things make sense to all of you guys. Whatever we have covered, you have to keep all this thing in mind, because these are the things going to be asked in your interview session, that what type of arrays we have, what is the difference between bytes, and what is the difference between string, which one will save more gas fee. If you want to take a number into a negative, then what data type you're going to use.
what are the range of certain units, int or unt. So these are the important things you have to keep in mind, that what it does and how you can utilize it in your smart contract. Right now we have covered about this data type, and we have talked about the unt and int variable. So you must know that why these ranges are important and what kind of problem it will create in our smart contract if we don't use that particular way. If we want to optimize our smart contract for paying the less gas fee, then how we can utilize it in a more efficient way, this in variable. Okay, so these are the things you have to keep in mind to write a well optimized smart contract. Okay, so that's the only thing I want to cover. Hope you guys have found this video valuable about this data type. Let's move to the next video. So when you will ask in an interview that what is the role of the function in the Solidity smart contract, so this is how you have to answer this question. Okay, a function is basically a group of code that can be reused anywhere in the program, which generally save the excessive use of memory and decrease the runtime of the program. So creating a function reduces the need of writing the same code over and over again. With the help of the function, a program can be divided into a small piece of code for a better understanding. Okay, so this is the explanation you can provide to your interviewer, the person who's taking your interview. Now they might be asking you that what kind of function we have in Solidity smart contract. So there is one function, declarative function, and there is a non-declarative function. So this is the code snippet for the function we have. So we have the function keyword, then we have the name of the function, and inside that we can easily able to pass multiple parameters. It's totally up to you that what you want to do with the function. Then we have the scope, that whether you want to make it public, external, internal. Then we have a return keyword, and if you can add multiple parameters like this here. Okay, and there are a couple of more function we have in Solidity programming, like we have modifying state variable. Okay, we have events, we have creating other contract, we are using self-destruct, sending ether via calls, calling function with mark pure and view. Okay, so these are the couple of function you can create, and there is a lot of things you can do with a function. Okay, so that's the general overview I want to give you about the function in Solidity, and let's try to have a look in practical way. Okay, so here we are back into a remix ID. So let's create a contract. So I'll call it learn function. Okay, right now I'm just giving you basic examples of function, but we're going to have a detailed discussion when we write actual real world smart contract. You will see that how life-saving it is. Okay, so here we'll take a variable called unt, and I'll say public, and I will say hey. So initially I don't want to assign any value to this, but I want to do it with the help of function. Okay, so get data with the help of function. Okay, so I want to check the function. So right now I'm using this function to check the data of this unt. Okay, so I'll take get info and public, view, and return. Okay, so the reason why I have used this view keyword, because I want to look at the state variable, and the return, you can pass multiple parameter in the function, and I want to return this unt 256. Okay, and now I want to simply return this data. Okay, hey. So this is the simple function which allow me to see the data of the state variable. Okay, that's the simple function we have. And this function can be more complex. You can have function inside another function which can check certain condition. Okay, we're going to do all that, but just have a look that how you can write a simple function which can do a simple thing. Okay, so let's delete this one. Let's try to deploy the contract, and let's try to have a look. So here we have this hey and get info. Okay, so if I click on this get, so before I do that, click on this get info, I can see 0 we have here. If I call this simple get info, I'll get this 0. Okay, so this is how we can retrieve the data. Now simply come here and let's replicate this, and let's delete this, and this time I don't want to make it public. Okay, deploy this one, and you can see right now we have this get info. If I click, I can easily able to see the data of this. Okay, so it's looking fine. So hope this making sense. This is how you can retrieve the data of the state variable with the help of function. Now let's write one more function which allow us to update the data. Okay, so we'll say update data. In that we're going to pass the data which we want to update, public. Okay, so this time we try to change the data, change the state variable. That's why we haven't added this any view or return statement. You can return that statement, but I'm not going to return it, because why should we should do that? Okay, because I just want to focus one thing at a time. Okay, so let's update the data. So that's what we have. We can take hey, and we're going to update it. Okay, so this is how we can update the data with the help of function. So let's come here, click on this, and let's try to deploy the contract. Okay, and here I have to check the data. So right now we have 0, and now we have to update the data. So in this we go to pass the value. So let's pass 6. Click on this transaction, hit enter. You can see here we got 6. No matter what value you will add, it will keep adding and updating the data. Okay, so that looks pretty fine. Let's keep updating the data. Okay, so that's how you can use a function to update the data. You can see keep updating, keep updating. So this is the updating we have, and let's write one more function which we'll call get unt a plus b, because we want to do some operations. Okay, so we're going to take a two number and we're going to sum it together and we're going to add to the state variable, and we can do that as well with the function. Okay, so we'll have this view return unt. Okay, so what I will do, I will take this two number, so new number, and this will come a plus b, and I want to simply return this number, new number. Okay, so what I'm doing, I'm taking this two number from the users and I'm summing up together and I'm returning back. Okay, so that's what I'm doing. Simply comment this, and now let's deploy the contract. Hit enter, open up this. Here you can see, here I have to pass this two number, so the number I want to pass is 5 and 6. Call this transaction. Here you can see, here I got the output to 11 because of the return keyword I have used. So you can perform this kind of mathematical calculations, a lot of things you can do. Okay, it will keep updating. Okay, so this is the one example for simple using function to do some calculation within the function. Okay, so hope this makes sense to all of you, that how things are happening. Now what I want to do is, let's come here. We're going to take this hey, because that's the state variable we have, and I want to update that data as well. So, okay, so we're going to say new number. Okay, and I don't want to return this, I want to return this hey. But as you can see here, I'm getting this error because I have used view keyword, and view keyword is not allowed when you are changing the state variable. Okay, we have a detailed discussion on this view keyword, okay, as well. So what I will do, I will simply come here, I'm going to remove this view, and now the error is gone, and now we can easily able to change the data. Okay, let's hit on deploy, go back to the transactions, and you can see if we pass this two data, let's 4 7, hit enter, and if I open up the terminal, you can see the logs there. So let's come here and simply come here and make it this public, so we can easily able to see, have a getter function, so we can check the value as well. So let's bring this terminal down and let's redeploy the contract. Okay, delete this one, deploy the contract one more time, and we have to pass this. Here you can see right this moment we have hey is to 0, and if we pass this two number, hit enter, and here you can see we got, right now you can see this is the log we got. So this is the two number we have put, and the output we got is 8. Okay, so this is the output we got, 8. Okay, this is the function we have called. If you click on this hey, you will get the 8 as well. Okay, so this is how you can perform operations in the functions and update the state variables. Okay, so hope this makes sense to all of you, that how you can create function in the smart contract. Again, I'm telling you, we're going to have a detailed discussion on each of these topics. Okay, and now let me show you that how the ABI would look like of this function. Okay, because whenever you will deploy the contract, it will generate the ABI based on the variables, based on the data types function you have defined. Okay, and that ABI is very important because that's the ABI is going to be run on the Ethereum blockchain. Okay, so let's copy that ABI and let's simply paste here, and here you can see we have all this data. We have all this abstraction in terms of ABI of the smart contract. Okay, so we have this input, in that we have this data type, and the name of the name is A. So this is the one we are passing, A. We have the another one which is a UID type. We have B. You can see we have B, and here we have the get function. Okay, so we have the name of the function. You can see here we have the portion we want to return as an output. So we want to return the UNT, so the result. Okay, that's what we want to result, and here you can see we have this, that's UNT. Okay, and here you can see we have this non-payable, because this smart contract is not receiving any kind of fund, so that's why the state is changed to non-payable. Okay, and we have the type function. Okay, and here you can able to find the state variable we have defined hey, and we have all this calculation. Okay, so this is how ABI will get generated whenever you deploy a smart contract, and this is what exactly run on the blockchain. Hope this thing's making sense to all of you guys. You guys understand that what we are doing exactly. Okay, so let's close this one and simply remove this one because we don't need that one. So that's, if I copy this bytecode, you will find the same bytecodes. Okay, so this is the bytecode we have, all the data. So this is what we have. You can easily able to decode this, simply remove this one, and that's the only thing I want to cover about the function. Okay, so I hope you guys have understood the basic concept, that what are the things you can do with the help of the functions. There's a lot of things you can do. You can build condition, build logic, which can automatically do certain of things for getting the data, for calling certain function, for transferring. You can do a lot of things. Okay, and we're going to do that in a practical way when we build the real world application using smart contract. Okay, so hope you guys have found this video valuable. If you have still any question and doubt, do leave in the comment section. I'll try to help you in that. And if you're new to my channel, hit like and subscribe. That will motivate me a lot. So but that's it, I'm ending this video. Let's move to the next video. In the last video, we learned about the functions in Solidity, and we have discussed a couple of important concepts which you have to keep in mind when you write your smart contract. In this video, we're going to learn about the state variable in Solidity, that how we can create, what are the way to update the state variable data. Okay, so that's all we're going to do in this video. So here I've opened my Remix ID. Make sure to do that. So the very first thing I want to do is I want to create a contract, and I'll call it state variable. Okay, and here I'm going to leave a couple of comments, so you guys have to keep few things in mind about the state variable. Okay, so that's the comments I have given. Now I'm going to define a couple of state variables to show you. So first thing, I'm going to take a string public, and I'll call it my state. I will take another one, this will become my num, and I will take another one. String is going to be, let's say, default text, and I'll say hey the default text, and I will take a number public, and this will say default num, and I will assign initial value is going to be 5, and I have to change this one to num. Okay, unt256. Here I have taken 4 state variable. The first 2 state variable doesn't have their value, but the second they do have. Okay, so let me save it and let me try to compile it, and let me show you what we get. So if I deploy, and if I open this my deploy contract, here you can see currently I have 0 ether into this contract. Okay, so that's why you can see the balance is 0, and here I have all these function, and the reason I got this function because I have used the public keyword, which I have already explained in the previous video. Okay, so right now you can see I have 5 in this, and that because of this default value I have assigned, I have my default text as well. You can see if I click, I got this default text, but if I click on this, I get 0, and if I click on this, I get empty string. Okay, I don't have anything in that. So that's how you can define your state variable in your smart contract, and the state variable will always come on top. Okay, so you have given the name of your contract, and below that whatever you define, that's your state variable. Okay, so right now we have taken 2 data types. One is number and the second one is a string, but we have other data type as well. So let's take a byte. Okay, and this byte is similar to a string. Okay, so when you use byte in your contract, it will allow you to save gas fee. Okay, it will allow you to save gas fee. So I'll make it public, and I will say default byte, and if I pass anything in here, you will see the output I will get. You will see the output. Okay, so the output I will get, let me deploy the contract and let me show you what I want to highlight here. So here you can see, here I have the function. If I call on this, if I call this default byte, you can see this is the number, this is the exactly output I'm getting, because this string is converted into a byte because we have used the data type to byte, and because of this it's more memory efficient. We have to pay less gas fee for this. Okay, so that's the thing you have to keep in mind. So whenever you pass whether hardcode data or whether you take from the user as an input, the data will represent in something like this in a byte. Okay, the data we have here. Okay, so let's simply replicate it, and let's try to have a look on the default value. If we don't assign anything, what we'll get as an output. Okay, so let me redeploy the contract and let's try to have a look. Okay, so let's change the name to num, and let's try to deploy the contract one more time. And if I come here, if I call this, right now you can see we don't have any data assigned to this default byte. Okay, number. So this is how it will represent. It will start with 0x, and then the number of alphabet you will have, it will take that binary code. Okay, so hope this makes sense to all of you guys. So this is how the byte data represent as a state variable. So these are the things you have to keep in mind. So this is the way you can define your state variable. You can keep as many data as you want. You can take array, you can take boolean, you can take unt array. So there are tons of things you can do. Now let's come here, and now what I want to do is I'm going to take another variable array. Okay, so you, as I told you, that you can take an array as well. So this is commented this out. If I come here and try to redeploy the contract, and the output I will get, you can see I'll get nothing. Okay, because I haven't made public, so I have to make it public so I can access this. Let's replicate this and let's make it public, and let's redeploy the contract, and boom, and here you can see that I got this my number. So currently we don't have any data into this array. Okay, so if we do have any data into this array, we can easily pass the index and we can easily able to have the output. Okay, so that's how you can define array. If you call this, nothing will happen. Okay, so this is how you can define array as well. So this is all the state variable, and this is how you define in your contract. And now I want to update the state variable data. So right now you can see this is the 2 state variable we have
string and number, but we haven't assigned any value to that. But we're going to do it right now with the help of constructor. Okay, we have a detailed discussion on this constructor keyword. Okay, constructor keyword, sorry. Okay, so just focus for the time being that there are multiple way you can update the data of your state variable. Okay, so currently it's empty. Here I'm going to take this constructor, and in that I'm going to pass this two data. Okay, so I have to pass the string, I have to pass the number, so I can assign that number to my state variable, and this is how we can do it. Okay, so I'll copy here and I will pass that, because first thing is a string, so I have to give the name of that data type string, and in Solidity you have to define the data type explicitly. Okay, you have to say that what data type you want to take, and here I'm going to use it memory. Again, this memory keyword has a detailed discussion, it has its own topic. Okay, so that's why I'm not covering it, just use it. And then I'm going to call this anything. Okay, and this is a general convention in the smart contract. So whenever you take any data from the user or as an input, this is how you denote slash and whatever name you can give to that. Okay, so I'll call it text, and I would call the number as well num. Okay, so this is our constructor. Whatever data we'll get from the constructor, we're going to assign the data to our state variable. Okay, that's pretty simple. So this is how you can update the data with the help of constructor, and this is what we follow when you will create ERC20 token. So at that point of time, you're going to define your name of the token, and you're going to define that how many token supply you want, and this is how you're going to do it. Okay, so let's try to update that. So let's come here. So this is the data we have. Let's come here and let's try to deploy the contract, and here we have to pass the text, and we have to pass the number. So I'll call it, let's say, hey dollar, and here I want to say 6. Hit on transaction, and if I come here I have my logs. Okay, if I click on my number, you can see I got 6, and if I call my state, I got this hey dollar. So this is the another way which you can use to update your state variable. Okay, so let me comment this out, and now let's talk about the third way which you can use to update your state variable. Okay, with the help of function. Okay, so let's come here, let's create a function. So I'll create a function, I'll call it update, and the same thing I have to do is I have to pass the same data type. Okay, same convention I have to follow here. I will make it public, and again there is a detailed discussion about this public keyword, that why we use, and we have a detailed discussion about this public keyword, what is public, what is external, what is internal. Okay, just follow along with me. So what I will do now, I will simply take the data, my state, and I'm going to update it. Same logic I have to follow here, simply copy and paste here. So our function is ready to update our state variable. Okay, so now let's deploy the contract. So let's come here, and I'm going to select the contract, and I'm going to click on this deploy, and here we have the deployed contract. Right now you can see we have nothing in this two, my num and my state, and here I have to update the data. So I'll call here inside the function, and now I'm going to pass the data which I want to update. So I'll say is and 2. Okay, hit enter. Now you can see the data is updated. So this is the another way you can use to update your state variable, and that's the only thing you have to know about the state variable, that how you can define the state variable in your contract, what are the ways you can use to update the data of your state variable. Okay, we're going to get into more details when we'll build the actual project ahead. I just want to have you a basic graph idea that how state variable work and what are the way you can act with. Okay, so we are done with this entirely. Okay, hope this entire thing makes sense to all of you guys. You have understood that what are this. So with that, I'm ending this video. Let's move to the next video where we're going to talk about the local variables in Solidity. In the last video we learned about the state variable. In this video we're going to talk about the local variables in Solidity smart contract. Okay, so I have opened my Remix ID, make sure to do that, and let me give this comment local variables, and let's create a contract by the name local variable. Okay, we are following the general convention. Okay, not a big deal, and here we're going to define couple of variable as a state variable. Okay, so when you define variable here after the contract, it's called state variable, and that's the thing you have to keep in mind. Okay, so it will become public, and I will call it number. Okay, right now I'm not assigning any value to this state variable. Okay, so we have our state variable, and now I'm going to create a function. So I'll call it function for local variable, and now here I'm going to define the function. I'll call it local public. Here you have to keep few things in mind. Whatever variables you will define inside a function, they are called local variables. You can define as many as you want, and you can use them to build different logic, to perform different calculations. So those variables can only execute when the function is get called, and they're not going to store on the blockchain. It's used locally in a memory. Okay, so all the variables which you will define as a state variable, those are the variables going to store on the blockchain, and those will keep the actual data. But those variables you will define inside the function, they're going to use in the function and act as a memory. Okay, it will not store on the blockchain, but it will store in the memory. So that's the few thing, that's the thing you have to keep in mind. So I'll say not stored on the blockchain. So you guys can understood that the variables we'll define here, it will not store on the blockchain. And here I'm going to define a variable. I'll take a unt. I'll define a variable unt I, and I'll say I is equal to 345. Okay, that's the simple one. And here I'm getting some sort of notification. Okay, so let's come here, let's delete this one, let's try to deploy the contract. Click on this, and here the contract is got deployed. Here I have my number. If I click on this, currently I have 0 because nothing in there. But if I have this function, I click on this function, and here you can see nothing is happening. I want to return this. Okay, so I have to make this view. I'll simply call it pure because we have a detailed discussion about this view and pure. Okay, so I'm not explaining right now this because I don't want to make things complicated to all of you guys. Okay, so just use pure, and here I'm going to use return. And what I want to return, I want to return number. Okay, so I will take this unt, and this is how you define return. Okay, and here what I will say, here I will come and I will simply say return, and I'm going to call this I. Okay, so in this way I can easily able to have the output from this function. So let's save it, and let's try to deploy the contract one more time. And if I click on deploy, if I click on this, here you can see I have 0. If I click on local, and I have the output. Okay, so this is how I can easily able to use the local variable to perform certain tasks. Okay, so this is the one way to define your local variables, but I want to do something. Okay, so right now you can see this is the state, this is the local variable I have, and I have my state variable which is an empty. So what if I want to make certain calculation, and the output I get, I want to assign that value to my state variable? Okay, we can do that. Definitely we can do that with the help of our local variables. Okay, so what I can do, I want to update that. So let's come here. Here I'm going to call that my number, and I want to update it to I, and here I want to have the output as my number. So here you can see, here I'm making the change in my state variable. Okay, because the previously the state variable is 0, empty, but here I'm, with the help of this function, I'm changing the state variable data. Okay, so I have to remove this from view. Okay, actually we don't need to use view because we are making change. View is only used to read the data from the state variable. Okay, so we have to remove this view because we are not reading, we are making change in our state variable. Now save it, and let's try to redeploy the contract. Click on this deploy, and here we have the contract. Okay, so if I click on this local, you can see right now I have this 0, but I have to call this function. If I call this function, if I call this, here you can see this is how we can update the data. So let me repeat what we have done, because this is the very important thing which you have to know, because when you will work on an actual smart contract, this is the thing goes over and over again. Okay, so inside the function we have created a variable by the name I, and that variable I, we are assigning that local variable, we are assigning to our state variable. That's the only thing we are doing here, and because of that everything's working fine. Okay, so that's working fine. So I hope you guys have understood that how you can use this function. And if you come to the logs, if I call this function, and if I come here, you can see this is the entire log I have got for this transaction. So this is the account which I have to do it, and the function I have called, and you can see this is the output I have got from this function. Okay, if I call it one more time, open it, this is the output I have got. Okay, so this is pretty simple. Hope you guys have understood that how you can define local variables, how you can use it, local variable, to perform certain calculation to update this state variable. Okay, so that's our local variable. Let's have a couple of more examples. So I'll say I plus plus. Okay, so what I'm doing inside that, I have defined the I value is 345, but further I'm trying to update that as well. Okay, so I'm adding 45 to that, and I will take this address, and I want to take the address one. Okay, so this is what I'm doing. So let's come here, let's define the address data type here, and now I have to make the output. Okay, so I'll say address, I want to take the number, and I want this I remove this one, and here I have to define that what are the data I'm just returning. So here I have to come, and here I have to define everything. So I will address, and I want this number. Okay, so that's the 3 thing we are returning. So we have to define explicitly that these are the 3 data type we are returning. Okay, and now we can click on this, click on deploy, and here we have, if we click on my number, still we have 0. If we click on this local, and here you can see we got the output. Okay, so this is the one we have right now. We have seen this is looking good, and here you can see in the log, you can see we got the address account 1, we got the unt 45, and we got the 390. Okay, it's coming in the form of object, so we can easily able to fetch this data and display on our application. Okay,
So that's how things are looking fine. Okay, let's bring this down. So that's all about the functions and how you can create local variables and perform different tasks. Okay, and how you can use local variables to update the state variable. Okay, with that, I'm ending this video. Let's move to the next video. In the last video, we learned about the local variables. In this video, we're going to talk about the global variables. That what are the global variables we have access in our smart contract, so we can utilize it. Okay, so the same thing we have to do. Let me give this comment: local variable. We're going to build a contract. We'll call it local variable, and here I'm going to define all the variables which we have access as a global variable. Okay, so let's start with the first one. I'll say address, public, and honor. Okay, so let's start with the honor first. So here I'm going to build the constructor, and this honor will get updated. So I'll say honor equal to message.sender. So what I'm doing here, message.sender is a global variable, and how it's work, whoever will deploy this contract became the message.sender. So we are saying that whoever is deploying the contract take the account address and assign it to the honor. That's what we are doing. Okay, so let me show you practically. Let's come here and let me remove this one. Simply click on this deploy and let's call it honor. So this is the account which I have used to deploy the contract. Simply copy and simply paste here. Okay, and let's come up here. Here I have my first account which I'm connected with, and I'm going to paste it here. Okay, you will find both the accounts are same. Okay, so in this way you can easily able to access the message.sender, means the one who deployed the contract. Okay, so this is the one global variable we have. Now let's talk about all the other global variable we have in our smart contract in Solidity. Okay, so we have this block hash, we have difficulty, we have gas limit, number, timestamp, value, now on, and we have this origin, gas price, call data, first for. Okay, so these are the couple of variables I have taken, so I can show you that what are the global variables we have access to. Okay, so these are the variables I have taken. Now let's try to access. Okay, so here we're going to do in the contract. You can use it in the functions, but here I want to get it in the contract. Okay, let's deploy the contract and let's try to have a look. So if we deploy the contract, you can see here we got that, and here you can see we have empty, nothing in there. Okay, all of these fields have empty. Okay, nothing in there, and now we have to simply update all this data in our constructor. Okay, so let's do it very quickly. So here we have the block coin base. Okay, we have difficulty, we have gas limit, timestamp, gas price, origin, data, sign, value, and we now. Okay, so all the data is available in this block. So whenever any transaction will happen, it will contain all this metadata. Okay, so we can easily able to access the origin, the data, sign, timestamp, number, gas limit, difficulty, coin base. Okay, so now what I can do, let's try to deploy the contract. Okay, you can see we have all this, and you're going to use a lot whenever you want to build any logic about the smart contract. Okay, just imagine that you have to build a contract which can take a token from the user and it will keep it for a week or for 2 weeks, and then it will send back to the user with some extra reward. Okay, so if you want to build that kind of smart contract, then these are the property you need a lot. Okay, so we have this. Now let's try to deploy the contract. Click on this deploy, and here we got it. And now if you click on any one of these, you will have access to the data. So this is the call data. Okay, right now we don't have any data, that's why it says this way. Okay, if we click on this difficulty, this is the difficulty, we got it. If we call this first 4, okay, it will give you the first 4 of the buy data. Okay, so that's why you can see in that way. If you click on this gas limit, gas price, block, now 0, number. Okay, so this is number 21 number block. Okay, origin, this is the honor. Both origin and honor has the same address. Okay, timestamp we have, and we have value to 0. Okay, so hope things are making sense to all of you, and you guys know that how many data, how many global variables do we have access in our contract and how we can utilize it. Okay, so these are the important things you have to keep in mind when you build your smart contract. So hope you guys have found this video valuable. If you have still any question and doubt, do leave in the comment section. And that's the only thing I want to cover about this global variable, that how you can access in your smart contract. With that said, let's move to the next video. In the last video, we have learned about the global variable in Solidity, that what type of global variable we have, how we can update it, and how we can access in constructor and in function. So if you haven't watched, I'll link in the I button or in the description so you guys can follow that. In this video, we'll learn about the view keyword in Solidity, that why you should use view keyword. You guys have already seen a couple of examples in the previous video, but in this video we'll try to understand even in deeper level. Okay, so here I've opened my remix ID, make sure to do that. And here I'm going to provide this comment view, okay, and I will create a contract. I will call, let's say, view, and here I'm going to define a couple of state variables. So I'll take a unt and I will define 2 predefined value and number 2. Okay, so they have taken 2 state variable and I have assigned value to that. Okay, so now let's write a function so we can check the state variable value. Okay, so let me give this comment using view to check the state variable. Okay, let's write the function and I call get result. I'll make it public, and again we have a detailed discussion about this public keyword, and this is how you define view keyword. Okay, view keyword, okay, view and result, and here we have to provide the data type which we want to return. That's the general convention. So we want to return unt, okay, unt, because we want to return 2 unt. Okay, and with this function what we are trying to do is we are trying to access the state variable which we have defined and to see that what value we have here. Okay, so here what we're going to do, we're going to return this, and we want to return this num1 and num2. Okay, so that's the simple function we have written, and we have used this view keyword. I will show you that when you will not use the view keyword, what error message you will get. Okay, so we have this function, just simply save it and we have compiled it. Okay, and let's make it capital and make it capital. That looks pretty good. And now let's come here and simply delete this one and redeploy the contract, and here we got the contract, and you can see we got this function and we have used this view keyword to access the data of the state variable. So let's click on this, and here you can see we got the data of the state variable. Okay, UA2 and 7. Okay, so that's how you can see the data of the state variable using the keyword view. Okay, now if I comment this and if I create another function, I'll say what if I want to calculate. So this function will allow me to do a certain calculation, and I'm going to use that calculation to have an output, and final output I'm going to assign to my state variable. Okay, so let's follow along with me. So I'll create this get result, and I'll say public view return, and I want to return this unt and product, okay, and unt and total. So this is the one way you can define whatever data you want to return. Okay, so here I'm defining at the function level that this is the product and total I want to return from this function. Okay, so you have multiple way to return unt, and I call num1 20 and num2 30, and I want to sum them. Okay, so I want to return this product, so I will simply say product, and I'm going to multiply 1 and 2. Okay, 1 and 2, and the same thing I'm going to do for the total. I will simply add them. Okay, so that's the simple. I have taken this local variable, okay, and that's what I'm returning from here. Okay, so that looks pretty good. Now if I come here, deploy the contract, and if I click on this deploy, you can see if I call this function here, you can see I got this data. Okay, I got this data. It's looking absolutely fine. Okay, so we can perform internal calculation as well with the use of view keyword. Okay, and this function will not create any impact on the state variable. Okay, you will see in later. Okay, so right now what I want to do, I want to simply use those 2 variables here. So if you can see here I'm getting this error message. Okay, did you mean num1 num2, because we have comment out this one, that's why we are getting it. Now I want to use this 2 variable and I want to update that. So I will say num1 num2, and this one is n, capital N, this one is capital N. So this time what we are trying to do, we are trying to use the state variable. Okay, we want to use that state variable to do certain calculation, so we can use it. Okay, this time we are using state variable, and because of this view keyword we can easily able to access. If we don't provide the view keyword, we can't able to access that state variable. So we have the state variable there, and now if we deploy that, we can easily able to have that output. Okay, you can see now we can easily able to use that state variable. Okay, and that's happening because of this view keyword, and that's such a lifesaver you have. Okay, such a lifesaver you have. Now what I want, if I come here and if I want to update the data further, so the state variable I want to update that with the help of this function. Okay, so I'll take num1, and if I say plus 5 and num2 plus 7, and here you can see I'm getting an error message, because now what I'm doing with this function, that I'm trying to change my state variable. So I have predefined state variables, but with this function I'm trying to update that, and I will get an error. Okay, because I have used view keyword, and view keyword you can only use to see the data of the state variable. you can't do any changes. Okay, you can do the changes in the locally, but you can't do the changes in state variables. Okay, so these are the two variables I have, and here we are trying to update it, you can see, but we are using, if we remove this view keyword, okay, so we'll get an error. Okay, if we simply remove this, and now we'll not get any error. Okay, everything's looking fine. And if you call this function, you can see here we call this function and get a result. You won't get anything here, but you can see in the logs, you can see this is what we got as an output. So we have product 98, we have total 21. Okay, so this is the output we got, and we have successfully updated our state variable as well. Okay, so if I make it public, let's make this public as well, and let's redeploy the contract. If I open it, if I call this function, you can see I have 2 and I have 7, but the moment I will call this function, you can see I have this 7 and I have 14. So I have updated that, so things are looking fine. Okay, the main thing you have to understand here, that if you want to do any changes in the state variable, you can't use the view keyword, you have to write a normal function. But if you want to see the state variable data, you can use the view keyword. Okay, so that's the funda you have to use. If you type view, you will still get an error, so you can simply comment, and everything is okay now. Everything is okay now. So that's the state variable, and let's simply copy and let's make it this, remove this one, the one I want to have a normal return. And if I want to return this product and total, I'll get an error. You can see I'm getting this error because I have to define the data type as well, because earlier I was saying that the data type is product unt and it is product, so I don't need to do define the data type one more type here. Okay, so here I have to define the data type, it's unt and it's unt here, and now I can easily able to return the data from here. Open, call it. If you call this one, this is the data what I get, and things are looking good. I hope these things are making sense to all of you guys, that how you can use the view keyword. The only thing you have to focus, that if you use view keyword to see the value of the state variable, okay, you can't, when you want to do any changes in the state variable, you can't use the view keywords. So that's the important things you have to make for this view keyword. Okay, things are looking good, perfect. So that's the only thing I want to cover in this short video, because I don't want to extend this video too long, because this is a very simple concept which you have to keep in mind while developing your contract. Okay, so with that, I'm ending this video. Let's move to the next video. In the last video, we have learned about the view keyword in Solidity. We have seen a couple of examples that where we can use, how we can use. In this video, we're going to learn about the pure keyword in Solidity, that why we should use pure keyword and in what way we can utilize it. Okay, so here I have opened my remix ID. Make sure to do that to be on my footstep. Okay, so I'll come here, I'll give this comment pure, and I will take a contract pure, and I'm going to define a couple of variables. So I'll say unt num4, unt num2 10. Okay, so these are the two state variable we have. Now let's create a function. I'll say function get data public pure and return, and define the data types, and I want to simply return the num1 num2 which I have defined as a state variable, and it will throw an error. You can see I'm getting this error that I cannot use this function to access the data of the state variable. So to access the data, I have to use this pure view keyword. Okay, so this pure keyword will not work for me. So you can see I'm getting this error, and if I remove this, if I type this view, everything's fine, because view will allow to access the both the state variable and local variable, but pure is only restricted to the local variable, not access to state variable. So that looks pretty good. Now if we deploy the contract, here you can see we getting the data. Okay, if we type pure, we are still getting an error, so you can't access that. Okay, let's take a variable. I'll say num1 30, num2 50, and I want to perform certain calculations. So let's simply have an output, and this will work absolutely fine. Okay, we have taken two variables and we are simply returning from this function. Okay, and this time we are not calling any state variable, but we are using the simple function. Okay, so let's provide this comma, and now things are looking good. If we deploy the contract, and everything's fine, we can easily able to access the data, because this time the data we have defined and try to have an output, those are the local variable, not state variable. Okay, so that's the thing you have to keep in mind. Okay, now we can come down, we can take another product variable num plus, and we have to perform certain calculations. Okay, you can do anything as long as you are using as a view and using a local variables. So, and this time here you can see we try to access the state variable, and again we have used pure, but we can't do that. If we want to access, we can use view keyword, and now everything's fine. Okay, we can use the state variable to perform certain calculation and get an output from the local variables. Okay, that's what you can do. If you type hit enter, get the data, you can see we are getting the data. Things are looking pretty good. If we provide this product and if we provide this total, we'll get an output here. Okay, let's redeploy the contract, and boom, here you can see we got the data, calculated data 500 and 120. So that's the entire logic you have to know about the pure keyword. If I use the pure, I can't able to access, it will throw an error. Okay, you can see we can't able to access that. So the only thing you have to keep in mind that you can use pure when you not accessing any state variable, but when you accessing state variable and both local variable, in such scenario you can use view keyword. Okay, so that's the only thing I want to cover about this pure keyword in Solidity, and I believe that you guys have got a complete understanding that how to use, where to use, and what are the things operation you can perform using this pure keyword. Okay, so let's move to the next video. In the last video we have learned about the pure keyword in Solidity. In this video we're going to build a smart contract for event organization. Okay, so let's start doing that. So I'll call this event ticket, and I will take the contract called event tickets, and I'm going to define couple of state variable here because our ticket will have couple of data. Okay, so I will take a unt public number of ticket. I will have another one, we'll say ticket price, we'll have a ticket amount, we'll have a ticket start time, so when the event will start, and we have to provide the end time as well. We have to provide the tickets timestamp. Okay, so we can easily able to find that when the time is got booked and when to end the event, when to start the event. Okay, so that's why we need to have this timestamp. Now we have to take a one more variable, and here we're going to define a pre-data. Okay, the by your first event ticket. Okay, so these are the couple of state variable we're going to define for our event ticket. Okay, we are writing a very simple, okay, very simple one, and here we have to provide the name. Okay, message. So that's the events state variables. Now we have to build our constructor. We'll take the, let's come here and let's try to deploy this one. If I deploy here, we get the entire instead of the contract. Okay, if you call all of these function, you will get this 0, and we have this pre-data. Okay, nothing in there, and now we have to update this. So we'll use this constructor, and in that we have to pass couple of things. So we have to take this unt, and we have to pass the ticket price, that what price we want to charge for those who want to buy their ticket. Okay, and we'll make this. Now we have to get the ticket price, and we have to update, and we can take the start time, which we'll have in this block timestamp. Okay, at the time of deployment we get the timestamp, we'll get the end time. So we'll simply take this block timestamp, and we're going to add the 7 day. Okay, so it will have a 7 days period in which the users can buy the ticket. Okay, it has 7 days period. So whatever we have learned so far in Solidity, we are only using those concepts. Okay, here we can add hell lot of things and optimize this contract even into the next level. Okay, because we have to do couple of condition checking, we have to do the condition checking that who can call, who to make the honor. Okay, so we are not doing anything like that because we haven't covered those topic in the Solidity course. So whatever we have covered so far, we are building the smart contract on top of that only. Okay, so we have to make a 7 days period. Now what we're going to do, we'll take this timestamp, and so here we have the timestamp. Let's rename this to time range. Okay, and we have this start end. We'll take this end time minus start time, and we have to convert that into seconds. Okay, so this is the timestamp we have, time range, and this one is called time range, not timestamp. So that's the constructor we have. Now simply deploy the contract, and here in the contract we have to pass the price of the ticket. So we'll say 5, click on deployed, and here you can see if you click on this total amount, we have 0 because no one have bought any ticket, so we have 0 amount. Okay, we have this 5 rupees, we have this time range is 7 days. You can see we have given 7 days time range, 7 days periods, and that's what we got here. If we call this start, we call this number, message, and this is the end date. Okay, things are looking pretty good, And now we have to write the functions so other can buy the ticket. Okay, so let's write the function buy ticket, and it will receive the price, public, anybody can call it, and we have to return something. We have to return the ticket ID number. Okay, and here I'm explicitly saying that I want to return ID, ticket ID. Okay, now I want to simply call this number of ticket, because every time someone will call this function, we have a number of ticket that will get increased. Okay, and every ticket will have a unique ID, and we'll say a total. We have to take the price and we have to add that to the total amount. Now we have to take the ticket ID and we have to call the number of ticket. So that's the simple function we have here, which allow us to take the amount and create a ticket ID and add that amount to our contract total amount. Okay, so that's the simple function. Here we can do a hell lot of things. We can check for the conditions like honor, we can check for the price. Okay, so but those things we are not doing here because that's the topic for the later part, because we haven't learned about the condition checking. Okay, so whatever we have learned so far, we are building the contract on the base of that. Now that's what we have here. Now let's redeploy the contract, and we have to price the price 5 rupees, 5 ether, sorry. Hit enter, and that's what we have here. You can see here we got all the functionality which you can check. Right now we haven't bought any tickets, so you can see number of ticket is 0, but now we can buy it. We can pass the price 5, and if we click call this claw, here you can see we got an output. If you open this one, you can see we got the ticket ID 1. Okay, if you call this now, you will have 1. It's working fine. You can see 5 we got. If we click on this 5, this become 10, so the amount is also increasing in the contract. Okay, and the problem I was telling you, that if someone pass the less than 5, it will also generate the ticket. So you can see it will add the amount here as well. Okay, so we're going to learn about the condition checking as well later, not now, because we are building whatever we have learned so far, we are building on top of that only. So price is this, but we are passing 1. So that's how we can generate a ticket for those who want to attend the event. Okay, so that's the simple contract we have. Now let's write another function, get amount. Okay, so we want to access the total amount which we have in the contract and how many ticket we have bought. Okay, so we can do it. In the last video, in the last video, we have learned about the concept of view keyword. Okay, so you can see how everything is coming together, and we want to return the amount, total amount, and provide another bracket here, and now it's looking good. And now if you deploy, you have to pass just remove all this, because these are the sensitive data which you don't want to make it public. Okay, so let's remove all of this. Things looking good. Now we're going to provide the price, hit enter, and here we can see if you call right now we have this 0, if we call 5, 10. Okay, so this is the very simple event taken contract which we have created on the base of whatever we have learned so far in this Solidity course. Okay, so hope you guys can see that how things are getting together. Okay, we have learned about the global variables and how we can utilizing it. We have learned about the functions, we have learned about the view keywords. You can see everything we are using in this contract. So things are looking pretty impressive. So that's the only thing I want to cover about the small smart contract of ticket event. Hope you guys have learned something new and you are making progress in every single lecture. With that said, I'm ending this video. Let's move to the next video. In the last video, we have built a simple smart contract for an event organization for selling tickets and collecting money. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about the constant keyword in Solidity. And this is very important concept which you have to know, because if you're in a smart contract development, this will save you a lot of money when you will deploy the contract. Okay, so I'll give this comment constants, and I will take a contract and I'll call it constants, and I'm going to define couple of state variable. Okay, so let's take a state address first. I'll make it public and say my address, and this is the address of my first account, so I'm simply pasting here. Okay, if I come here, if I simply deploy this, and if I open my console, you can see here this is the entire transaction log, the hash generation. Okay, this is the execution cost I paid for deploying the contract on the base of this variable, the state variable I have defined. So okay, so what I will do is simply copy this and I will paste here. Okay, I will show you the difference, that why you should use constant for certain variables. So I just want to make it clear one thing, that when you use constant, where the value is constant, it's not going to change. in the context of this contract, you can see this is the address I have defined in the contract, and this address is not going to be changed. All the funds I will receive in this address. Okay, so whenever you have any variables in your smart contract, that's going to be permanent. You can't change those variables. You should define constant. Okay, so this is the amount I'm paying without defining constant, but you will see that when I will define the constant, I'll pay less. So this is how you can define constants. Literally you spell it right, and this is the general convention you follow to define the constant variable in uppercase. So my dash address. Okay, so this is the general convention to define the variables. Now I will simply deploy the contract, and I will show you something. If I deploy it, come back to the logs, and let me have a look to the execution cost, and this time I pay way less. You can see, simply copy and paste it here. You can see there is a lot of difference in the gas which we are paying with constant and without constant. Okay, so that's why you should use constant for those variables which are constant, which are not going to change in the contract. Okay, so that's the simple funda we have here, and now let's write a function to see that what we get. So we'll say get constant public return, and we want to return the address. So we want to simply return this my address. Okay, so the address we have defined with a constant value. Okay, let's come and we'll make it view so we can easily able to see that. Let's deploy the contract, and this is the amount we got. Okay, so we are calling the constant variable with the function, so this is the amount we are paying, 215,450. Now let's comment this one without constant and simply replace this one and deploy and call this function. And here you can see here the amount we are paying, 23,586. Still we are paying high. Okay, so you can see we are saving money when we are calling the function as well. Okay, so it's always good to use constant when you define any variable which not going to change. You can see you are saving a lot of money for your company, and that's the only thing you have to know about the constant. In short, those variable is going to be permanent, not going to change. You should define those variable constant to save money. Okay, and those variables going to be changed, you should just use normal expression. Okay, so that's the only thing I want to say. Hope you guys have learned something new. With that, let's move to the next video. In the last video, we have learned about constant keyword in Solidity, that how we can define to save gas fee. In this video, we're going to learn about if-else statement in Solidity, that how you can write nested if statement and the entire concept. Okay, so here I have opened my Remix ID. Make sure to do that. Let me give this comment if else, and I'm going to create a contract. I'll call it if else. In that, I'm going to define a couple of state variables. So I'll take a unt my 5, and string is going to be, let's say, no. And here I will write a simple function, get public return, and I want to return the string memory. And again, we have a detailed discussion on this memory keyword, don't need to worry about it. And make it, let's say, if. Okay, so here what I want to do is I want to update my state variable with the help of this function using this if else statement. Okay, so here I will receive a number from the user. So I'll say num equal to 5. If it's 5, then I want to update the string to, let's say, hey, the value of num is 5. Okay, else I say not 5. This is a very simple function we have built. What we are doing here, we are taking an input from the user. On the base of that input, we are defining the value, okay, of that string. Okay, simply deploy the contract, and here you can see we have this 3 function. Num is 5 and string is empty. But if I provide this 5, hit enter and call the string, you can see, hey, the value of num is 5. It's got updated. If I type any other number, I'll say not 5. Okay, so this is how if and else statement works in Solidity. It's just like a JavaScript and other programming language. In the same way, you can define if and else statement here as well. Now we can add as many as we want. The third parameter we can also add, and we'll say num is equal to 4 if. Okay, so that's the third argument we can add. We can hit down deploy, and you can simply able to check the data and update it. So 5 to this, call this one. If we provide 4, we'll get this value. If we type 6, we'll get this value. Okay, hit all of. Okay, things are looking pretty good. Hope these things are making sense to all of you guys. Let me comment this out. Let's write down the function shorthand. Okay, so the method I have shown you above, that's a longhand of writing the if and statement, but we have a shorthand method as well called ternary operator. Okay, so we can write that huge code in a smart way as well. Okay, same logic we have to follow here. Memory will say if number is equal to 5, then dollar. Okay, else this. So this is the long way of writing the if and else statement. Now let's write the shorthand. So I'll say num if that is equal to 5. I have to give this question mark because we are using ternary operator. If it's right, then we have to give this string to string, and I can say dollar. Else we can say this nobody. Okay, simple. You can see it's just like a one-liner. You have just simply reduced that 7 to 8 lines of code into one line, and that's called ternary operator. It's just like the way you write in JavaScript, the same way we are doing here. If I deploy the contract, it will work in the same way. Simply pass the number and you get the updates of the data. Okay, so hope these things are making sense to all of you guys. This is the way you can define if and else statement in the contract. Okay, these are the simple if statement we have written. We're going to build more complex as per the contract itself. And that's the only thing I want to cover about this if else statement in Solidity, that how you can define longhand, shorthand, and it's just like a JavaScript. The way you write if else statement in JavaScript, the same thing you do here as well. Okay, so hope you guys have understood that how you can define if else statement in Solidity. With that, I'm ending this video. Let's move to the next one. Hey all of you, hope you guys are great. In this video, we'll learn that how we can create while loop in our Solidity smart contract. As we all know that all the programming language has their own loop. In the same way, we have loop in Solidity programming language. Okay, so we're going to cover one of the loops, which is a while loop in this video. Okay, so here I've opened my Remix ID. Make sure to do that to continue where I am right now. So I'm going to give this command Solidity while loop. I'll create a contract. I'll play while loop, and here I'm going to define the syntax that how it will look. So let me type the syntax, and this is the condition you have to. First you define the while and then conditions, and inside that you have to write the block and the piece of code which you want to execute and check. Okay, so I'm making this comment so you guys can have a reference. Okay, so let me comment this out. So this is the syntax part. Now let's check this in private. So I'm going to create a couple of variables. So first is going to be, let's say, unt array. Okay, so what I will do, I'm going to create a function, and with the help of while loop I'm going to add the number into this array. Okay, so that's what I'm going to do with the help of while loop. I'll take another unt. This will call unt 8, and initial value is going to be 0. Okay, now let's create a function. I'll call it loop public return, and I want to return an array, so memory. Okay, here I'm going to create the while loop. Okay, so I will define the keyword while, and here I'm going to check for the condition. So I'll say if j is less than 5. Okay, because I want to add only 5 elements into my array. Okay, so I will increment the j, and then I'm going to push that j into my array. Okay, that's a very simple logic, and then I'm going to return it. I believe that you guys are familiar with JavaScript, the same structure we have to follow here to push the data into array with the help of while loop. Okay, so here I'm getting an error. It's not a j, it's a k. So let me replace this one, k, and k. So that's the simple while loop we have written. Okay, I believe that you guys have got the idea that how you can use it. And now let's test this out. Okay, so let's deploy the contract. Click deploy, and here you can see the transaction went successful. If you see the logs, it's always very important that whenever you define any loops in your contract, there is a high probability that it will exhaust your gas fee. Okay, so adding loop in your contract, it's never a good idea. Okay, you should always try to avoid loops in your contract. Okay, and you should always compare the gas fees which you are paying when you are running the loop. Okay, so this is the entire execution cost, transaction cost which I have paid. Let's open it and let's try to call this function. Okay, if I call this function, you can see the transaction went successful, and if I open the transaction log, you can see I got 5 arrays into my data. Okay, 1 2 3 4 5. Okay, so right now I have 5 array. Okay, so you have to look at the execution code. You can see it's pretty high, so we should not include loops in our contract. Okay, let's bring this down, and that's the basic example. I don't want to extend this video because that's the only thing you have to know about the loops, that how you can create in your smart contract, and you can check for any conditions Okay, you can check for any condition in your smart contract. So that's how it will look. Hope you guys have got an idea that how the loops work in a smart contract and how you can create your own loop in Solidity programming language. Okay, so that's the only thing I want to cover. Hope you guys have found this video valuable. If you are still question, doubt, to leave in the comment section. With that said, let's move to the next video. Hey all of you, hope you guys are great. So in the last video we learned about the while loop in Solidity smart contract. In this video we're going to learn about do while loop in Solidity. Okay, so I have opened the project in my remix ID. Make sure to do that. Okay, so I'll give this command Solidity do while loop. Okay, let me create the contract and we'll call do while loop, and let me give this command. Let me show you that syntax of this do while loop, that how it will look on a Solidity smart contract. Okay, so first we define the do, and then we have this block, and here we check for the condition. Okay, you can check for any piece of code which you want to execute into this do while loop, and then you define the while, and here you check for the conditions. So that's the structure for creating a do while loop in Solidity smart contract. Okay, so let me simply comment this out, and now let's create a couple of let me type this command syntax, and now let's create the couple of variables. So let me create the unt data array, and we'll create another data type is this. Okay, so I'm going to follow the same logic here which we have covered in the last video, okay, about the while loop. So I'm going to take the same example here. I'll create a function called loop, and we'll say public return, I want to return an array memory, and now I'm going to use this do while loop. Okay, j++ data.push, and I want to simply return that. Okay, here I'm going to check for the condition. If it's j is less than 5, then we have to execute this code, and then we have to return the data. Okay, that's the very simple loop which you can create. Okay, so now it will work fine. So let's come here, let's deploy the contract, and simply open up the terminal and hit on deploy the transaction. When successful, open this, and you can see this is the execution cost we have paid as a gas, pretty high because we have loops in our contract. Okay, we have transactions, we have execution costs, they're pretty high. So now you will see that how much amount we are paying. Or if you click on the loop, this is the transaction we done it, and here you can see still the transaction is really very high. That's why I tell you never include loops in your. So here you can see that we have this execution cost, we have this unt, and that's the simple. Okay, so it's pretty simple with the while loop, and this is the do while loop. Okay, so I hope this makes sense to all of you. Okay, so that's the only thing I want to cover about the do while loop, about the syntax. Okay, so that's why I don't want to extend this video too long, because this is a very simple which I want to highlight the syntax only. Okay, let's move to the next video. So in the last video we have learned about the do while loop in Solidity smart contract. In this video we learn about the for while loop. Okay, so I have opened the project in my remix ID. Make sure to do that. Okay, so let me give this command Solidity for loop. Okay, let me create a contract for loop, and I'm going to type the syntax so you guys can prefer. So first we type the for, and then we have to give the initialize value. Okay, then we have to provide the test the conditions, and then we have to simply add the iteration statement and then we have to add the statement, and that's it. Okay, here you can add the block of codes to check. So that's the general conditions which you have to follow if you really want to create loops in your contract. Okay, so let's come here, let's have a practically look. So I'm going to create a variable, same example I'm going to take here as well. Okay, so I have this data type array, I have this function public return, and I want to return simply an array. Okay, so what I will do, I'm going to create the loop. I'll use this for, and here I will provide my initialize value, which is going to be a unt type. So I'll say I is equal to 0. If I is less than, I'll take for any arbitrary number. Okay, so I'll say if I is less than 5, then I want to increment the I, and I'm going to simply push that I into my data array. Okay, so that's the simple loop, for loop, which you can use to create loops in a smart contract. Okay, so there is so many loops we have here. So that looks pretty fine, and then we have to simply return the entire data. Okay, so that's the simple examples we have here. Let's remove this extra and let's try to have a practically. Okay, let's deploy the contract and let's see the logs. Hit on deploy, and boom, you can see here we have the entire transaction logs, and the gas is always really very high. If you call this loops, you can see it went successful, and you can see still we are paying very high amount of gas fee. We have all this data. It started with 0, 1, 2, 3, and 4. So we have 5 array into our data. So that's how you can create array
I believe that you guys know how to create loops in Solidity Smart Contract. Last video about the loops in Solidity, because we have covered all the 3 loops. The one thing I want to highlight about the loops is that you should try to avoid any type of loop in your smart contract, okay? Because when you include loops in the contract, it increases the possibility of exhausting your gas fee, okay? If you want to use it, the loops in your contract, you can, but you should never add the dynamic data, okay? You should define the definite value, that this is the value which I want to execute, and this range it will follow. Only the loop will follow for this range, okay? It should never be in dynamic. So that's the only thing you have to keep in mind about the loops in Solidity Smart Contract, okay? So that's pretty good, and that's the only thing I want to cover about the loops. Hope this makes sense to all of you guys, and if you have still any confusion, any doubt, we have covered all the 3 loops, okay? With that said, I'm ending this video. Let's move to the next one. In this video, we're going to learn about the required keyword in Solidity Smart Contract, that when you have to use, how you have to use, and what are the conditions you have to follow if you really want to handle error in your smart contract, okay? So let me give this comment. I'll call it Solidity Error Handling, and we're going to use this require statement, okay? All the way we have 3 methods to handle error in our smart contract, okay? But in this we are focusing on the required. In the next video we're going to focus on other keywords, other ways to handle error in our smart contract, okay? So let's create a contract, and we're going to call it required. Inside that we're going to create a function, and we'll say check input, okay? It will take a UNT number from the user, and we have to validate that number. So public view return, and we want to return a string, okay? And here we have to build the condition, okay? We have to use this required statement to check for a condition. So we use the required keyword, and in that we pass condition and message, both thing. So let's build the condition. So whatever input we are getting, if that's greater or equal to 0, then this is the error message we have to display, invalid UNT8. And the second check we are doing, that if input is less or equal to 255, then we have to simply throw this error message, okay? And that's the very important thing which you have to keep in mind, that require statement need 2 arguments. One the condition, and the other one is the result, that message you want to display, okay? So let's provide this bracket. So I'm getting an error, so let's provide this bracket, and that's the check we are doing. If someone provide the valid number, then we want to simply return the string, okay? Input is UNT8, okay? So that's the simple function we have written. We are taking a number, we are doing a couple of check, and then we are passing the string, okay? So let's come here, let's try to deploy this contract, and let's try to have a look what output we get. So here you can see the contract is deployed, and here we have the function check input, and in that we have to pass the number, okay? So let's bring the terminal a little up here. Things looking fine to me. Now let's provide the number, let's call it 5, and here you can see the transaction went successful, and here you can see the input is given 5, and here we got the output string UNT is UNT8, okay? Input is UNT8. So but if I provide something higher number, I'll get the error message. You can see invalid UNT8, okay? And that's the power of the require statement. But you always find the cost you are paying, because your transaction will get reverted back if the condition fail, and you can able to see that how much gas cost you are paying. So here you will find the execution cost. So whenever you write your smart contract, you should always compare with all the statement of error handling, that which one is costing you higher amount, okay? In that you will find the require is the best option to go with, okay? So you can see here we have that entire logic. This is the entire error, the codes you have got. So hope this makes sense to all of you guys. Now let's come here, and let's delete this contract and bring this terminal down, and this is what we have here. And what I can do, so we are doing this check. Let's try to create one more function. We'll say odd, okay? We're going to take the number, view returns, and we want to return boolean this time. We're going to do a comparison, so we'll take the condition. So the input we are getting, if we are doing this remainder, if it's 0, and if we do this, okay? So if this statement is true, then we have to throw this true, okay? So that's the simple logic we have, and that looks pretty good to me. No more problem we have. Let's simply deploy the contract, and here we have it. Simply let's come here, let's try to provide the number. So this time I want to have a remainder, so let's provide 5, and you can see here we got this call to require odd, okay?
We have called the function. If you open, you can see this is the input we have given and the return we have got is true. Okay, because we got a remainder. So that looks pretty fine to me. If you type 2, you can see this will give us false because the condition is failed. Okay, the transaction is reverted. You can see it's false. So you can do hell lot of things. You can do multiple things. Okay, here we are checking for conditions and simply executing the functions. So that's the simple thing you have to keep in mind, that you can do calculations, you can pass argument, you can pass conditions and check the data which you are receiving from the smart contract and any kind of validation you want to do. Okay, so hope this entire things makes sense to all of you, that how you can use the required keyword in your Solidity smart contract to capture the error. Okay, so let's move to the next video, and that we're going to see a couple of more keywords to handle error in our Solidity smart contract. So let's move to that. In the last video we have learned about the required keyword in Solidity, that how we can handle error in our Solidity smart contract. In this video we're going to learn about the one more keyword to handle error. Okay, so let me give this comment assert. Okay, because we're going to use assert. Last time we used the required, but this time we're going to use assert. So let me create a contract. We'll say assert statement. In that I'm going to take a couple of variables, state variable, boolean, result, and I want to create a function. We'll say check overflow. It will have a number. Take two numbers, public. Okay, so we're going to take a 2 input from the user and we're going to perform certain calculation. Okay, so we'll say num1 plus num2, and we want to simply check for the condition. I want to simply say result is true. Okay, so what I'm doing here, I'm taking 2 number, I'm performing the sum, and I'm saying that if sum is less or equal to 255, then result is going to be true. Okay, that's a simple logic we have built here. Let's bring this up and let's try to deploy the contract. And here you can see the contract is deployed. You can see you can easily able to find all the execution cost which you have paid for deploying the contract. Okay, so again I'm telling you, it's very important that you should always compare all the variables which you use, that how much gas it's costing you. Okay, so that looks fine to me, no more problem we have here. Let's open this one, and this is the function we have, and here we have to pass 2 numbers. So I'll say 45 78. Okay, if I save, and you can see this is the 2 number which I have provided, 45 and 78, and the result I got back is where it is. Okay, I'm not returning anything from this function, that's why you can, but you can see the, let's make it public. Okay, let's make it public so we can see. You have the boast option, you can simply return from this function, but I'm not returning. I'll make it public. So let's deploy the contract and let's try to have a look. You can see right now the result is false. Let me provide the number. So I'll say 34 and 67. If I make a request, you can see the result is true now. Okay, so it's working fine because the sum is less than 255. So that looks pretty fine. So I believe that you guys have understood that how you can use this assert in your smart contract for checking for a condition. But here you have noticed one thing, in the required statement we have used the condition and the message, but here in the assert we are using only condition, no message. Okay, so that's the key point you have to keep in mind. Let's bring the terminal down. So that's the simple function we have written. Let's come here, let's create one more function, get result, public view return, and we want to return simply string. We'll say if result is deeply equal to true, then we want to say that return no overflow, else return overflow exist. Okay, so that's the simple logic we have. Simply remove this one, and now let's try to deploy the contract, and contract is deployed, and simply bring it up. Here we have this get result, click on this get result, and here you can see overflow exist. Okay, if we provide the number, so 45 56, hit a request, and you can see right now the result is above. Okay, so say no overflow. Okay, that looks pretty fine. You can see on the base of that we can easily able to check the data. So believe that things are looking good to all of you guys. Now you guys can understand that how you can use this required statement or a asserted statement to handle error, how you can use in different functions and check condition. Okay, so that's the pretty simple thing. That's the only thing you have to know about this assert keyword in Solidity smart contract to handle error. Okay, there's no rocket science there. Okay, it's a simple keyword. You have to know the rules that how you can utilize it, and you can straightaway apply. Okay, so with that I'm ending this video. Let's move to the next video. In that we're going to use one more keyword to handle our error. Okay.
This is where we left in the last video. In the last video, we have learned about the assert keyword to handle error in our smart contract. So in this video, we're going to see one more keyword which is there, which allow you to handle error, okay? And this one is the final one. So let's start working on it. So let me give this command. I'll call it revert handler, okay? I'll create a contract by the name revert statement, because revert is the keyword which allow us to handle error, okay? So we have three error handle keyword like required, assert, and revert, okay? And this one is the least used keyword method, okay? So here what I'm going to do is I'm going to simply create a function. We'll say check overflow, and it will take the unt, two unt types, and we'll say public view return, and we want to return this string, okay? Simple. Now I want to take a variable called sum num1 plus num2. If sum is less than 0 or sum is greater than 255, then I want to simply, let's say, revert this, and I can say overflow exist, okay? Else I want to return this, and I want to say overflow and the exact value. I hope this makes sense. So what I'm doing here, I'm checking for a condition. If the sum is less than 0 or sum is greater than 255, means it's not between this range, okay? Then in such scenario, it's only throw this error message overflow exist, okay? But if the sum is in between the range, then we are sending this message, okay? Simple logic. In this revert keyword, we don't look for any condition, okay? We only pass the error message. So that looks good to me. Now these are the checks we are doing, revert, and we have the error. Let's deploy the contract, bring the terminal up, hit the deploy, and just look at this function. And here we have to pass the two number 34 and 56, and here you can see we got this. You can see no overflow because the range is lies between these, okay? And we get this unt, okay? So everything's looking fine, looks great to me. So that's the simple logic, simple thing. It's pretty simple, but you will notice one thing, that in most of the contract which already out there in the different blockchains, they don't use this revert keywords, okay? Because in that it's limited. You can't able to check for the conditions, okay? Because when you use this revert keyword, in such scenario you have to check the condition based on the if else statement, okay? And that's the unnecessary lot of code you have to add if you go with the revert keyword, okay? So if you use the required keyword in your statement for checking the condition, it make your work very easy, because you have to type the condition and you have to throw the error message, okay? So that's why you will not find in most of the smart contract, they not prefer to use this revert keyword. So that's how it looks. Hope this makes sense. That's the only thing I want to cover. I don't want to extend this video, because this is the concept you have to understand. Don't try to use revert, don't try to use assert, just try to use the required, because in that you can easily able to check for the condition and send the message, or you can simply check the message only or check the condition only, okay? So hope you have found this video valuable. If you have still any question and doubt, do leave in the comment section. With that, let's move to the next video. In this video, you will learn about modifier in Solidity programming language, that how you can define and what kind of benefit it's provide, okay? So here I have opened my remix ID, make sure to do that. So let's come here and let me give this command function modifier, and here I'm going to give a couple of notes to all of you guys, so you guys can have that in mind, okay? Modifier are code that can be run before and after function calls, okay? Generally used for three reasons. The first one we have is the restrictions, okay? So if you want to keep a restriction for anything, for that, validations, and the third one we have is the guard for reentrancy, okay? So this is the three important concept which you have to know for the smart contract developer, okay? That it's help you to restrict any functions, it help you to validate data, it help you to prevent any reentrancy attack, okay? So these are the couple of things you have to keep in mind. Let's come here, let's create a contract. We'll call it function modifier, and here we're going to define a couple of variables. Public honor, we'll say unt public x is equal to 10, okay? So I have taken two state variable. Let's take the third one, public locked, okay? So what I have done, I have taken three state variable. One is honor, the second one is unt type x is 10, and the third one is a boolean type, okay? Three different data types. Let's create a constructor, and in that what I have to do is I have to set the owner message.sender, because I'm going to deploy the contract, so I will be the message.sender. And here I have to create a modifier. Okay, so what I say, modifier only owner. Okay, so what this modifier will do, that wherever you will attach this modifier, only owner of the smart contract can call that function. Okay, so let me show you what I mean by that. So I'll say required message.owner, sorry, sender, and I have to pass this owner. So if message.sender, the one person who's calling the function, if his owner, then only execute, but if it's not the owner, then you have to throw the error message not owner. Okay, so this is the simple modifier we have created, and this is how we have to denote. Okay, so if this statement get true, that dash notation will mean that continue the function further. Okay, execute the other function. So this is the simple modifier we have built. Hope this makes sense to all of you guys. Now let's come here, let's create the second modifier, which is for validating data. Okay, so I have to validate this address, and I'll say that address not equal to the 0 address, and if that's, then I have to throw this error message. Okay, that's the second modifier I have. So we got this 2 modifier, and now we have to continue the function. Okay, now let's create a function. We'll say check owner, we have to pass the address, and I'll say new owner. Okay, so what this function will do, that it will change the ownership of the contract. Okay, and public, I'll say owner only, and validate data. Okay, so here what I'm doing, that I'm calling the 2 modifier I have created as a function. Okay, so I have created this only owner, means only owner of the smart contract can call the function. Okay, so that's the first modifier we have. The second modifier is validate data. Okay, so first only owner will execute. If it's get true, okay, then this function will true execute, then the change owner function will execute. Okay, so this function, okay. Hope this makes sense to all of you. If it does, then we have to simply get this on new owner, and we'll set the owner to new owner. Okay, hope this makes sense. Try to understand that what's going on. You can use this modifier as an abstraction. Just imagine that you have a statement, and the same statement you have to utilize in multiple functions. So you can abstract that as a modifier, and all you have to do is to attach that modifier in every single function wherever you want to do the check. And that's so powerful. This will save you from critical bugs. Okay, it will save you from typing lengthy long smart contract, like too many codes. Okay, so it will save you a lot of time and sort of a lot of bugs. So that looks fine to me. No more error we have. Now what we can do it, so we have the modifiers, we have the change owner functions, and both the modifiers working fine. Now let's come here, let's try to deploy the contract and deploy. And this is the, you can see I got this logged variable is false, honor this, and X is this. Okay, so now what I want, I can come here, I can simply go to the account number 2, and because I want to set him an honor. Okay, so if I copy that, his address, and if I come here and simply, this is the honor, if I paste his, and currently I'm on account number 2, that's the thing you have to keep in mind. So currently I'm on account number 2, so if I call this change honor function, I'll get an error. Okay, because I'm not the honor, account 2 is not the honor, account 1 is the honor. Okay, so our modifier is working fine. I got this error message. So okay, so if I come here, you can see I got this error message from here. If I copy that account address, if I paste and make the change, I can still get that error. Okay, I'm not the owner, so to change I have to come back to my first account, and now I can make an owner. And this time what I'm doing, that I'm making honor my contract. Okay, I'm making the contract honor to itself. Okay, so if I paste and if I hit a request, you can see the transaction went successful, everything's looking good. So this is the address, which is the contract address. So right now nobody can do anything because this contract is the owner of itself. Okay, so this is how you can transfer the ownership of the contract. Okay, if you click on the owner, you can see the owner variable is changed. If you go to no matter what accounts, and if you try to call these functions, you will get an error. Okay, you will get an error that not owner. Okay, because the owner is the contract. What function, no matter what account you call, you will get that error. So hope these things are making sense to all of you guys. You guys have understood that how you can use the modifier as an abstraction, and you can check for a condition, check for the data validations, and you can do a hell lot of things. Okay, so that's the first check. Let's come down, let's create another modifier, and I'll say no reentrancy,
And you guys have already are familiar with this famous attack which happened in most of the smart contract, re-entrancy attack. Okay, and in such scenario, modifiers play a great role. It's a great role. In such scenario, modifiers plays such a great role because it will totally prevent any kind of re-entrancy attack if you use modifier. Okay, there is no chance of having re-entrancy. So let's create a function for that. So here what I want to do is I have to check for a condition. If lock is true, okay, initial value of lock is false. Okay, if it's true, then I have to say that no re-entrancy. This is the error message I want to send, and I want to simply execute the function false. Okay, but if it's not true, then I have to set the true. Okay, then I have to simply continue and I have to say false. So in that way, I'm simply strictly saying that if that's happened, then change the variables and update the data. Okay, so that's the modifier I have here. Now I can use this in my function. So I'll say decrement, it will take a number, public reentrancy. You can see I have called the modifier, and now I have to do simple calculation. I want to simply subtract this x by -1. Okay, every time I call. Okay, so that looks fine. And here I have to check for condition. If I is greater than 1, then I want to simply decrement I plus 1. Okay, simple logic. I hope these things are not making any complicated. Okay, these are the simple JavaScript we are doing, because JavaScript and Solidity both are same. You will find everything is same. So that's the simple smart contract. We are using the modifier, no reentrancy modifier, to check these conditions. Okay, subtracting, checking for the if statement. Let's come here and let's try to deploy the contract. And here you can see, let's come here, and here you can see we get all the functions. Right now x is 10 and all these variables we have. This looks good. Now let's provide this. So if I provide 5, I'll get an error because the value is above 1, and that's why it's throwing this error. Okay, no reentrancy. But if I provide 0, it went successful because it's less than, because 0 is less than 1. Okay, and that's the condition we are checking here. You can see this is the value we have provided, which is less than 1. If I provide 1, if I hit a request, it will went through because 1 equal to 1. You can see this is the value I had. If I provide 2, it will throw me an error. You can see our reentrancy attack is working fine. Sorry, a modifier is working fine. So that's how you can create. The possibilities are endless. You can create many logic around these simple, powerful functions. Okay, so that's the only thing you have to know about this modifier, that this is how you can create an abstraction of the condition which you want to check in every function. Okay, so just imagine that you have a couple of function in your smart contract and you want that owner only if owner can call that functions. So you can add this kind of modifier, so only owner of the contract can have the calling power of the functions. Okay, so hope these things make sense to all of you guys. If you have still any confusion, rewatch the video and leave your comments down below so I can help you. So with that, let's move to the next video. In this video, we're going to learn about constructor in Solidity, that how you can initialize constructor, what is the role of the constructor, and how you can define into the smart contract. So construction is basically an optional function which can only be executed at the time of contract creation. So here I'm using Visual Code Studio to write the example, and later we're going to test this code in the Remix ID. So let's see that. So let me give the license identifier. We have to provide this. Now we have to provide the Solidity version, and here we're going to define the constructor name. So let's create a basic constructor. So we'll have a basic constructor X, and we'll say X, and that I'm going to define a string variable. Then I'm going to define the constructor, and this constructor will take the variables at the time of deployment, so it's memory, and that's how we're going to update our string variable. So this is the very first contract, the X contract. We'll create couple of contract because we want to test that how we can inherit one contract into the another, the properties. So this is the first contract. Let's create the second contract, and this will call contract Y, and again we're going to have a string. It will call text, and we'll define our constructor, and it will take this text, and here we're going to update that text, and we're going to simply close that. So this is the second contract. So we have two contracts, X and Y. So let's write the third contract. There are two ways to initialize parent contract with the parameter. So right now we have two contract and we want to use these contract variables like this text and the string into different contracts. So generally there are two way. So let's have a look on the first way. So here we can come, we'll give this comment pass parameter here in the inheritance list. And the order is very important. The order is very important when you inherit any parent contract into your subcontract. So let's define the contract and it will call B. And here how we initializing. So we are taking the parent contract X and we'll pass the value. So input to X, and the same thing we have to do with the Y. And here we have to simply execute that. That's the only thing you have to do if you really want to inherit the parent contract into the other contract in the children contract. Let's create another contract, and the second way we have is to define in this way. So this is what you have to do: pass the parameter here in the constructor. So we'll say similar to the function modifier we have. So we're going to define the constructor, and it's going to be take this memory string and memory, and this will be our X and Y. And the second way to inherit the parent contract into the subcontract. So the first one is initializing with the value, and the second way we inherit. So make sure there is one important things you have to keep in mind, that order is very important. So first we have defined X, the second contract we have Y, and the same order we are following here. If you build any modifier, which I have already covered in previous videos, so you have seen that this is how we define the modifiers on the constructor, and the same thing we are doing. So this is the C contract, and that's how we can inherit the parent contract. Let's give me this comment. Parent constructors are always called in the order of inheritance. So that's the only thing you have to keep in mind, that it's called in the inheritance way. The second we have to say, regardless of the order of the parent contract list in constructor of this child contract. So this is how the order is going to be like. So first we'll have the first contract, which is X. This is we'll have the second contract, which is Y, and the third contract is D, because we are inheriting X and Y in our D contract, and this is going to be our third contract. So what I'm doing here, this is the D contract we're going to create right now, and in that we're going to inherit X and Y. So let's define X and Y, and here we're going to build our constructor. We'll pass the value both for the X and Y, and that's it. Let's do the same thing for the other method. So here we're going to create X, Y, and this is going to be E. So let's create another contract. This will become E, and this is how we can inherit as a way of inheritance. We'll define our constructor, we'll define the values, and we're going to, and that's the only thing you have to know about the constructor. There are a couple of ways which you have to initialize constructor. There are ways that you can inherit the property of the previous contract into the main contract. So that's the things we have to keep in mind. You can see this is the first, second, and this is the two methods to update the contracts, and that's it. So now let's take this code to the remix ID and let's test this out, that is it really working. So here I've pasted all the code for the constructor, and let's deploy this contract. So if I come here you can see, here you will find the list of all the contract which you have created, B, C, D, E, F, and X and Y. So these two contracts are the parent contract, and these contracts are subcontracts. So let's first deploy the parent contract, and in this I'm going to pass DAULAT. That's the one I'm going to pass. And here you can see we have this one, and if I call this, you will have this dollar, and right now we don't have any balance into this contract, so you can see it's empty. Now let's come here, go to this Y contract, and in that I'm going to type SHOAIB Schwab my little angel, and I will click on deploy. And here we have the second contract which is got deployed, and this is the contract we have, the first one. If I call this, it's dollar, not this one, and this is the one we have. If I call, you can see I got this two contract. Now what I want to do is, so these two contracts we have deployed, and now we have to inherit these property into this X, so B contract only. So let's come here and we're going to deploy this contract B, and what I can do is I'll simply close this out and let's deploy the contract. So here I have deployed the contract, and this is the B contract. If I open this, here you can see I got this two name. One I've got text, and this one is M name. So if I click on this, I'll get this X, because that's the variables I have defined. And this contract is totally this contract which you have taken. Like here we are trying to inherit this contract in the B. You can easily able to modify the data. You can see we are modifying the data by passing the values like this. do the same thing for the Y. You can see that we have initialized that. So that's the B contract. Now let's deploy this contract C1. Let's click on this and we'll deploy that. So here we have to pass this values. So if you open this one, here you have to pass the name. So I'll say, hey, BUDDY, buddy, and I'll simply click on this deploy, and the transaction went successfully. If I click on this is the C contract, and here you can see if I click on name, hey, and this one is the B, buddy. That looks pretty fine to me. So we are continuing using this contract to update the data. That's what we have here, and this is the final one. This is another constructor we have created. Now what we can do is, let's come here and we have to select the D. If you click on deploy, here you can have this D. If you click on this, you can easily able to have this value. So that's how you can update with the help of the constructor. This is also a way to update the value with the help of the constructor, and I hope this makes sense to all of you guys, that how you can update the value into a smart contract at the time of deployment. Because when you are deploying these contracts, only on that time you can initialize these value into these properties. So make sure these are the things you have to keep in mind, and that's the only thing I want to cover about this constructor, that how you can initialize, what are the way you have, and how you can deploy. So hope this makes sense to all of you. With that, let's move to the next video.
Let's learn about mapping in Solidity. Mapping is a very important concept which allows us to track the data into the smart contract. So in this video, we're going to focus on the mapping, that how you can define the mapping, what are the value types, what are the data types, what is the string type, how you can inherit a contract into the mapping. So to create a mapping, this is the exact sentence. You have to define the keyword mapping, then you have to define the key type and the value type. So the key type can be built in any types, like it could be a byte, it could be a string, it could be any other contract, and the value type can be include only mapping or array. So these are the two things you have to keep in mind. Now let's see the examples. So let's define the license identifier, MIT, define the Solidity versions. Now let's write the first contract, and this contract we're going to call mapping because we are learning mapping. So let's call it mapping, and in this I'm going to take a variable, okay, mapping from address to UNT. So we're going to create a mapping, and that we're going to provide the address and we'll get the UNT back. That's how we're going to create the mapping. So let's create it. So we're going to call mapping address to UNT. It's going to be public and mapping. So this my mapping will contain all the addresses, all the data. It's just like a big basket, in that we have all the users, all the addresses. With this ID, we can identify that which user we want to take from that basket. So that's how the mapping works. So that's mapping we have. Let's come down. We're going to create a function, and this will call get, and this mapping will allow us to get that particular individual from the big basket. So we'll take this address, we'll take the public view, and it will return the UNT because it will return the ID of that particular user. And here we're going to define mapping always returns a value. It will always return a value, whether you define or not. But if you don't define that, it will return a default value. So what is the default value of a number? Default value of a number, default value for address, default value of a boolean. So everything is covered. Make sure to follow the previous video, okay? So that's the default value. Let's come here, and here we're going to return the address. So my mapping is the entire basket, and that we are passing the address. So when we do that, we can easily able to get that ID. So that's the very first function which allows us to get the ID of that particular user. Now let's come down. We have to create another function. We'll say set user. So we want to set the user into that mapping. So for that we need two data. We need an address and we need the ID. So we're going to create an ID. We'll say public because we are doing the changes in the state variable. Mapping is a state variable. So here we're going to create a comment. So update the value at this address. We're going to target our mapping, and we're going to pass the address into that, and we're going to assign an ID, and that ID is coming in the form of I. So that ID is totally up to you, that what ID you want to assign. You can do it programmatically. Whenever someone will click or create the account, ID get generated, and that's what we have done in our NFT marketplace. So if you haven't followed that project, make sure to watch, and that you will have a complete idea that how we are assigning an ID to every single NFT or every single user. So you have these two options. One, you can add it programmatically, or you can take from the user that what ID they want. But when you take the ID from the user, it's create a problem, because what will happen on that time,
same user, like two different user can provide the same ID, and that can create the problem. So that's the thing you have to keep in mind. But here I want to teach you the concept of mapping. That's why I'm going in this way. So it looks fine. Now let's simply close this. So this is this two function we have. We have the get mapping and a set mapping. Now let's create another function. This will say remove mapping. So we have a data. We have a huge list of users into our mapping. But sometimes what happened that we want to remove certain data from there, and we can use it. So for that we need the address that whom we want to remove. So it's gonna be a public, and we have to simply call the our mapping. So we have to reset the value of the default. And how we can do that? This is how we can do it. So we'll say delete my map, and in that we have to pass the address, and that's the pretty only thing you have to do. We have this special keyword in Solidity which allow us to delete the element, and it is what it is. So that's the function we have. Hope you guys have understood that how you can get, how you can set, and how you can remove in the mapping the data. Nested mapping. And nested mapping is a very important concept which you have to know, that how you can get the data from the nested mapping and set the data there. So what we can do, let's come here. We're going to create another contract and we'll call nested mapping. And in that I'm going to create a nested mapping. So this is how the general structure of the nested mapping look like. So this time what we're going to do is we're going to create a mapping from address to another mapping. So if we provide an address of a user, and that will return a particular mapping related to that user. Every single user will have a mapping. So that's what we are doing here. So that looks pretty fine. Let's create a mapping address, and this will call mapping. And in that we'll have this unt, it will return the boolean public, and this is the call. We're going to call it nested. Hope this makes sense. So this is the syntax which you have to follow if you want to create a nested mapping. So we have mapping, we are passing the address of the user, and with the help of that address we are getting another mapping which contain all the informations of that particular user. That's how it's work, and that's the only thing you have to know. So that's the mapping we have. Let's create a function. We'll say get, and we have to get as it says. So we're going to pass the address, we're going to pass the ID, and it will return the boolean. So it will return the boolean. So we'll say you can get value from a nested mapping, and here what we can say, even when it is not initialized. So it will return me the nested, and we have to pass the ID and the address and the ID, and this will give you the data of that particular user, which is a true or false, because that's what we are returning. So with this function, what we are checking that the address we are providing, is it really there in our nested mapping or not? If it's there, then it's returned true. If it's not there, then it's returned false. Now let's create another function. This will allow us to set. So we want to set users into this nested mapping. So again, let me take a address one. It will take the unt ID, and it will take the boolean, and that's what we're going to provide. So if a user will get created, he will provide his address, he will provide his ID, he will provide the bool value, because initially boolean value is false. So at the time of setting, it's become true. So let's come here. We're going to call this nested address and bool, and that's the only thing you have to do. So this will set the user into a nested mapping. Let's create another function for removing. It will take the address and the ID, it will come public, and here we're going to simply delete that user from the nested mapping, and that's pretty much. So that looks pretty fine. You can see we have learned about all these functions. So we have created like single mapping, we have created nested mapping. So that's how you can see this is the nested and this is the single. Here we have all the contract which we have written about the nested mapping and a single mapping. So let's come here, let's deploy the contract. So here you can see, here we have two contracts. First one is mapping, and second one we have the nested mapping. So click on the first one and deploy the contract. The contract is got deploy. You can see the green tick, and if I come here, if I click in this, here we got four functions. So if I come here, the very first mapping contract have these four function, and the reason why we have this my mapping here as well, because we have assigned public. So when you assign public keyword, it will create a getter functions, and that's you can easily able to identify. So first thing what I want to do is I want to set a user. So we're going to use this for function. So let's open it one, and this time I'm going to pass, let's come here, let's go copy this address, and that's the address I'm going to pass here, and the ID I want to assign is the 12. That's the one I want to do, and I will simply call transaction. So the transaction went successful, and I know the ID. So here I want to provide the address. So if I want to know the user, I can simply pass the address and I can call it. So if I pass the address, you can see I got this 12, and here what we are calling. So because of this, it will take the address and it will return you the EUNT. So I hope this makes sense to all of you. So that's the function we have checked. We have checked the set function. Now let's click on the get function, and in that get function we have to pass this, where it is, we have to pass the address. So to get the user, I have to click on paste the address and click on this, and here you can see we got the data. If you want to remove it, you can simply come here and you want to remove that person, and that we're going to simply pass the address. So if you click on this, and that's removed. And if I come here, if I click on this get, we don't have that user into this. So it's working pretty fine. So this is the very first function. You have seen all the methods: remove, set, get, and mapping. Now let's create on the nested mapping. So let's delete this one. Let's come here and let's deploy the contract. So if I deploy that, you can see here we have the contract, and here we got the 4 functions. So right now we don't have anything. So first thing we have to do is to set. So to set that, what I have to do is I can paste this address, I can paste the, let's say, ID, and I can paste this to, let's say, something true. If I click on this transaction, the transaction went successful, and that looks pretty good to me. Now what I want to do is I want to get that user. So to get that user, I have to paste the address of that user, and because we are doing with the nested mapping, so that's why we are providing this true data, and we're going to pass this 5. If I call this one, you can see the transaction got reverted, because I think I have what the ID we have given to this user. Okay, so this is the set method we are calling, and that we are passing the ID. Okay, so we are setting the user, and this ID is, okay, this one is the set one, and this one is the get one. In the get, we are passing the address only, my bad. So not this one, this is the function we have created. It will take the address and it will take the UNT. So in that, I'm going to pass the address and I'm going to pass the UNT. If I call this one, if I call this get, I get an error. Why it's happening? So let's come here, let's paste the address and paste this ID. What ID I have provided? Let's call the functions. I think I have provided the wrong ID. I forgot the ID. Let's click on this and let's try to create that one more time. So what I will do is, so this is first thing we have to do is to set the user. I'll come here, I'll simply paste that, and let's call this one to 3, and this will become hey. And if I click on this transaction, the transaction went successful. And if I want to get that user, first thing we have to pass this in this. Let's call the function, and you can see it's a UNT type. So this will take the address. My bad. So first thing we have to provide the address, and then we have to provide the 3. And if I call this one, here you can see I got it true. This user exists in our nested mapping. You can see this is true, we got with this function. Sorry, this function we have created nested mapping. Now I want to get the user. It will same thing I have to do here. If I come here, I'll paste the address and I'll paste this 3, and if I call this get the transaction, you can see here we got the boolean true. So it's working fine. So that's how you can retrieve the data and simply delete the data. The same thing you have to do. If you want to set, you can set it, you can remove it. Hope this makes sense to all of you guys. You guys have understood that how you can create the nested mapping with a single, and how to create a simple mapping, and how you can create a nested mapping. So that's the only thing I want to cover in this video. Hope you guys have found this video valuable, and if you have any confusion, make sure to watch the NFT marketplace after completing this course. Okay, so in that you will have a better understanding that how we have utilized this nested mapping for mapping the NFTs of the single user and a multiple user. So make sure to check that as well. So with that, I'm ending this video. Hope you have enjoyed this. With this, let's move to the next video. Array is a very important concept in Solidity or any programming language. So in Solidity, we have 2 types of array. One compile time fixed size array, and the other we have a dynamic size array. So let's take the example and let's see how we can easily able to update, delete, add into an array. So let's follow the general configurations. We have to provide the Solidity version, and here we're going to create a contract. We're going to call it array because that's what we're going to cover here. And inside that, we're going to create a couple of arrays. So several way to initialize your array in the contract. So let's do that. So first way is to this. This is the first way to initialize the array. So here we are creating an array which is a unt type, and we have used this public keyword so we can get a getter function, and this is the name we have given to our array, arr. So this is the first way to declare an array. Let's have a second way. So we'll again have a public and we'll pass this data, and this is the second way to declare your array. In that we are defining the value, predefining the value of the array. So that's the second way. Now let's do the third way. Let's give this comment: fixed size array, all element initialized to 0. And that's how you can do it. Here we have to declare 10 array, and we're going to call it fixed size array. In this fixed size array, we are declaring that we cannot have more than 10 element into our array, and that's what you have to follow in your smart contract, fixed size array. Now let's come here. Here we're going to create a function we'll call get. And with this function, we want to get the information from an array by particular ID, because every array will have a index, so it will start from 0, 1, 2, 3. So on the base of that index, we're going to get the data from the array. So here we're going to make it public. We'll call view returns unt, because that's what we want to return from the array, because it's a unt type. And here we're going to simply return the array, the entire array. In that we're going to pass the index, and that will give us the data. So this is the very first function we have. Let's create the second function. This will call Solidity can return the entire array, but this function should be avoided for array that can grow indefinitely in length. And that's very important, because in the smart contract, what happened that you're going to store informations, you're going to do the transaction, because this array is nothing but a state variable, and whenever you do any transaction, whenever you add any information into an array, what happened that you have to pay gas fee for every time. So that's why it's not a good idea that you should define an infinite array in your contract. You can go with the fixed size array, but you cannot go with the infinite. You can, but it's not recommended. So let's create a function. We'll call it get array, public view return, and we want to return the entire array. So not a particular data, but we want to return the entire array. So let's come here. We're going to define that. We'll say return, and we want to return the entire array, and that's how you can do it. So this is the array, and now let's create another function. We'll call it push public, and now we want to push the data. So you have seen that this is the normal array we have created, and we want to push the data into that, because we are not initializing any data at the time of deployment. It's just a state variable, an array, and we are pushing the data into that. So let's do that. We'll create this append to array, add to array, and here we're going to call this will increase the array length by 1. So every time you will add an array element into your array, it will increase that. So initially it will start from 0, 1, 2, 3, and will go on and on. So let's come here. Let's create an array dot push, the method we have. In that we're going to pass this I, the number. So this is the push method. Now let's come here. We have to take another function which is pop. So sometime what happened that we have an array and we want to remove something from that array, and that's how we can utilize it, by using the pop method. So we'll come here, we'll take the array, so removing the last element from array. So when you want to do that, when you want to remove the last element, you have to use the pop method. So we'll call our entire array. So this will decrease the array length by 1. So we'll call our pop method, and it will remove that last element in the array. So this is the function. Now let's create another function. This will call get length. So if you want to get the length of the array, that's how you can do it. So we'll say public view return. We want to return a number, obviously, because the length is going to be unt type. So that's why unt, and return the entire length. So just simply call the method dot length. It will give you the length of the entire array. Let's come here. Let's create another function we'll call remove. And now we want to remove an element. So just imagine that you have an array, 100 of array or 10 array, and that you want to remove a particular data, particular element from that. But what happened here that when you will remove that data into an array, so if the array length is 10, and if you remove that particular number 5 element, so when you remove that, what happened at that time, gets removed, but it will set the default value to the 0, and you will have the same 10 length. So there would be no changes in the length, but only in the value. It will reset the value to 0. So in that, we're going to pass this index public, and we're going to simply delete does not change the array length, but it reset the value at indication as a default. Hope this makes sense. And let's, in the case of 0, here we're going to call this delete method, and we're going to pass the array and the index, and this will become 0. So let's come here. We have to create another function. This will call example external. So let's test this out. So what I want to do is, into this function, let's create an array. In memory, fixed size can be created. So sometime what happened that you have an array as a state variable, and you want to create a copy of that array to execute certain functions. And that's what we have follow in our NFT marketplace. So you can check that smart contract. So in that scenario, whenever you want to create a function in a memory, that should be fixed size. It should be never dynamic size. It should be fixed. You have to define the length of that array, and that's what we're going to create here. So let's come here, and we're going to call this unt memory new memory, and here we have to define the lengths. So right now I'm going with a 5, and that's how you can define. You have to define the data types, then the array, memory, and you have to give the name of the array. So we have taken A, and you have to use the new keyword, then a data type, and you have to define the length. So that's how you can define array into your memory. So this is very important. You have to be very focused here. So that looks pretty good to me. Now close this one. So with this, we are done with this entire array section, and we have covered most of the topics. So you can see this is the entire contract, and now we can test this out. Here you can see we have the entire array contract we have written, and we have all these functions here. So let's come here, let's deploy the contract. And here you can see this is the only contract we have, which is an array. Click on this deploy, and here you will get the contract. Open it, and here you will find all the contracts, all the function which you have created right into this array contract. So what I can see right now, you can see we have this array 22. So let's test this out. So if I come here, you can see this is the one we have, and we don't have any function to add any error because we have defined all the element at the deployment. Initially we have defined all the values. So if I want to get the first value into this array, I can pass the 0 index, and I click on this, and here you can see I got the value 0. If I come here, if I pass the 3, because I don't have this 3 element, so I have to pass 2, because in array start with 0. So if I click on this, I will get the 3, and that's what I have in this. So this is how you can access the data on the base of the index into an array. And right now we have this array, and here we are using this array to update and delete and remove. So you can see this is the public we have used, and here we have it. And right now where it is, if I call this one array, you can see nothing I'll get here. You can see it's an empty array. And now what I want to do is I want to get this. So right now we don't have any array. We have to simply first we have to set that array. So let's see where we have created that array, and this is the array we're going to use this. So we're going to use this push function to add into our array. So where we have is here we have that. So I want to add 5. If I click on push, the transaction went successful, and if I call this one get array, so this is the one we have, get array. If I click on this get array, here you can see I have this 5 which I have added. And if I want to find, let's add one more. So let's come here, let's remove this, let's type this 3, let's type this 7, 6, let's type this 8. So right now I have 4 arrays. If I click on this get array, I'll get this all 4 elements. So if I want to get with the help of this function, so I want to access this data number 3. So what I will do, I will type 1, I will click on this, I'll get this 3. Okay, if I want to get the 5, I can type 0, because array is a start with 0. Okay, index 0, so 5. If I want to get the length, right now we have 4. If I click on this, I'll get the length. We have 4 elements into our array. If I want to remove, so for removing, what I have to do, if I want to remove this, so right now we have this, I want to remove number 5 or number, let's say number 2. This is the 3 value. So for that I'm going to pass the 1 index, and I will click on remove. And it's remove. If I call this get array, you can see I have this 4, because when you remove, what happened that it only remove the value, but the length will not change. It will set the value to 0. So hope this makes sense. And if I want to remove the last element, so this is the length I want to remove, so I can call this pop. If I call the transaction successful, if I call get, you can see the array is gone. So the pop method delete an element from last. That's the general overview of an array, that how you can add element, delete element. In the next two videos, we're going to have two more lessons on the arrays. In that, we're going to see the advanced use case of an array. So let's move to that. In this video, we'll learn one important concept in Solidity when it's come to array. How you can shift an element from right to left and remove. And that's what we're going to focus in this video. So let's see how we can do that. So let me provide this Solidity compiler. We have to provide the Solidity version. Let's create a contract and I'm going to call it array removed by shifting. And that's what we're going to do in this. So here I'm going to define an array. So this is how it will work. So this is the array we have 1, 2, 3, and I want to remove the one index array. So once I remove that, that's how it will become 1, 3, 3, and this is the final product would look like 1, 3, because I'm removing this. So what I'm going to do is, let's come here, we're going to remove 1, and that's how you can do, because 1 is going to be, we have a array in that we have one element which is a 1, and that's what I want to remove. So the index of that element is going to be 0. Once you remove that, what you will get? You will get nothing. So that's pretty simple thing. Let's create a array, and it's going to be a unt type and array. So let's come here, we'll create a function called remove, and this function I'm going to call inside another function. So in this function we're going to pass an index public, so anybody can call it, and that's we're going to write a do a if statement, because we want to remove the element on the base of the condition, not just like this. So here we'll say that if the index is less than array.length, the array we have, if we have an array, if we have any item into our array, then only remove index out of bound, because there is no array and the index we have provided, there is no way to remove those index into our array. So that's the first check, and here we're going to run a for loop. We'll say unt I is equal to I index, the index we are getting. If I is less than the array length, then we have to subtract, because we want to start from the backend side, and then we have to increment that. And here we're going to simply remove it, the index I plus 1. So hope this makes sense. It's a simple JavaScript. We are running a for loop and trying to delete the index. So just imagine that you have a 10 elements into an array and you want to delete the 5 from the last. And that's how you have to do. So if you want to have only 5 elements into 10 array, so what you can do, you will pass the index 5 and it will run the for loop and it will delete all the element from the last side till we have the 5 array left. And that's what this remove function is going to do, to help us to remove the array from the back into our array. So that's what we have, and now we're going to call this function. So we're going to create another function, and this will call test. It's going to be external, and here we have to do on the base of certain things. Okay, so we're going to take an array. It's going to be 1, 2, 3, 4, 5, 6. So this is the array which we are updating into a function. Okay, remember earlier we have no data into an array, but here we are updating that. We'll say that remove index 2. So that's how it will work. So you have passed this remove functions, so it will remove. This is the array we have defined 1, 2, 3, 4, 5, but we are passing the index 2. So can you guess that what array it will remove from that? So here let me do this. So this is what we're going to get it, because we are removing number 3, 0, 1, 2, 3. 0 is 1, 2 is 1, 0, 1 is 0, 2 is 1, and 3, because we are removing the 3 element. That's how it will look. Let's do the check. So if assert 0 index is 1, yes, that's the true. Then we have to do the second check. If the second element is 2, yes, it is true. Here we have to do the third check. If the first is 2, second is 4, yes, because after deleting that we got that. Now the last one is 5. So it's true statement. If this statement gets true, we have to simply call this assert. So if the array.length is 4, if that's the true condition, then we have to remove one more element. So we're going to check this one and we're going to say remove 0. So we want to remove the first array, and then we have to call this. So it will call assert.length is equal to 0. It will be our true statement. So hope this entire things make sense. So this is the entire shifting works. And let's test this out, the contract we have written. Here we have the entire arrays, which we have defined, and the two functions. So let's quickly deploy that. So here you can see this is the only functions, only contract I have. If I click on this deploy, here I got the contract back, and then thus we have these three functions. So right now we have this test and we have this array. So here you can see right now we don't have anything into an array. So if you pass 0, you will get an empty array. You will get nothing into this because we don't have anything. Now what I'm going to do is, instead of calling this function get test, or you can call it from here. So if you have anything into an array, because that's what we are dealing here. So if I can pass 1, I can call it remove function. Nothing will happen because nothing is there. Nothing is there because this function is totally dependent on this test. So right now you can see if I call this get, if I call this test, so what will happen? The first, it will update this array, because this is the array we have taken and here we are updating that. So it will update that, then it will remove the first this element, it will remove this element and it will get this, and then we are doing this check that at the end finally we are checking for the length, and then we are checking we are again updating the array and making it 1. So at this point we have only one array, and here we are calling this remove function and passing this 0 means we want to remove this array as well, and we'll get this function. And here we are confirming that the entire array is length is 0. That's pretty simple function. Now let's test this out. So what I can do is I can click on this confirm, and here the transaction went successful, and the transaction went successful, and you can see we got nothing. If I open the logs, this is the transaction we have done, and here you can see we have done all the logic. So this is the transaction has the function we have called, and you can see right now we don't have anything. This is absolutely empty. So what happened? First, when you call this test function, what it does, it update the array 5 element into our array, then remove the third. All the elements are there on their position based on the index, then check the length, then remove the last one. So hope this makes sense that how you can remove by shifting. So this is a pretty important thing which you have to know, because when you're going to create a nested mapping and in that you're going to map an array, so these things becomes very important. So that's the only thing I want to cover about the shifting and removing array by shifting. Let's move to the next video, and that we're going to have one more topic on array, then we'll move to the other topics. When it's come to removing an element into an array, there is one more method which you can use it. So generally what happened that you have an array, just imagine that you have 10 array, and when you call a delete method on that array to delete a specific index, a specific element, what happened at that time, the length is going to be the same. So if you have 10 element and you call the delete function and you deleted the first element or second element, the length is going to be the same, and that's not ideal because you want to change the length as well, because you have deleted one element. Once you call the delete function straight away, what happened at that time, it will set the value to 0 by default. So it's always a great idea that whichever element you want to delete, first you have to place that element at the end of the array, and from there you can call it pop method to delete the last element, and that way you will get the updated length after the delete. Okay, and that's what we're going to do it right now in this video. So first thing, we have to provide the Solidity license identifier MIT, then we have to define the Solidity versions. And here we're going to create a contract and we'll call it array replaced from end. Here we're going to define an array, and it's going to be a normal array. We have not defining any value, and here we're going to create a function. Okay, so let me give this command: deleting an element, create a gap in the array. This is what I have talked about. If you want to delete an array, if you have 10 array, if you want to delete the array number 5, and that it will reset the value, but you will have the same length. And that's the gap I'm talking about here. On trick to keep that array compact is to move that last element and place, and then call delete method. So let's call this, let's see in the function. So we'll call this remove, and in that we're going to pass the index, whichever index we want to delete into an array, and we're going to make it public so anybody can call it. So we have that one. Now what I'm going to do is I'm going to create this, move the last element into the place to delete. So just move it, and now we're going to create an array. We'll have an array, this entire array, in that we're going to identify binary index, and we're going to simply call this array.length -1. So it will give us the last length. So it will give us the right index and the exactly both the things will be together. Simple. Let's call remove the last element. So to remove that, we're going to call this pop method. So what we are doing here, we are just setting up the value and we are removing the last element. So that's how exactly it works, and that's how you can remove that. Let's come here, let's create another function, and we're going to call it test public, and here we're going to confirm that. So we have to update the array. So we're going to take this 4 array. In that, we're going to simply call this remove function. So what I'm doing here, I want to remove the element number 2 inside my array, the 2. So for that, I'm calling that, and this is what the result I will get. So first I'm doing that, I'm bringing that 4, the fourth one, bringing into the place of 2. So 1 4 3, and that's what I have talked about. So you have to replace the position of the index of the element which you want to delete from the to the last, and bring the last one to its own place. That's what the array, updated array, will get after calling this remove functions. And here we can make the change. So if the length is 3, so that's the first check we are doing, and here we are simply doing that second check, that in the first index we have 1, in the 0 index we have 1, and the first index we have 4, and the second index we have 3. And now we can simply call the remove function. So in this remove function, what I'm doing, I want to remove the last element, the last one. So this is what I will get, 1 and 4, because it's already last. We are not going to replace with anyone. So we're going to simply call this. And then we can check the length. Is it the length? If is that the length, then simply confirm that. It will work 100% fine. And that's the entire logic. Hope this makes sense, how you can replace an array and then you can simply remove that. This is the entire contract we have here. Let's deploy the contract very quickly. This is the only contract I have in this. Let's open this one, and here we have these 3 functions: remove, test, and array. So right now if I call 1, I have nothing into this because initially we have not assigned any value to this. So first let me click on this test. If I click on this test, it will do this. You can see first it will update the array, then it will remove this element, and it will give me the updated array. Then we are confirming this. Then again we are removing this array. So this is the third one, because this was 0, 1, and 2. So this one, and then we are checking for this. If you have a look here, we can see the transaction went successful, there is no error, and you can see everything looks fine. We don't have any error, means everything's look good. So that's how you can replace an array by shifting. In that way you always get the updated length. So 10 array, if you want to remove one and you want that the length of the array also get changed, and that's how is the way to go. So hope this makes sense to all of you, and that's the only thing I want to talk about the array. I hope I try to cover every single thing about the array which are there, by replacing and then shifting and deleting, then the normal. So everything we have discussed about the array in the Solidity smart contract or in the Solidity programming language. With that said, let's move to the next video.
So in the last video, we have completed the array section in Solidity Smart Contract. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about Enum, what it is, and how you can define into your smart contract, what is the structure, and how you can keep the track of the entire data which you want to specify in the contract. So that's going to be the topic of this video. And Enum stands for innumerable. So this kind of question might be asked in the interview. So let's see the practically that how we can do it. We have to provide the general configuration. So Solidity license identifier, we have to provide the Solidity version, and let's create a contract, and we're going to call it Enum. Instead that, we're going to define our exact Enum. So let me give this command. Let's define the enum. So this is how you define. You give your name enum, and you can give this name of this enum whatever you want. It could be hey, okay, but here I'm going with status because I want to create an enum of a shipping. So just imagine that I'm creating contract, and that contract will keep the track of a shipping of a product. So there will have a multiple data. It will have a pending, cancel, arrive, accept, reject. So let's create that data. So we'll call it pending, shipped, accept, reject, and cancel. This is going to be our enum. And let's come here. So whenever you define enum, the default value is going to be the first element. So that's how exactly it's worked. So let's create a variable status, public status, and that's how we refer our enum. And here what I'm going to do is, let me show you. Returns the UNTs. Pending is going to be the 0 because the default value of the enum is going to be 0, and it's just like an index. So we have array, in that we have this indexing system. In the same way we have indexing system in enum.
So the second one will have this ship 1, accept 2, reject 3, and cancel is going to be 4. So looks fine. Now let's create a function. We'll call it get public view return, and in that we want to return the status. So what we have to do is let's create a return status. So that's the simple function. So this will give us the status. So can you guess what status we'll get when we'll call this function? Just think about it. Let's write the code. So let's come here. So now let's update the status, because the default value of the status is going to be obviously pending. So let's update that. So we'll create a function, we'll call it set status, and that we're going to take the status public, and in that we're going to call it status equal to status, and that's it. In that we have to pass the index, the status we want to confirm, because the pending we have 0, accept we have 1, so that's the index we have to provide. So this is the so let's come here, let's create a function, we'll call it cancel, and this is how you can update the status. So we'll say status is going to this cancel. So if you want to cancel that entire order, you can call this cancel method. Cancel enum, and this will change the state. So by default we have this pending, but when someone will call the cancel this function, it will update to cancel. And if you want to update to other like accept, reject, you can simply pass the index in the set function, and that will update the status. So that's the pretty simple thing here. Let's come here, let's create another function, and this is very important, because when you delete an enum, it will reset the value to 0. So let's see in the code. So we'll call it reset public, and in that we want to take this delete status. So when you do that, it will delete the status. So that's the simple smart contract we have written about the enum. Hope this makes sense to all of you, and how we are accessing different variables in each of these functions. So now let's test this contract in the Remix ID. Here you can see we have the entire smart contract for the enum, and we have all these 3 functions. So what we can do is let's come here, let's come to the deploy sections, and you can see this is the contract we have. Now click on this deploy, and here the contract is got deployed. If you click on this enum, here you will find these 5 functions. So first thing we have to do is, if you really want to access the set, so in the set, so let me do one thing. What I can do is, here we have made this public, so let's check the default value, that what default data we get from here. If you click on the status, we'll have this 0, because this is the indexing 0. This one is the first one pending. And now what I want, if I want to simply call this 1, because I want to target this shipped, if I call this set, the transaction went successful. If I click on this, I'll get this 1. So you can see we are updating based on the index. So it's just like an array. The way we have accessed the array into a big array by providing the index, in the same way we can access all this data by its index. So it's working absolutely fine. So now if I call this get method, I will get the status. So here I can call it get, and here you can see this is 1. That means the shipped, and it's working fine. If you call this set, we have already used the set method. If we call this cancel, so let's do one thing, let's click on this cancel, and the transaction went successful. If we call on this status, it will be 0, and that's what we have provided here, 0. So we have checked this function. Now what we can do, let's do the reset. So if I want to reset the entire data by its default, I can do it very easily. Click on this reset, and the transaction went successful, and now you can click on the status, and you can see we have this default value. So hope this makes sense to all of you guys. Array act like an indexing. So if you want to access any variable into these data, you can provide this index. So this one is 0, 1, 2, 3, and 4, and on the base of this indexing, you can easily able to build the logic which you want to build. You can display the message that your transaction is got approved or rejected. A huge string you can display by taking this indexing value based on this enum. So hope this makes sense. If you have still any confusion, make sure to rewatch the video, and do leave in the comment that what is the problem you are having, what is the difficulty you are having. I'll try to solve in that. With that, let's move to the next video. Sometime what happened that your smart contract is huge, and in that you define multiple enums. The enum list is huge. So in such scenario, what you can do, you can create a separate contract, separate interface, and that you can define the entire enum. So that's also possible in the Solidity. So in this, we're going to do the example. We're going to create an enum into a different page, and we're going to import it and try to access that. So let's provide this general convention Solidity version. Let's create a contract declaration. So here what I'm going to do right now, I will show you right here, but in the real world, what happened that you create a separate file, and although it's a very small
enum which I'm going to create. So that's why I'm going in the same way. So you guys can get the notation that how you can import and how you can create. So let's declare the enum. So we'll call it status, and that we can define our enum. So the same example we are taking: pending, shipped, accept, reject, and cancel. So just imagine that we have created a separate enum declaration Solidity file. In that we have declared all the enums which we want to use into a smart contract. So this is the enum, and now I want to utilize this enum into different contract. So this is how you can do it. All you have to do is to create a new file. So right now I'm showing you in the same file, but what you can do, if you want to use this enum, the interface, enum interface, into a different contract, you can create a different file like whatever the name of the file, and this is how you can import. You can use the import and you can provide the file path. So that's what we have, and now you can simply create a contract. We'll call it enum, and in that you can easily able to inherit all the enum property, all the enum which you have defined into the file. Just close the contract, and that's the only thing we have to do. You can see we have defined the enum and we have imported that. How you can import and export the enum, and that's the only thing I want to talk about, the import of the enum in this video. So with that, let's move to the next video. Struct is a very important concept in Solidity smart contract development because it will allow you to create related data. And the best part of it is that you can define into separate file and you can import it into a smart contract. So in this, we're going to learn everything about struct, that how you can define, how you can update, and how you can delete. All those things we're going to discuss in this. Let's provide the general configuration. So we have the MIT Solidity version, and let's create a contract, and we're going to call it to do. And in that, we're going to define our struct. So this is how you can define your struct. You can use the keyword struct, and you can define the name which you want to give to your struct, and this name could be anything. It's totally up to you what kind of data you want to model. So in that, let's define the struct. So it will be a string and text, and it will have this bool complete. So by default the boolean value is going to be false, and if we complete the structs, it will turn it to true. So that's the simple struct we have created. Now when you define your struct, you have to define an array. All the data which you're going to create with the struct, that's going to be stored into an array. So let's declare our to do, and will be public and to do. So that's the how you have to declare struct and how you can store the data into an array. Now let's create a function which allow us to create our to-do list. So let's create a function. We'll call it create. It will be string, call data, text, and public. So anybody can call this function, and in that we're going to initialize. So generally we have three ways to initialize our struct. So we're going to take each of these three. So we're going to explore each one of these. So let's come here. The first one we'll have by calling it like a function, and you can take this to do look, and you're going to push the entire data. So we have this to do, text, and the false. So when someone will create, will take the data and will create the, I will turn it to false. Okay, that's the pretty simple things. This is how you can update the data into the struct by using the push method. And there is one more method. The second method we have is by key value mapping. So this is going to be the similar one. All you have to do is to provide the key text, and that's what we have defined in the to do text, and we are passing that. So this is one way you can do by the key value pair as well. And the last one we have is to create like this: initialize an empty struct and then update it. So all you have to do is to create a memory to do. So this is our empty, and here we're going to simply update that. So we'll take this to do, this text to do dot text equal to text, and the same thing we have to do is for the complete, and by default the boolean value is false. So this is how you can update it, and then we have to push that to do into our to dos. So that's pretty simple thing. Hope it makes sense to all of you guys that how you can update the struct by using these three methods. All you have to keep in mind that we have three ways. One, by simply passing the data using the push method. In that you don't need to pass the key value pair, and the second one we have is the key value pair, and the third one we have is to creating an empty struct, and then we can update one by one. So these are the three methods we have. Now let's come down. Let's check the Solidity automatically create a getter for to do, and to get that you don't need to create a function. So let's create a function. We'll call it get. In that we're going to pass the index, public, view, return, and we want to return the and boolean. So this is the data we want to return from this function, and we'll call it to do storage to do, and in that we're going to pass the index. Pretty simple thing. And then we're going to simply call this return, and we'll pass this data. So in this way we can easily able to access the data into our array, because all the data we have in that array, and we have to pass the index of that. So that will give us the data back. So that's pretty simple. Let's create a, if you want to update that to do, so we can do that. Let's create that function for it. So we'll create a function, we'll call it update text, and that we have to pass the index and the call data public, and we have to simply change the state. So storage to do index, this will give us the particular to do list which I want to update, and in that we're going to simply update the text we want to do it. So that's pretty simple. Hope this makes sense. Now let's come here, let's update completed. So when you will click yes, it will become true. When you click again on that, it will become false. That's the simple logic. So let's call it complete toggle, and we're going to pass this unt index public, and we have to simply change the status. So we'll create a empty array, we'll take that array, that particular struct, and we're going to simply update that to not this. And that's a pretty simple function. So if you call this function on a to do, it will turn it to false if it's true, and if it's false, it will turn it to true. So that's the simple thing it will do forth and back. So hope this makes sense to all of you. This is the entire smart contract we have written on the struct, and now we're going to test this out. Okay, here we have the entire smart contract we have written to understand the struct. You can see we have all the create function, and we have the get, update, and toggle. Now simply deploy the functions. Deploy the contract. I will click on this deploy, and here we have the deploy contract and all the functions. So right now you can see we have this 5 functions, and you can see right now we don't have anything into our array. So if you come here, this is the array we have created. Okay, this one is a, yeah, if I pass 0 index, I won't get anything. I won't get anything because we don't have anything into that. So we have to call this function create. So in that, what we have to do is, let's come here and let's come here. This is the function we are calling. Open this one, and in that we have to simply pass the string. So the data I want to pass is hey, not day, and click on this transaction. If we do call that, the transaction went successful, and now if I call this to do, here you can see I got this hey text, and by default it's false because that's the default behavior of Boolean in Solidity smart contract. It will be false. Now if I want to create one more, I can type something like buddy buddy, and I can click on create, and the transaction went successful. If I want to access that data, I can simply call this one, and this will give me the data. Here you can see we are doing this. So we have used all the 3 methods to create the struct. That's why we are getting this problem. So to fix this, all I can do is simple way. That's pretty simple. Simply comment this. And because we're going to use any one method, not we're going to use all the method to create the same data. So we have uncommented this, delete this one, and now we have to deploy the contract one more time. Here the contract is got deployed, and now we have this method. So we have, first thing we have to create, I call DAULAT download, and I will click on this create. We have created, if we take the 0 index, I will get that, we'll get the data hey text is dollar, and if I want to go into this, if I pass the index to 0, I'll get this dollar. But if I want to create one more, I'll say SHOAIB Schwab, and I will click enter. The transaction went successful, and if I call this one, I'll get this Schwab. You can see this time is working. Earlier it was not working because we were using 2 methods to update the same data. That's what's the problem. And if you do the same thing here in the array, it will work in the exact way. We got the swap by. Now what if I want to update this? So here we have this get function. This is the one which is returning the data. So now let's update that. So to update that, we have to pass the index and we have to call the data. So here we have this update text, and what I want to update, so let's expand this one, and here I'm going to pass this buddy buddy, and here I'm going to call it, so buddy is on the index 0. So let's take index 0 and click on this transaction. It's been successful. If I come here and if I call this to do, here I got dollar. Okay, nothing happened. So let's see what's the problem we are having here. Okay, my bad it's a 0, and here I have to pass this buddy, buddy buddy. If I click on the transaction went successful. If I click on this to do, I'll get the data buddy. So this one is also working fine. Now let's check this toggle. So for that, I have to provide the index. So let's come here. This is the function we have. Let's close this one. This is the function we have. If I pass this 0, I'll get this data. So right now, if I open the logs, you can see this is the 0 index we have provided, and we have done it. So right now, if I call this 0 index, it will become true, because here we are saying if it's false, then turn it to true. And if I call it one more time, this will become false. You can see it's false. So this also working fine.
the to-do list component. So hope this makes sense to all of you guys. Have understood that how you can create struct and how you can update into an array, how you can use this three different method to update the struct. This is the data from you can use to get, this is the function which you can use to get the data from the struct, and this is for updating and this is for changing the state. So hope this makes sense. If you have still any confusion, do let me know in the comment. I would love to help you in that. And let's move to the next video. In that I want to show you one more thing about this. So as we have discussed about the enum, that you can create a separate file, separate Solidity file, and that you can define all the enums which you want to use in the smart contract into a different file. That's also possible with the struct. So let me show you the example that how you can create a struct into different file and how you can import into a different contract. So let me provide the general configurations, license identifier, Solidity version, and we're going to create the file which we want to. So here I'm giving this command. In this file I'm going to create the entire struct which I want to import into different file. So let's come here. Let me create the struct to do. And this is the general convention you have to follow. In that we don't need to define any contract name because we want to define only the struct which I want to use, which we want to use. In that we have to define the string, text, and we have to define the boolean. This is the struct we have. And now just imagine that I want to use this struct into different contract. So this is how you can do it. Very easy. We have to define the, let's say import, we have to define the file which we want to use it, and here we're going to create a contract, and in that we're going to simply inherit. So an array of to do struct. We have to create the array because right now in the struct we haven't defined that array, and that is very important that you have to define whenever you define the struct in the contract, because all the struct you're going to create, that's going to be stored into the array. So this is how we have defined the array, and we're going to simply close that. In this way we will have the access of the struct we have defined into this contract, to this contract, and that's pretty simple. So hope this makes sense to all of you guys, that this is how you can create a struct into a different file and how you can import it and how you can use it in your smart contract. And that's the only thing I want to cover in this video, because this is a very simple thing, and I wanted to show you that there is a way you can create a separate file for the struct and you can use it into the smart contract. With that, let's move to the next video. Let's try to understand the data location into the Solidity smart contract. So we have three different type of data location. One is storage, other one is memory, and the third one we have is the call data. So when it's come to the storage, the data we're going to define in the storage, that data is going to be stored on the blockchain. The data you will define in the memory, that data will exist in the functions, and the data you will define as a call data, that data is going to be an argument. So let's follow the general convention. We have to define the Pragma Solidity version. Let's create a contract and we're going to call it data location. In that we're going to define our array. It's going to be a UNT type public array, and we're going to define a mapping address, and we can simply define a struct. In that struct we're going to take a UNT is going to be a foo, sorry, and here we're going to define another mapping which will take our struct, and then we have to define the struct. So that's the pretty simple thing. Hope this makes sense to all of you guys. Now here we can come and create a function we'll call f, and in that we're going to call another function which we're going to call internally. So let's create this function. So we're going to call it, so let's do something with the state variable first, and this data, the state variable we're going to define, this data is going to be stored on the blockchain. So this is the function we're going to create, -f, and in that we have to pass the array and the mapping and the struct, the first struct. Hope this makes sense to all of you. Nothing complicated, very simple. And here we have to do something. So get the struct from a mapping. So to get that, all we have to do is to call the struct, and we're going to call it storage because we are creating a memory. We are creating a copy of the data we have defined as a state variable, and that's how we can do it. We'll call it my struct, and we have to access the struct 1 because we want to access the first element. We're going to simply create a struct in a memory. So we are getting a copy and then we are creating into a memory. So let's come here. We're going to call map. So now we are declaring the struct in the memory. So we have to use the memory keyword, and here we're going to call our struct my struct, and we have to say my struct 0, first one. We'll close that one. Let's come here. Let's create another function which is going to run internally, and in that we have to pass all the variables, array, mapping, and my struct 1. If we come here, we're going to define the UNT storage array. We have to define the mappings, address, storage, and this one is going to be the storage, my storage. It's going to be simple internal function, and here you can type whatever you want to do. Hope this makes sense to all of you guys, that these are the variable we're going to pass into this internal function, and our f function will execute. So we'll check. Let's write the other function. We'll create a you can return memory variables. So that's how we can do it very easily. Let's come and create a function. We'll call it g, and then we're going to pass this argument, entire array, memory array, because this is what we want to return. We have to reuse this return, and here we want to return the entire array we have defined. And that's why we are giving this unt type and the memory, because we want to return the data in the memory, and we want to do something with the data. We don't want to store on the blockchain, but we want to use that data to perform certain tasks into the smart contract. And that's a very common practice when you will work in the real smart contract. You'll create a copy of the entire storage data, and you can perform certain function, and you can simply execute it. So that looks fine to me. Let's come here. We can do something with memory array. So that's pretty simple. Now let's talk about the call data. So let's create a function which h, and then we're going to pass this call data array, and we're going to say external, and in that we want to do something. So do something with call data array, and that's pretty much. So this is how you can define the data, the call data, memory, and storage. Storage is very important, because when you will write the smart contract, you have to be very precise that what data you want to store on the blockchain, because every single data is worth almost ether. So you have to be very calculated that how much ether you are paying for deploying the contract. So you can learn about the memory, that you can create copy, and you can do performance certain tasks using that array. You can do the same thing with the call data, but storage is an important concept. Right now, if it sounds confusing, don't need to worry about it, because when we write the smart contract, when we build the applications like NFT Marketplace, which we have already built, you can refer to that project, and you can see that how we have defined the memory data for performing and calculating the who are the user had created the NFT. So those kind of logic we have built into the smart contract. So this is the contract for the data location. You can see we have all the variables. So this is the first function, f function, and that we are calling this foo, passing this data. Then we have the other function. This one will run for the call. This one is for the memory, and this one we have for the storage variable. So if you come and if you deploy the contract, and if you check, you will have all this access. If you do anything like this, it's when successful. But you can't return any data right now, because we have not built any logic. We have built that you can do something with the data. You can do something with the data. So this is how it's worked. That's the only thing you have to keep in mind about the data location in the Solidity smart contract. This is not that important, but when you will write the smart contract, the storage is very important, that when you have to storage, when you have to use the memory. The only thing you have to remember that storage will store the data on the blockchain, and you create a memory, because when you want to take the data into the function, not storing on the blockchain, but you want to use it internally in the function to perform certain calculation. That's the only thing you have to keep in mind. Hope this makes sense. If you have still any confusion, and down to leave in the comment section, I'll try to help you in that. With that, let's move to the next video. Function in any programming language is the heart. If you want to do anything in the programming language, in the smart contract, you have to create function to build the logic. And that's what we're going to learn in this video, function in Solidity smart contract. There are several ways to declare the output. If you want to declare an output, get an output, for that you have to create a functions. So let's follow the general convention. We have to define the Solidity version, and now we have to create a contract. We'll call it function. In that, we're going to create function can return multiple value. Okay, so this function going to return the multiple value for us. So we'll create a function. It will say return many, and in that we have to define, so public, pure, and this will say return, and in that we have to define all the value which we want to return. So unt, we want to define boolean, we can take unt, and we can come here, we can simply call return, and we will pass the value. The only catch here is that you have to specifically tell that what data type you want to have as an output. So here you can see we have taken in a unt, so we are returning 1. If we are returning boolean, so we have defined boolean. We are returning unt, so we are defining unt as a 2. So that's the very important things which you have to keep in mind. So this is the very first function. Now let's build another one. We'll call it return values by name. You have that option as well. So earlier what we have done, we have returned the value without a name, but you can do with the name as well. So we're going to create a function, we'll call it name, and that we have to do the same thing, public, pure, and it will become returned, and that we have to define the value type and the data type. So unt is going to be x, boolean is going to be b, and unt is going to be y. So this is the name type I have defined that X is a UNT, B is a Boolean, Y is a UNT. So this is the data type of the value which we want to return from this function. So we're going to simply call it return, and we have to pass the data. So this is the name type which you allowing to return the data. Now let's create another function. We'll call it return values can be assigned to their name. Okay, let's, in the case the return statement can be omitted. So let's create a function for that. We'll call it public pure return, and we want to return this. So we'll say UNTX, we'll call it boolean B and UNT Y, and we want to simply return that. So here we can come, we'll call it X is equal to 1 because we haven't defined any variable to the X. So you can also define the variables and then you can return. And because we have already taken this name, so we have this name, so we don't need to define data type here, because here we have already declared that it's a UNT type, and we can simply update the data here before we return from this function. So let's update that. Same thing we have to do for the B, it's true, and Y is going to be 2. And this is the one way to update, and simply destructuring assignment. So hope that makes sense. Now let's destructure the data. So this is how you can do it very easy. So we can create a function that can return multiple values. So we'll say function, and we'll call it destruction assignment. Here we're going to call this public pure, we'll have this return. Inside that we have to define the data type, so UNT boolean, and this is gonna be a UNT because these are the data type we want to return. And the last one is going to be, let's say, okay, UNT, we'll make it, let's say, UNT, and we'll make it this. And here we want to deconstruct that. So this is how you can do it. And these all data we have into that. So we'll have this UNTI, boolean B, UNTJ, and we want to get it from here, return many. This is the function we have created on the top, and that we are returning these data, and that's what we are deconstructing here. So deconstruction is also possible. You can create a function, you are getting an output from there, you can deconstruct it into a different function, and you can access that data as well. So that's the exact thing we are doing here, because this is a very simple logic which you will find in most of the JavaScript programs. So it's just a simple JavaScript. Let's go ahead, and we have our deconstruction. Let's come down. We're going to simply value can be left out. So this is how you can do X, Y, and that you can simply update 4, 5, 6. That looks fine to me. Now you can simply return A, I, B, J, X, and Y. That's one way also. So these are the things we are returning in the above. So these are the return data type we have defined. Like we have taken I, B, and J, the 3 data type, and here we have defined the other 2, X and Y, and that's what we are returning. So hope this makes sense. Now let's come here. And here is one thing I want to highlight, that sometimes what happened that you cannot use map as an function input. So let me show you what I mean by that. So let's come here. Let's create a function. But you can take it as an array. So let's create a function. And that we're going to say array input. So it will be UNT type array and memory array. You cannot use mapping, but you can use array. Here we have taken a UNT type array, and that's what we're going to simply call it here. So this is the one way you can take data in the form of array to do and perform certain tasks. So this is one way to take the input, but you cannot use mapping. That's the important things you have to keep in mind. Take it array, and this is the one we want to have as an output. So we can say, and we can define the array we want to have as an output. Pretty simple. You can take data output as an array or as an individual, so you have both the option, but you cannot use it as a mapping. That looks fine to me. And let's come here, return the entire array, because that's what we want to return. Here we have taken a UNT type array, public array, and this is what I want to return. And here we have mentioned that we want to have the complete array. So that's the logic here. So make sure to keep these things in mind, that it can only work with array, not with mapping, because mapping is also work like an array. You can have multiple data into that mapping, but you cannot use that as an input or as an output. So that looks fine to me. Let's come down. We're going to, and now let's create a contract. And in this, I want to teach you that how you can put data into a function with the value pair. So you can assign a key and you can assign a value. That is also possible. So let's come here. We're going to create a contract. We'll call it X and Y, Z. And then we're going to create a function. We'll call some function with many input. And then we're going to define the input types. So UNTX, Y, we have the Z, and we're going to have this address A, boolean B, and we have this string memory C, and we'll have this public pure return, and we want to return this UNT. In that, what I'm going to do is I'll create another function. In this function, we'll call function, and it will be external pure return, and we're going to return a UNT. And in that, we have to define a couple of things. So we're going to return this function, the function we have created above. So function with many, and in that we're going to define all the inputs, because this function need an input to execute. So we're going to define without key value pair. So in that we're going to assign the values, not the key. Because you have both the option, you can assign the key value or you can assign the value as well, but make sure to follow the exact order we have defined in the function. Here we're going to define the address 0 and this. That's the one way. And now let's declare the function with the key value pair. So we'll come here, we'll create another function, we'll call it function with key value, and the same thing we have to do here. We're going to return a UNT, and this time we're going to call the same function some input may input, and we're going to assign this value because this is the one we want to return. A, what is A? So we have to define its address. B, what is B? B is a boolean value, true. We can define the C and go so on and so forth. So that's pretty simple thing. You can assign the inputs as a key value pair or without a key value pair, and you can use a output of one function into another function to perform certain tasks. So that's the entire smart contract. Hope this makes sense. If you still any confusion, make sure to rewatch to understand what is happening. So this is the entire function smart contract. You can see all the functions we have declared. We all have here. Now let's simply deploy the contract and let's try to have a look. So deploy, here we have the contract, and here we have all the functions. So first thing we have to do is here we have this array input. So where we have declared that array input, so the array input we have it's here. Here. This is the array we have, and here we have this array input. So you can declare that. You can call it to something like 1, and you can call this 0, because we don't have anything into this. That's why you can't find anything. The same thing goes from here as well. If you find something, if you put that, you will got nothing because we don't have into an array. Now if you call this array output, you can see this is what you will get. We don't have any data, that's why you get the empty array. If you call this assign, you will get this data because this is the data we are. So here we have this function called this assigned, and in that we are returning this 3 data. You can see this is the one we have updated, and that's what we are returning from these functions. So hope this makes sense. Now we have this Constructor. So if I call this function, you can see this is the data we are getting. So this is the data we have type we have defined. Here we are calling this function return many, this function, and from there we are returning these 3 data, and we are also updating X and Y, and that's all the data we are getting here: 1, 2, 3, 4, and 5, 6. So hope this makes sense. Now we have this name. If you call this name, here we have this 3 data, and that's what we are assigning here. You can see this is the one we are returning from this function. So 1, true, and the 2. If you call it return many, here you will get the same data, return many, and that's what you have here. Return many, 1, 2, 3. So what we have learned in this video, that you can create one function and you can use this function output in different functions, like the way we have used here in customer assignment. That's the one way we can assign and return. You can simply take the data as a key value pair or without a key value pair. So this is the without key value pair, and this is the with key value pair. So A, B, C, that's all we have defined to have an output. So that looks pretty fine to me. Hope this makes sense to all of you guys. If you have still any confusion and doubt, do leave in the comment section. I'll try to help you in that. That's the only thing I want to cover in this video. Hope this makes sense to all of you guys. Still, if you have any confusion and doubt, do leave in the comment section. I'll try to help you in that, and I try to explain one more time. With that, let's move to the next video. So let's try to understand what is event in Solidity and how you can utilize it into a smart contract. And the some major use case we have is that, just imagine that you have an event and if you want to update any data into the blockchain. So you can use this event, and when you use this event to store data on the blockchain, and it's cost you very less as compared to using the actual storage. So when you store data as a form of state variable, that will cost you higher amount, but when you use this event to store the data, it will cost you cheaper. So that's what we're going to learn in this, that how you can create event into the Solidity smart contract and how you can define. Let me provide the license identifier Solidity, and let's create a contract. We're going to call it event, and in that we're going to define. So when you define your event, you can pass only 3 indexing. You can have multiple data in the event, but the indexing is going to be only 3, not more than that, and it will allow you to filter the data. So what happens generally in the indexing form, that suppose you have data on the Ethereum blockchain and you want to index based on the address or based on the token ID, something like that. So you can have only 3, not more than that. So let's come here, let's declare an event. We'll call it log, and in that we want to provide the address. We'll call it index, sender, and the string message. So we want to have the data based on the index. So the address is going to be the index for that particular user to get this message. Let's create another empty event. So this is the blank event. We have this event, but we don't have anything into that event. So you can declare an empty event as well. So another logs. Let's come here, let's create a function to test this. So we'll call it public, and in that we have to declare the event. So we'll say emit log, and we have to pass the exact data. So we have to pass the person who's calling this function. So message.sender is going to be the address, and we have to pass our string hello world. So this is how we can update. And let's come here, we're going to say log message.sender hello world, and that's another way. Let's come down here, we're going to simply pass the empty event as well, and that's it. That's the only thing you have to keep in mind. So that's the event contract we have written. We have all the parameters and this function. So let's test this out. So if I come here, if I deploy this event contract, and here you can see we have this one. Here we are getting this only function because that's the function we have it here. Let's click on this, and here you can see we got this entire. But if I open this, entire log, here you can find that here we have this from, which we have called, this is the topic, and this is the event we have. You can see we have all the event. So this is the log we have defined, this is the data, the address, and the string, the address and the string, the define we have defined. So you can define multiple argument here. Here you can see we have these 2 events because we are passing different data in each of this event with the same sender, same person who's calling this function. So that's the entire data you can easily able to get. So this is the first event, this is the second event, and this is the third one, which is an empty, and you can easily able to get this data and fetch the data and display right in your front-end application. So it's a very important things which you have to keep in mind, and this will save a lot of money when you will use, instead of storage data, you can use this event to get the data from the blockchain. So that's the only thing you have to keep in mind. Hope this makes sense to all of you. If you have still any confusion, do leave in the comment section or rewatch the video to understand in a better way. So with that, let's move to the next. Solidity programming language, it supports multiple inheritance. So if you really want to inherit any other contract into your contract, then you have to use the is keyword, which is very important. And if you want to modify any functions, any outcome of that function, you have to use the virtual keyword. And if you want to do the change in the function itself of the parent function, then at that time you have to use the override keyword. I know it sounds abstract, but we're going to have a practical look at how exactly it's worked. Let me provide the general configuration, Solidity version, and now we're going to create a contract. So we'll say, let's have a graph. So let's try to understand the entire interface with the help of a graph, that how exactly it's work, because order is very important when you want to inherit any contract into another contract. So order is very important. It's very strict. So let's come here. We'll take A. So this is the A contract, which is a parent contract, and this A will inherit by B and C. Okay, and that B contract is going to inherit by F, D. So now that's how the inheritance works. So you have to follow the proper hierarchy, the way you define the contract in the single contract. Okay, so if you have a contract and that you have a multiple contract, so that's how you can inherit. You have to give a proper reference, otherwise it will throw you an error. So let's come here, inheritance graph. We're going to create our contract. So let's create a first contract. We'll call it A, and in that we're going to create a function. We'll call it foo, public virtual, and it will say string memory, and in that we want to simply return this A. That's a simple function, simple contract which have this foo function, and when you call this function you will get an A. Now we can come down, and here we're going to create another contract, and this contract is going to inherit this A contract. So let me give this comment by using the keyword is. Let's create a contract. We're going to call it B, and we are using this is keyword to inherit our A contract. And this way we can easily able to have the access of the contract A, and the default output of this contract is going to be A, because you can see if you look at the contract A, in that we are returning A. So that's the default output of foo function. Here what we're going to do is we create another function. We'll call it foo public pure virtual override, and this is going to return the string. And here we're going to simply call the B, because here we are using the foo function from a contract A, and we have used the virtual and the override keyword to update the data. So right now if we call a normal foo, we'll get A, but here we are changing the data, so we are returning B from here, and that's how you can do it. So this is the B contract. Let's create another contract C, and we're going to inherit A, and the same thing we're going to do here. So we'll override A to return something else. So virtual override, we have to memory, and we have to simply return this C. So this C contract is going to return C. We are using that A function, foo function, and modifying it and getting our desired result. So this is how inheritance work. And now let's come here. So a few points to keep in mind, that a contract can inherit multiple parents contract. When a function is called, that's define multiple items. Okay, so the parent contract are search for that right to left, and that's how the manner exactly work. The order is very important if you want to inherit the contract. So let me show you the practical demo. So what I'm going to do, I'm going to create a contract. I want to create a contract by D, and I want to inherit, and that's the reason, because it's on the right hand side, the last one. We have the same two function in both the contract, but the C function is getting called because it is the most right side. And that's how the Solidity inheritance work when you want to inherit the functions. So if you are importing multiple contract, then that's how it's worked. The most right parent contract is going to be executed if they have the fourth function name. Okay, that's the things you have to keep in mind. So that's what we have here. Now we're going to create a function. We'll call it foo override VC, and we want to return this. So we are passing the same thing, override B and C, and we're going to simply return this super function in both the way. Now let's come here. Let's create one more contract E. We're going to do the opposite way, because this time we're going to export the output of the B contract, because B is the most right hand side, and the output is going to be this B. Since B is the right most parent contract with the function foo, and here we're going to simply have the same output. We have to pass the way we have inherit the contract, the same we have to provide in the override section, B and C and B, and we want to simply return the data from here. So string memory, and we want to return the super function, and that's the only thing you have to keep in mind. Okay, so let's come here. We're going to create an inheritance must be order from most base like. Swapping the order of A and B will throw a compilation error. We're going to see that what is the error I'm talking about, but I want to give you this note so you guys can keep in your head that there are rules which you have to follow if you want to inherit the contracts. So let me show you. Let me write the code. Let me write a contract F, and we want to inherit A and B in this F contract. So the function we're going to create this foo override, and we want to override A and B return, and we want to return this memory. In that we're going to call this super, and we'll call it foo, and we want to simply return that. So that's the one we have, and that's the entire smart contract we have written. Here we have the entire smart contract for the inheritance. You can see we have A contract, we have B, C, D, E, and F, and we are inheriting one contract from one another. So that's a nested contract. So let's come here. Let's try to deploy. Let's delete the old one, and here we have this multiple contracts. So if I come here, if I deploy this contract, and here you can see we got this one, and if I click on the foo, I'll get the A. Let's try to deploy the other contract. If I call this B, if I call the deployed, and I'll get the B. So let's close this one, and here I have the B contract. If I call this, I'll get this B. A and B, we have this two contract. But what I want to do is I want to simply inherit in the C as well. So let's come here, and this is the C contract. If I call deploy, and here we have the deployed, and if I come here, so here what I have mentioned that the default output of this A is A, but we are using this override property and creating a virtual, so this one override, to update this C. So if I call this function, I'll get a C. That's what I have mentioned here. We will get a C. Now here what we are doing is that here we are creating this D contract and we are inheriting this B and C. But as because of this C is the most right parent contract, so this function is going to be executed from here and we'll get this C as an output. So let's come here. So what is the name? D. If I come here, if I click on D, if I click on deploy, the contract is deployed. And if I call this foo function, I'll get output FC. So if I click on this C, and you can see this C, because this is the rule we have in the Solidity. Because both B and C have the same function, but we are getting this C because this one is the rightmost parent contract. If we take this E contract example, if I deploy that as well, and if I simply deploy this E contract, call this one, I'll get a B. And that's what I have him, because this time the B is the most parent contract on the right hand side. But here if we have this F, and if I call this function, can you guess what will happen? So let's try to check this out. If I come here, if I go to this, if I call this F function deployed, sorry, and here we have the F deployed, and here we have the foo. If you call this time, you get a B. Hope this makes sense to all of you. You guys have understood that why everything's happening, how the inheritance work in multiple contracts. Order is very important, and make sure to rewatch this video if you have still any confusion to understand better that how exactly it's work. With that, let's move to the next video, and if you have still any confusion, any doubt, do leave in the comment section. I'll try to help you in that. Have a wonderful day. So shadowing is one of the concept in Solidity smart contract. It's allowing you to inherit state variable. So unlike functions, state variables cannot be override by redeclaring in the child contract. So let's see what exactly it is. Here we're going to create a contract A, and in that we're going to declare a state variable and we're going to assign a value to that. So name is going to be, say, contract A. So this is our state variable, and now we're going to create a function. We'll call it get name, and we want to simply get this state variable. So we'll call it name. That's a pretty simple contract. All it does, it has a state variable, it has a function. So when you call this get name, it will return the state variable, and which is a contract A. That's a pretty simple function. Now here I want to highlight a couple of things. So in the earlier version of Solidity, it was not allowed to inherit the contract like this. This is not the way you have to go. So the exact way is to do like this. So let's come here. Here we're going to create another contract. We'll call it C, and this time we want to inherit contract A, and we're going to simply change the data, override that. So this is how we can do it. This is the correct way to override inherit state variable in the contract A. So what we can do, let's come here, we'll call it constructor, and that we have to pass the name and we have to simply update that. And that's pretty much. Here we're going to simply get the return is to contract C, and that's pretty much. That's the way you have to simply update the state variable. So here we have the entire smart contract we have written for the getting the notion of the shadowing concept in Solidity. You can see this is the contract, first contract we have, and this is the C contract. Now let's deploy this one. This is the two contract we have. Let's deploy the first one, and if we deploy that, here we get this. If we call this name, we'll get A. If we call this, we'll get the A. Okay. Now the point is, let's come here, and now we have to deploy the contract C. If we deploy the contract C here, in this we have this two functions. So if we call this name, you can see we'll have an output as a C, but if you call this one, it will have an output as a C. So you can inherit the parent contract and you can simply update the state variables. So here what we have done, here we have declared the state variable in the parent contract, but we haven't declared here in the child contract, the C contract, but we are inheriting this A. With the help of this constructor, we are updating that, and we are getting an output of a C. So that's how the exactly works. So if you want to override the property of a state variable in a parent contract and use a different property in a child contract, that's the way to go. So that's how you can change the state variable. So hope this makes sense to all of you, because this is going to play a huge role when you will work in the actual project, when you're going to communicate with a different contract but want to have a different values. So that's the important things you have to keep in mind. If it sounds confusing, don't need to worry at all, because we're going to build up a project, and on that we're going to explore each one of this. The reason why I'm explaining you this concept, shadowing concept, because you have to know this all things, because when I will use this, I will use it straight away. So on that time you guys not feel like that what I'm talking about. Okay, that's the only reason I'm covering all of these concepts which are there in Solidity. So hope this makes sense. If you are still in confusion, end out, do leave in the comment section. I'll try to help you in that. And with that, let's move to the next. You might have seen super keyword in Solidity smart contract, but what it does and why we use super keyword, what are the functionality we have, and what are the way we can initialize super keyword in the contract. Follow the general convention, provide the license identifier and Solidity version. And now let me create the hierarchy. So super keyword will allow you to inherit the parent contract. So this is how the entire interface tree looks like. So let me call this inheritance tree, and first we have the first contract A, and from this we will have this two contract B and C. So B and C will inherit the A contract, and then we're going to create another contract D, and that D going to inherit B and C and A. So it will inherit all the three contract. So let me show you by the code. So let's create a contract. Let's create a contract. So let's declare an event, and we're going to log that event into our console to see that what data we are getting. So let's declare an event log. In that we're going to pass this data string, the message. Now let's come down. We're going to create a function. We'll call it foo, and it's going to be a public virtual. And in that we're going to simply emit that event, the event we have created. So in that we're going to pass this data a.foo called. So this is the data. This is the first function we have. Now let's create another function. This will call bar, and it's going to follow the same structure. And in that we're going to emit this event. So in this we'll call it, and now we're going to close this contract. Now what we're going to do, we're going to create another contract by the name B, and this time we're going to inherit the A contract using the is keyword. So I hope you haven't forgot that why we have used is keyword, because we want to inherit the above contract. So let's provide the name of the contract, and now what I'm going to do is let's declare a function. We're going to call the same function name foo. Here we have the foo public virtual override, and here we come, and here we're going to initialize the event. So you have noticed one thing, that here in the B contract we haven't initialized the event because of A we are inheriting. That's why we have the access of the event from the A contract. So let's initialize that event, and in that we're going to call this b.foo call. And this event is coming from the contract A. So that's the things you have to keep in mind. That's the pretty simple thing, and we go to call this a.foo. So this is the one way to declare and call the contract A function by the name itself. So you can call it A and you can call the function. So this is the one way to declare the function. Now let's come here. Let's create another function. We're going to call it bar virtual override. Let's come here. We're going to call this emit log b.bar called. So we're going to call this super. And this time in this function what we have done is, still we are calling the contract A, but instead of writing the A we have used the super keyword, and this super keyword will work in exact the same way. Let's close that. So this is the first contract B. It's inheriting the property of A, and we have used the foo function. In that we are calling the contract by the A, by the name, and then we are using the super function, super keyword in the bar function. That's clear. Now let's create another contract. It will call C, and in that we're going to inherit the A property. Pretty simple. We have to do the same thing. Let's create a function virtual override. In that we're going to call this event. Now we have the event. Let's call this function. Same logic we are following, because C is also inheriting the A. And the reason why I'm giving you this multiple example, because you have to understand everything, that no matter what is the hierarchy, what is the tree, it's all important that how you are inheriting the contracts and what is the hierarchy of the contract. So that's what we have here. You can simply inherit that, and you can simply call the other function bar, and you can use this same super keyword. You can log that event and you can call the super bar, and that's pretty much. So that's our C contract. Now let's come here. We're going to create another contract D, and in that we're going to inherit B and C. And in this scenario, D will have the access of all three contracts, B, C, and A, because B and C is also inheriting A. So in that way, D will have the access of A contract. So let's come here. We're going to create a function called foo virtual. In that we're going to pass this, because we want to override the B and C contract. In that we're going to pass that, and here we're going to call the super.foo. And can you guess from where we are getting the super keyword? I believe that you got it. Super keyword. Let's create another function override, and then we're going to say B and C, and we're going to simply call the super bar. Let's close that one. So that's the pretty much of the contract we have created here. And here you can see I have given this logs. So right now you can see that it seems like complicated thing for all of you guys, but don't need to worry. What we're going to do is when we're going to call each of these function, we have to check the logs that what exactly happening. So here you can see when you will call this contract, it will inherit the A, B and C. As I told you that it will inherit all the three contract, and it will first call the C and then it will call the A. So that's how it will going to follow, which is not that important. Don't need to worry about it. Now what we can do is, now let's check this entire contract in the remix ID. So this is the contract we have written. This is the A contract, this is the B contract, this is the C contract, and this is the D contract. So let's deploy that. If we click here, we have these 4 different contracts. So let's deploy one by one. First we're going to deploy the A contract. Click on this deploy, and here we have the logs. If you come here, if you click on this A contract, so here we have the A contract. In this we have these 2 function, foo and bar. So let's click on the bar, and let's try to have a look at what data we get in the console. So the transaction went successful. If we come here, click on this, and here you can see this is the log we have. So this is the data we have passed in the foo function. So we have called the bar. Okay, we have called the bar. So in that we have this bar called. You can see this logs we got. If we call this bar, here you got it. You can see this is the another data we got here. So this is how you can access the data from the blockchain with the help of the event. So this is the first contract. Now what I'm going to do is let's deploy the other contract. Click on this, come to the contract B, and in this you will notice one thing, that the contract B is inheriting the property of contract A, just like this event. Okay, so here we have to deploy the contract, and here we got the contract. And if we come here, let's open the logs to see what data we get. If we click on the bar contract, so here you can see we are getting bar dot called. If we open that, here we have the data. So here we have 2 events. This is the bar dot call, this one, and then we have used this super keyword, and we are getting from here. So A dot bar, we have used this super keyword so we can easily able to access this contract A, because here we have specified that we are using the contract A in the contract B. So that's also working fine. Let's come here, let's deploy the contract C. And in the C contract you can see A is inheriting the C, so it will going to behave in the same way the B contract. Let's say check this D contract. So before we do that, okay, let's check the C first, because this D is dependent on A and C. So if we come here, this is the C contract, and if we click on this bar, here the transaction went successful. You can be able to find the logs. If you call the foo, the transaction went successful. Now let's come here, let's deploy this D contract. If we deploy that, the transaction went successful, and here we is the catch. So here we have given the couple of descriptions. So let's do one thing, let's call this foo contract first. If we call the foo contract, and let's try to look what data we get in the. So here you can see, as it mentioned that it's going to call the contract C, and that's what happened here, B dot bar, and then it will have the B dot bar. So first it called the C, because it will start always from the topmost left hand side. First it will have with C, then it will go with B, and that's what we have here, B, and then we have the C. It's called all the contract. If you call the foo contract, it will have the same behavior. So when you want to inherit any other contract, you can use the super keyword, or you can use the direct name. And when you use the super keyword, it's going to take the first contract in the smart contract. Hope you have learned something new in this video. If you're still any confusion, any doubt, do leave in the comment section. I'll try to help you with that. Have a wonderful day. Let's learn about visibility in Solidity. What is visibility and where we can use it, and how we can utilize inside the contract, and when we want to inherit any other contract, then how we can define the visibility. And that's going to be the topic of this video. There are 4 types of visibility. Number 1 is public. So any other contract and any other account can call that function or that variable. The second one we have is the private, as the name suggests that it can be only used privately. The third one we have is internal. So it can only work internally, and it can inherit the functions. The last one we have is external. So any external accounts or any external contract can call that function or variables. Let's do the general configurations. Solidity, And now we have to create a contract. So we'll call it base. Inside that, so here I'm giving this comment so you guys can keep in mind that what is private functions are doing. So let's try to see the function. So let's create a function and we're going to call it private function. We're going to call it private because this is how you have to define that what type of function you're going to create. It's a private or it's a public or it's external or it's internal. So this is the place where you have to define the function visibility. It's going to be a pure, it will be returned and it will be returning this memory. So we want to return the string. Inside that we're going to simply return this string, so private function called. So this is the very first function we have. Now let's create another function, and in this function we're going to test the function we have created and we're going to call that function. So let's call it public pure return, and we want to simply return this string, and in that we're going to simply call the function, so the function we have created. That's the simple logic. Again, if it sounds complicated, we're going to test this code and I'm going to show you that why it's happening in this way. Now let's talk about the internal function. So here is the command to keep you and remind you that what we are doing here. Let's create a function. We'll call it internal function, internal pure internal pure return, and it's going to return the string memory. In that we're going to simply call this internal function called. So this is the simple internal function we have created. Now let's come down, let's create another function and we're going to call it test internal function. It's going to be a public pure virtual returns, and it's going to return this string we have defined. We're going to call the function. It's going to work. Now let's come here. Now let's create the function. We're going to call it public function, public pure return. It's going to return the memory, and that we're going to simply return this string public function called. So this is the public function. Let's come here. Let's create a function. We call it external function. External, it's going to be pure return. It's going to return the string. So in that we're going to simply return this external function called. That's the simple function we have written. We have provided all the visibility, external, internal, private or internal. Everything is looking fine to me. Now let's come here. We're going to, and this is the one note you have to keep in mind. So when you want to call an external function using a public, in that way it's not going to be compiled, it's going to throw an error. So this is the exception it has. It will always throw an error. We're going to declare a couple of state variables and we can try to access those data. I believe that you guys have already seen that how we are accessing those state variable by assigning a public keyword. And let's come here. We're going to create a string private variable. So it's going to be private, not public. We have to take another variable. It's going to be internal variable. It's going to be another string. It will be say public, and we're going to say public variable. Let's take the state variables. Cannot be extreme. So this is the exception we have, that you can use it private, you can use it internal, you can use it public, but you cannot use as external when you have to define the state variable. So that's the exception we have here. So let's create another contract and we're going to call it child is base. So we are trying to access the parent contract, which is a base contract, and the contract we are creating is a child. So nothing new to all of you. Let me give this command. You cannot access private variables or state variables. So let's create a function. We're going to call it, let's say, test internal function public pure override, and we're going to return this string, and that we're going to simply return this internal function which we have declared in that parent contract. And let's close this one and let's come here. So that looks pretty fine to me. So this is the entire contract we have written for both this base contract and the child contract. And now we're going to test this out, that which function we can easily able to access. So few things you have to keep in mind, that private function, private variables are not accessible in the child contract. So let's test this out. So this is our entire Solidity smart contract we have written. Inside the base contract, we have all these function we have created. So private, public, internal, public, and this we have public, external, and we have couple of state variable with different visibility. And this is the child contract in that we are trying to inherit the parent contract. So let's try to deploy it. If we come here, here you can see we have these two contracts. So first we have to deploy the first one. If we click on this deploy, if we come here, you can see we have all these functions. And if you notice one thing here, that the first function we have is this private. So this one is not displaying, this one is external, this one is public, this one is also a public, and this one is testimonial, and this one is a test private. So okay, so this function is not here because we have assigned the visibility to private, so we cannot have that. This is the private we have and the visibility is the public. So let's test this one out. So test this one out. So this is the contract we have. Let's click on this, and that's the return we can get. You can see this is the return we can get from here. Now we have this public function. So this is the public function we have. If we call that one, this is the exact information we are getting here. Now we have public variable. So this is the variables we have defined. Now this private one, this is what it is. It's a public. So this is the variables. If we click on that, we can get it. But those function declared as a private, you cannot have the access or you cannot get the getter functions. So I hope this thing got clear. Now let's come here. Let me close this one and let's try to deploy the contract child, because this contract inherit the property of the base contract. So let's deploy that one. Our transaction when successful, if we open that, and these are the function we are getting. So if we look at the child contract, and that we have these functions, but here we have a lot of functions because we are inheriting the base contract, and because of that we have access to this data. So this is the contract we have, test internal. So test internal, this is the function. If we call it, you can see you can easily able to get the information, and this function we have here, internal function, and this is coming from here, internal function where it is, and this is the function, and from here we are getting the message. So hope this makes sense to all of you. You guys can understand that how everything's work, how the inheritance work, and how you can easily able to access different data in different contract and assign different visibility. So hope this visibility concept got clear to all of you. If you have still any doubt, in any confusion, do leave in the comment section. I'll try to help you in that. With the time being, so hope everything is got clear to all of you guys. If you have still in doubt, any confusion, do leave in the comment section. I'll try to help you in that. With that, let's move for the next video. There was a debate among the students that interface is a contract or it's just a library. In this video, we're going to learn about interface, that what it is and how you can create and how you can inherit that interface into your smart contract. So there are a couple of facts which you have to know about the interface. Interface cannot have any function implementation. So I will explain what is function implementations. Interface inherit from other interface. So you have one interface, you can inherit the property of other interface into that interface. All declare function must be external, cannot declare a constructor, cannot declare state variable. So these are the couple of property of interface when you want to create. So let's have a practical look. So let's provide the general configuration. We have to provide the Solidity version. Now we have to create a contract, and we're going to call the contract to counter. And in that we're going to define our couple of variables. So it's going to be unt public, and we're going to call count. Let's come down here. We're going to create a function we'll call increment, and it's going to be external. And that we're going to simply call count plus 1. So we want to increment our state variable by 1 every time someone will call the function. It's pretty simple function. Now let's come here. This is the first contract we have, and now we're going to create an interface, because this is what the topic is about, interface. So we have to, if you want to declare interface, you have to use the keyword interface, and we have to give the name. So you can give whatever name you want to your interface, and in that we have to define all the functions. So let's come here. Here we're going to call this function count, and it's going to be external, view, and return. So there are a couple of property of the function which you define in the interface which you have to follow. So first, it will take the normal function keyword, then you have to define the name of the function, and it's always going to be an external type. No private, no public, no internal. It's going to be an external type. You can use view and you can use pure. It's totally up to you, and you can return the data from the function or you can't. It's totally your choice, but it will always follow the external. And you cannot declare any variable, you cannot declare any constructor into your interface. So let's declare here. That's the few things you have to keep in mind. Now let's come here, let's create another function. We'll call it increment external, and that's how you can define the interface. Let's create another contract. We'll call it my contract, and that we're going to create another function, and we're going to call this increment functions, and in that we're going to simply take this data address external, and we're going to call the increment interface we have created. In that we're going to pass that count increment. So can you please explain me what is happening here? Write down in the comment sections and just tell me what is happening here. So here what we are doing is we are creating a contract, in that we are creating a function. Inside the function we are taking an address, and that data we are taking, we are passing into our interface, and this is how we got that interface into our my contract, I contract. We are passing the data and we are calling the increment function. So whenever someone will call this function, it will store the data and it will increment that number. That increment function is there. So that's the pretty simple function we have here. Now let's create another function. We'll call it get count, and in that we're going to pass this data. External view return is going to return the unt. We have to return our counter, and we're going to call this count function we have here. Now we're going to take the example of the Uniswap. So I believe that most of you are following the Uniswap decentralized exchange which we are working on. If you haven't followed that, make sure to watch, because that's going to be the huge thing. And I'm going to take the example from there to explain you that how exactly work. So let's come here, let's declare the interface. In that we're going to call this Uniswap v2 factory. So there is a contract is available in the Uniswap documentation, you can check it from there, and that's what I'm going to use it here. So let's come here, we're going to call this function get pairs. It will take the token address A, token address B, and external, and it's going to be view, and it's going to return me the address of the pairs. So this is the very first function. Let's create another interface. We'll call it Uniswap v3 pair. In that we're going to create this function get reserve external. It will be view, and it will going to return the address, sorry, unt 112 reverse 0, unt 12 reverse 1, the two tokens, and it will have this unt which is a time block stamp, and that's the get reverse function. So I'm not coming up with this because these are there in the Uniswap smart contract, so you can simply refer back there. So that looks fine. Let's create a contract. We'll call it Uniswap example. In that we're going to take the address which is a private type. Factory is going to be this. So this is the address of the Uniswap v2. Again, I'm getting from the Uniswap contract. This is the first address. Let's take the another one which is a private DAI address. This is the DAI address on the mainnet. And let's take another one. This one is the WETH address on the mainnet. And let's come down here, we're going to take this function called get token reserve external view returns unt, that's the two data we want to return from there. And in that we're going to simply call this add pairs, and we're going to call this Uniswap v2, and that we're going to pass the factory, and we're going to pass the pair, get pair. In that we have to pass the two token address. So let's pass that one. Here we have the two token. Let's call this unt reserve, and we have to pass all this data, and we're going to call this pair get reserve. Then we have to simply return these two, and that's it. I know most of you guys are confused at what I have done, what we have written, but it will make sense. Here we are trying to learn about the interface, that how exactly it works. So this is the entire contract we have built to learn about interface. So this is the first contract. In that we have this variable, we have this increment function. Then we have this interface. Inside the interface we have this to function. Now we have the second contract. In that we have this to function, and this is the interface for Uniswap v3 factory get pair. In that we are passing these two data. Here we have the second interface which is a Uniswap v3 pair. In that we are passing all this data, and this is the contract factory address, and this is the two token address, and this is the get token reserve. So right now I don't have this data, but I want to show you. So let's come here and let's deploy the contract, the first one. So let's deploy that one. If we click on this deploy, here we got it. If you come here, you can call this count. You can see you got this 0. If you call it increment, if you come here, you can see it's working. It's incrementing. So this contract is working fine. So this is how the interface exactly works. This is how you inherit the property. Right now it's not working because we are not providing the valid address, but it will make more sense when we write the smart contract. So make sure to watch the Uniswap smart contract we have written for the decentralized exchange, and that we have inherit this Uniswap smart contract addresses. So make sure to access there to watch that, to have a better understanding that what exactly is happening here. Rewatch the video and trying to understand that how we are inheriting the property. The only thing you have to keep in mind that inheritance is not a smart contract, and if you want to inherit, you can define it and you can use it in the contract like this. This is how you can initialize and use it.
Let's try to understand the payable keyword in Solidity Smart Contract. So when you declare payable keyword in any function, you can easily able to receive ether in the contract. Follow the general convention, and now we have to take this Pragma Solidity version. Let's create a contract. We'll call it payable. Inside that, we're going to declare a couple of commands. So payable address can receive ether. That's true. We're going to define the address. We're going to make it payable so it can receive fund, and we're going to make it public so we can check what is the address. So here we have taken a variable which is address, payable, public, and honor. Simple variables. Let's come here. So when you declare payable in the constructor, it can also receive ether. And let's come here, declare constructor, we'll make it payable. And here we're going to define the honor. So honor, and who is the honor? Message.sender, the person who's deploying the contract. So he can receive some ether. So that's the simple constructor we have. Now we're going to create a function that to deposit ether into this contract. Let's create a function, deposit. It will be public payable because we want to pay. And this function will going to create function. We'll call it not payable public. So if you try to send fund with this function, it's going to throw an error because we haven't defined the payable keyword into this. So these are the two functions we have. Let's come here. We're going to give this command. And now we have to build the function for withdrawing the ether. Let's create a function. We'll call it withdraw public, and here we're going to say get the amount of ether stored in this contract. So we have to get it. For getting that, we have to take this unt amount and we have to say address this dot balance. So this will give us the balance of the contract, that what balance we have in the contract. Address this means the contract, or you might have seen address 0, that's also referred to the contract. Send all ether to honor. So we'll call it honor can receive ether since the address of the honor is payable, and that's what we have declared on the top. So let's call bool success. We have to take a boolean value and we have to say success, and that we have to call honor.call value, and we have to take the entire amount which the contract has, and we're going to call this method call. This will send the money back to the honor address. And here we're going to call this require. So we have to check whether transaction went successful or not. So if boolean is false, then it's mean that the transaction went fail, and if it's true, then it's passed. So we'll fail to send ether, and that's it. Let's come here. Let's create a function to transfer ether from this contract to address from input. Function transfer, in that we're going to take this address payable, and we're going to take this to amount that where we want to transfer. So we have an address and we want to make that address as a payable so it can receive fund, and we are defining the fund, and we are making it public so anybody can call it functions. Simple function. And let's do the same thing. So the same thing we have to do, we have to pass the amount which we are getting, want to transfer, then we have to do the check that whether the transaction went successful or not. And that's the only thing we have to know about this payable keyword in Solidity, that how it's going to receive fund, how it's going to send fund, and how you can send the transaction, the contract balance to your own. So let's check this out. Let's test this out. So this is the entire payable contract we have written. In that we have all these functions and the honor. So this is the honor, this is the constructor, this is the deposit function, this is the not payable function, this is the withdraw function, and this is the transfer function. So what we can do is let's deploy the contract. This is the only contract we have deployed, and here we got the contract instance. In that we have all these functions. So the very first function we have this deploy, and this function will allow us to add ether into this contract. So right now you can see we have this 4. Okay, I don't know from where it came. So let's try to deposit that. Maybe I have predefined the value here, that's why it got added, because we have made our constructor payable. Okay, so this 4 ether came at the time of deployment. By mistake I have added the 4 and it's got deployed. So we have that. Now let's deposit by this function. So I want to add, let's say 5. If I call this transfer, the transfer went successful, and here we have this 9. If you call this payable function, so right now we don't have anything, let's call this 1. And if I call this not payable, it will throw an error because we haven't assigned payable keyword to this function, and that's why it cannot add fund into the contract. So that's also look fine. Now let's check this function, withdraw function. So in the withdraw function we want to take the entire amount. So right now we have this 9, and I'm the owner of the contract, so this address is the owner. So right now we have 87. So if we call this withdraw function, you can see the amount will become 0,
and 0, and here you can see this amount got updated 96. So we can easily able to withdraw fund from this. If you want to transfer, you can do the same thing. All you have to do is to provide the amount and the address, and you can easily able to transfer. So that's how the payable concept work. You can easily able to add the fund at the time of at the time of contract deployment, which we have done. You can check the honor, you can do all the things. That's a pretty simple things in the Solidity smart contract. If you want to receive fund in the contract, or you want to make it payable to any function, so you can transfer the fund to anyone else, then you have to define the payable keyword, and that's the only thing you have to keep in mind. So with that, I'm ending this video. Hope you have found this video valuable. If you have still any confusion and doubt, do leave in the comment section. I'll try to help you in that. With that, let's move to the next video. So when you will send Ether in any contract or any wallet address, there are a couple of methods in Solidity which you can use to transfer the fund. And those three methods we have here in the Solidity. The first one we have is transfer, the second one we have is send, and the third one we have call. So let's see in practical each one of these, that how exactly it works. Let's follow the general convention. License identifier, we have the Pragma Solidity version. Let's declare the contract. We'll call it receive Ether. And here we have to build the hierarchy. So let me build that. And these are few points I have written which you have to keep in mind. Which function is called? So we have two functions in Solidity to receive the fund in the contracts. The first one we have is the fallback, and the second one we have is receive. When anybody will send Ether into the contract, if message.sender.data is empty, in that scenario it's going to call this receive function. But when it has some data, it's going to call this fallback function. So when anybody will send any transaction to the normal wallet, it's going to call this function, and that's how you can keep in mind. But when the transaction will have any data, it's going to call these functions, and that's the only thing you have to keep in mind. Now let's declare the function to receive Ether in the contract if the message.sender data is empty. So we'll call it to receive. It's going to be external type, so anybody can send the Ether into the contract, and it will become payable. So if you want to receive fund, you have to make it payable, otherwise it will not receive fund and it will throw an error. So this is the receive function we have. When we have the data, then we have to call this fallback function. Fallback external payable, so it can receive. We're going to create a function we'll call get balance public view return, and it's going to return the UNT, which is the amount in Ether. And here we're going to declare the return the balance of the contract. Address.this balance. And let's come here, let's create another contract we'll call send Ether, and in that we're going to create a function we'll call send via transfer method. So as I told you, we have three methods. One, we have the transfer, then we have the send, then we have the call. So this is the transfer method. In that we're going to pass the address, and we have to make it payable, that address, so it can receive fund. In that we're going to pass the address where we want to send the amount, public, payable. And in that we're going to simply, so this method is not recommended to use in your smart contract to transfer the fund. We're going to create that to.transfer. We have to use the keyword transfer, which is inbuilt keyword in the Solidity smart contract. In that we have to simply pass the value, the amount we want to transfer, and that's the function we have. Let's create another function we'll call send via send. So now we're going to use the send method to send the fund into the contract. So we have to define the address payable to public payable. It will always return the boolean value whether the transaction got succeed or fail, and this function is no longer recommended to use to transfer the fund. Let's call this bool send, and that we have to call this to send method, and we have to simply pass the value. If it's when successful, then it will become true. If it's false, then we have to display this error message. Simple function we have here, how to send Ether via send method. Now let's create a third function which is a send via call. It will do the same thing. Add public payables. Now here we have to, so this is the recommended one by most of the advanced developer in the Solidity space. If you want to send the transfer, you have to use the call method. So let's call boolean, it will say send, and then we have to send the byte data memory. We have to call this to call, and we have to simply send the value, and we have to call this empty functions. Then we have to check whether the transaction went successfully or not, and that's it. And that's the thing you have to keep in mind. So this is the recommended method which you can use in your contract to send the transfer of Ether. And hope this makes sense to all of you. These are not that complicated, very simple function we have written, very simple smart contract. So this is the entire contract we have written for receive Ether, and this is the another contract we have for the send Ether. In that we have all these three methods: transfer, send and call, and here we have defined this receive and fallback, and this is for the getting the balance. Let's deploy the contract. This is the only contract we have. First we have to deploy this receive one so it can receive the fund, and here you can see right now we have 0 into this contract. If we call this balance, we'll get the exact amount. Now we have to deploy the other contract to send the ether into that. Let's deploy it. Here we have it succeed, and here we have all this method. So now what we're going to do is, first we're going to send the ether via transfer one, and that we have to pass the address. So we have to pass the address of the contract. We're going to paste it, and we want to specify the amount we want to transfer. So I want to transfer this amount. So let's say I want to send 10 ether, and now I can simply call the functions transaction, and here the transaction went successful. If I close this one, and if I come to this transaction receive one, here you can see I have the balance 10. If I call this one, I'll get the entire, and this is in the terms of way. You can see I have 10 ether, so it's working fine. So this function is working fine. Now we have to check the other function. So let me close this one. We have checked this one. Now we have to check this send method, and that I'm going to transfer the fund, let's say close to what amount I can send. I can send 2 ether, and I can call this 2, and the transaction went successfully. You can see this is in terms of way. Now let's call this one. I'll want to send something like let's send this something. I want to say something, let's say 3, and let's do the transfer. It went successful. If you come back to the receive ether contract, in that you can able to find that this is the amount we have. First we sent 2, then we have sent 3. If we click on this, we'll get the entire amount in terms of way. So hope this makes sense, that how you can easily able to send transaction into contract. You can do the same thing for the addresses. It will both work in the same way. When the data is empty, it's going to call this receive function, and when there is a data, the data is not empty, it's going to call this fallback. So these are the couple of things which you have to keep in mind. And with that, we are ending this video. Hope you guys have learned something new. If you have still have any confusion and doubt, do leave in the comment section. I'll try to help you with that. With that, let's move to the next video. When you use fallback in the contract, and when someone will send the ether into the contract via transfer method or via send method, in that scenario, the minimum gas they have to pay is 2,300. And that's the only thing you have to keep in mind about the fallback. Now let's see in the example that how exactly it's going to work. Now let's follow the general conventions, and we have to provide the Solidity version. Let's create a contract, and we're going to call it fallback. Inside that, we're going to create an event, and we're going to provide a string fun, and we're going to provide a unt gas. This is our event we have now, and fallback function must be declared as external, and that's what we have done here. We have made it public external, so it can receive fund, and that we're going to define a couple of things. So when you use the send and transfer method, in that scenario, this is the gas fee you pay. And inside the fallback function, we're going to call our event. So we're going to say fallback, and we have to pass the gas, and which we have is gas left. Just simply call this function. Let's create a receive external payable, and that we have to define that logs receive and the gas left, the function we have to call here. And we're going to simply come down. Now let's create a helper function. So we'll say function get balance public view return is going to return the unt, and we have to simply check the balance of the contract. Let's create another contract we'll call send to fallback. In that, we're going to create a function we'll call say transfer to fallback, and that we're going to transfer the address. Sorry, we have to provide the address to transfer the fund public payable, so it can receive. And then we have to call the transfer method. Now let's create another function. We'll call it fallback. In that, we're going to use this payable. And the same method we have to call. Boolean send, we have to call this call method. And then we have to simply true the transfer. So I believe this is nothing new to all of you guys. This is what we have followed in the send ether contract. And the same thing we are following here. So that's the entire smart contract we have written. Hope this makes sense to all of you. We have created 2 contracts, and in that we have built this logics. So now let's test this. now let's test this out. So this is the entire smart contract we have written for the fallback. This is the event we have. This is the fallback function. This is the receive function, and here we are checking the balance of the contract. This is the second contract we have. In that we have this 2 function, transfer ether and call ether. These are the 2 methods to transfer the ether. Now let's simply deploy the contract. This is the first contract we're going to deploy, the fallback. And here you can see this is what we have here. Right now we have this 0 balance. If you call this one, we have this 0 balance. Now what I can do is let's deploy the other contract. If we click on the deploy, here you can see we have the contract here. If you open that, we need to pass the address in which we want to transfer the funds. So simply copy this address and simply paste here, and do the same thing from here as well. And here we have to define the amount which we want to transfer. So I want to go with 5 ether. So let's call this fallback. So this function first to transfer. If we call that one, the transfer went successful. And if we see the logs here, you can see this is the function we have called, and you can see this is the address we have provided, and this is the entire log. You can see this is the receive, and this is the ID. This is the function we have called, and this is the gas, and this is the gas. So this function provided by Solidity. So if you want to check that what is the gas you have paid, you can simply call this function and you can have a log, and that's what we can see it. Let's call the other function. The same thing happened to this. If you come here, click on this, you can see the address of the contract, and you can see the receive and the ID and the amount, the function you have called and the gas you have paid. So this looks pretty fine. This is nothing complicated. It's pretty simple. All we have done, created 2 contracts, and we are logging the data of each of this one. So hope this makes sense to all of you guys. If you still have any confusion, any doubt, do leave in the comment section. And if we come here in the fallback, if you can see here, we have this 5. If we call this get balance, you can see this is the amount we have transferred into the contract. So hope this makes sense to all of you. The only thing you have to keep in mind that you have to check that what amount you are paying as a gas fee. So this is something you knew you have learned. So with that, I'm ending this video. Hope you guys have found this video valuable. If you have still any confusion, any doubt, do leave in the comment section. I'll try to help you in that, and I try to explain in a better way. So with that, let's move to the next video. In the last video, we have learned the fallback keyword in Solidity and what it does when it's come to receiving the fund. So if you haven't watched, I'll link in the I button in the description so you guys can follow that. In this video, we're going to learn about the call keyword in Solidity, and this is the recommended way to implement when you are transferring fund from one account to other, or from one wallet to another smart contract. Let's follow the general convention. We have to provide the Solidity version. Let's create a contract. We'll call it receiver, and this is going to receive the fund. Inside that, we're going to declare an event. It will say receiver received, and that we have to pass the address of the caller, the user who is calling this function. Then we have to assign the amount, and it's going to be the message. So 3 data we are passing: address, UNT, and this message. This is our event. Let's create a call of fallback function because we want to receive ether into this contract. Receiver, external, payable, so we can receive the fund. In that, we're going to simply emit this event. So this is the event we have created. Now we have to initialize that. So message.sender, we have to pass the amount, message.value, and that will have the amount, and we can simply pass the message. Fallback was called. So this is the fallback function we have. Now let's come here. Let's create a function we'll call foo. In that, we're going to pass the message. We have to pass the amount, and it's going to be a payable. It's going to return the UNT, and we're going to simply initialize the event. So we already have the event. Now we're going to call this value and the message. That looks fine. Now let's come here. Let's do certain calculation into that. And what we're going to do is we have to simply say x plus 1. So whatever amount, whatever ID it's providing, we're going to simply add on that 1. That's the simple things we are doing. Let's create another contract. In that contract, we're going to call it caller, because this is the contract is going to transfer the fund into that contract. In this, we're going to create an event. We'll call it respond. It will take boolean success by data. This is the 2 data it will take. This is the one condition. We have the address and we want to call. So we'll create a function. We'll call it test call foo, and that we're going to pass this address, the address where we want to transfer, public payable, and in that we're going to simply, and as you all know that you have to pay gas fee whenever you do any transaction on Ethereum blockchain. And in this, you will also have the option to customize and define that what gas fees you want to pay. If it exists more than that, then you want the transaction get failed. So you have an option that as well. So let's define that. We'll call it boolean. We'll take the boolean value. It will be success. It will take the byte, memory, and data, and we'll call this, we have the address, and we're going to call this method call, and that we're going to pass the amount, message.value, and we can define our gas fee. So this is the gas fee, 5,000. We don't want to pay more than that for this transaction. That looks fine. Now let's come here. We're going to call ABI.encoded with signature, and that we're going to simply pass this foo string UNT 556, and we're going to call this call foo and this. That's the simple things you have to do. And once we have that one, now we're going to call the event we have created. In that, we're going to simply pass the success and the data. That looks pretty fine to me. That's a simple function we have. So let's come here. We're going to create a function. Test call does not exist. In that, we're going to simply pass the address, payable, and we're going to do the same thing. We're going to take a boolean value. We'll take the byte data, memory data, and then we're going to call this function. And then we have to assign the ABI encoded with signature. We have to assign this data, and we're going to simply initialize the event. And that looks pretty fine. And I believe that you guys have understood that what exactly happening here in the call method. So this is the entire smart contract we have written. The first contract we have is the receiver. Inside that we have this event, we have this fallback, and we have this function. This is the second contract. We have this caller. In that we have this event, and we have these two functions, test call foo, and we have this test call not exist. Now let's deploy the contract and let's have a look. So first we're going to deploy this receiver. And if we come here, you can see right now we don't have anything into this. And if you want to check this function, you can pass the message and you can pass this. So I can pass, I'll say, hey, and I can pass 1. If I do the transaction went successful. And if I open this, open the logs, you can see the data which I have got. So this is the UNT I got 2, which I have returned. So it's working fine. These are the two data we have provided. Let's close this one. Let's deploy the other contract, and we're going to deploy that. This is the second contract we have. Inside that, right now we don't have anything into this. And in this contract, we have to pass this data. So we have to pass the data, the address. So simply grab this, and we're going to cause and paste here, and we're going to send that. The transaction went successful. You can see the transaction went successful, and everything looks fine. This is the custom gas fee we have paid, and right now we haven't transferred any funds. So if you come into this contract and still we have the 0, if you want to transfer the fund from, for that you can simply come here, increase the fund, and now you can make the transaction. If you call this, it's working fine, and here you can see we have this balance here. It will work in the same way if you come here and paste the address of the contract here, and if you again transfer the fund, and you can call this transfer foo, the transaction went successful and the balance got up. So it's looking absolutely fine. So this is the recommended method which you have to use whenever you want to transfer the fund, this call. And that's the only thing I want to show you, that how you can build a complex model to get the data and transfer the funds into the contract or into the wallet. So hope this makes sense. If you still have any confusion, make sure to analyze the entire code we have written and what's happening. Try to understand what these functions are doing. If you still have any confusion, try to Google it out and try to find out what is happening here. These are very simple one. So with that, I'm ending this video. Hope you have found this video valuable. If you are still confusion and doubt, leave in the comment section. With that, let's move to the next video. In Solidity, we have a keyword called DelegateCall. It's a low-level function, and that function is similar to a call which we use to transfer the fund from one account to other. When a contract A execute the delegated call to contract B, in that scenario, B contract will also execute. So with contract A, the storage of the message.sender and the message.value would be accessible. So let's try to have a look what it is and how we can utilize it into our smart contract. Let's provide the general configurations. We have to provide the Solidity version. Let me give this note. Deploy this contract first, and here we're going to create a contract. We'll call it contract B. The state variable will define in the contract B that would be similar to contract A. Only then we can easily able to call the delegated call. So let's define the variables. We'll take this UNT public num. We'll take the address public sender, and we'll take the UNT public value. So these are the three state variables we have, and here we're going to create a function. We'll call it set var. Inside that we're going to take this UNT public payable, so we can easily able to send that. In that we're going to take this data. We want to update our number. So this is the first function we have. Inside that we're going to update the sender, which we have inside this message.sender, and the final one we have is the value. So this will send the amount and a date into our state variable. So this is the contract B. Now let's create a contract A, and we have to follow the general convention, because the contract B state variable, whatever we have defined, that's the exact thing we're going to add into a contract A. So let's define the variable num, address, sender, and this is going to be unt value. So same state variable we have here. Now let's create a function we'll call set var address. In that we have to pass the contract we want to call the delegate. So that's going to be the contract address. Then we have to pass the unt, the number, and we have to be public payable. Inside that we're going to boolean success bytes memory data, and we have to simply call the contract. So delegate, and because here we want to refer to the contract B, and we are using this delegated method to execute our contract B. And in that we're going to simply pass this ABI dot encoded with signature, and in that we have to pass the function which we want to execute. So we have to pass this set vares, and we have to pass the amount, and the amount we are getting. Here we can come, and now that's pretty much. So this is the delegate method which we are using to transfer the funds. So hope this makes sense. The reason why I'm showing you this, because this is not that popular in the smart contract using this delegate call. Most of the smart contract you will find in that they use only call method, but I want to show you this keyword exists in the Solidity programming, and you can use this encoded with signature data to transfer to call the functions. So that looks pretty fine to me. And now let's test this out. This is the contract we have written to understand the delegated call. This is the B contract, and this is the A contract. So let's deploy that, and here you can see here we have the two contracts. So first let's call this B contract, and if we come here you can see here we have this function. So we have num. If we click on num, we have 0 sender, this is the 0 address, this is the value, and here we can easily able to call this function. So if I want to send any amount, I can simply call 5, and I can simply call this send. The transaction went successful, and if I come here, if I go into the logs, you can find all the data. This is the data we have provided. And now if you call this num, if you call this sender, if you call this value, everything is got updated. But this time we're going to use this contract A, and we're going to deploy this one. If we deploy that, you can see this is the contract, we got it, and from here you can easily able to call the function which we have in the B contract with the help of this delegated call method. If you call this one, you can see we have the same variables, but if we want to call that, we need the address of the contract B. We can simply open this one, and we can simply pass the address, and we can pass the number. So I can pass 6, and if I call this transaction, here you can see the transaction went successful, and you can call this one, you can see the updates, and we have called this function. So if we come here, if we'll open the logs, you can able to find the details. This is what we have provided, and everything's working fine. If you come in the B contract, if you call it, everything's looking fine. So that's how we can access the function of contract B with the help of this delegate method, and we can simply transfer. So the only thing you have to keep in mind that this is the delegate method which allow you to call the function on the base of the encoded with signature, and that's the only thing you have to remember. Pretty simple. Here we are using these functions, and that's what we are getting from here. And that's how you can call different contract with the help of this delegate method. So with that, I'm ending this video. Hope you have learned. If you still have any confusion, do leave in the comment section, and just try to play around with this code and see how the things are working. Okay, so let's move to the next video. When you want to call different contract, you have two ways to call. The first way we have is to call straight away by the name, and the second way we have to call by the low level calls. So let's have a look what I mean by that. Let's provide the general configuration, and we have to provide the Pragma Solidity version. In that, we're going to create a contract. We'll call it callee. So this is the contract we're going to call into a different contract. So let's define a variable. We'll say unt public x, and we have to take this unt public value. So these are the two state variables we have. Now let's create a function. We'll call it set x. In that, we're going to receive the x. It would be public return, and we want to return this unt. Inside that, we're going to take this x, and I'm going to update it to our state variable. That's pretty simple. And we're going to simply return the x, that what we are exactly the value of the x. So that's the simple function. Let's create another function. We'll call it set x and send ether. So we're going to take this UNTX, that what is the X we have, and we're going to make it public, and it will return the two data. It will return the X and it will return the amount. So let's do that. We'll say X is equal to this, the amount we are providing, and it's going to be the value is going to be the message.value. And now we have to simply return X and Y and close this function. So this is the very first contract. Now we're going to create a second contract. In that we're going to call these functions, and we want to understand the ways we can call different contract. So contract, in that we're going to call it callee. So because this is what it's going to call, we come here, we can create a function, we'll call it set X, and in that we're going to receive the address of the contract which we want to call. So I'm going to call it callee, and we're going to provide the address of that contract, and we have to provide the amount UNTX. Call that UNTX is equal to, we have to call the function we have set X, and we have to pass that X value because that's need to be executed. So we'll get our X value. Now let's create a second function. We'll say function X from address. So in that we're going to pass the address, and we have to pass the X, and we'll make it public. And in that we're going to simply callee this. We'll take the variable callee, and we're going to simply call the contract address. Once we have that, we're going to call this set X, and we're going to pass the value of the X. What is the X we have, and we're going to call that function. Let's come here. We're going to create another function. We'll call it set X and send ether. So we need the address because we want to access the different functions to call into this contract. So we need the address of the contract, and we need the amount. So we'll make it public so we can transfer the ether. And here we're going to call this X UNT and the value, and it's coming from this. So message.sender value, and we have the X. So we are deconstructing that and getting in here. So that's the pretty thing. Pretty much you need to know about the calling different contract into another contract. So these are the two contracts we have written, and now we're going to test this out, that how we can call this contract into this contract and to access all the function which it declare. So let's come here, let's deploy the contract. So here you can see the first contract we have to deploy this callee, deploy that one, and here you can see we got deployed, and here you can able to find the value of X and Y, which is currently empty. Now we're going to call the function this set X. I will pass 5 and I will hit enter. The same thing I have to do with this set X and send ether. In that I'm going to simply open that one, and in that I'm going to simply pass, let's say 5. If I hit the transaction, the logs, let's have a look at the logs. The transaction went successful. If I click on this, I'll 5, and if I call this, I'll get 0, because if I want to send the transaction, I need to make it select the amount we want to transfer and then click on the transfer. If I click the transfer, the transaction went successful. If I check the value, we have this 5 ether in terms of weight. So this one is working fine. Now let's close this contract, and now let's deploy the contract number caller, and let's deploy that one. The contract got deployed. Let's have a look in the console. So this is all the function we have which we declare in here, and now we can easily able to access. So to access the function of these contract, first thing we have to provide the address of the contract. So in that I'm going to provide the address of this contract, and now I can simply call it. So if I paste that one, and here I have to provide the amount, which is a X. If I call that, the transaction went successful. So that looks fine. If you want to do the same thing for the other one, here you have to do the same thing. If you want to send the ether, you can provide this address, you can send that 5, and you can select the amount which you want to transfer from here in terms of ether, and you can make a request. So if you make that, the transaction went successful. This looks fine. If you want to do the same thing for the address, you can do that. Simply pass that, and you can pass the amount, and you can simply do the transaction. So everything's working fine. No more error we have. If you open the logs, you can able to see all the data which you have provided. Okay, so that's how you can call the different contract into another contract. If you open that, if you call this one, you can see you will still have the same variable, because there is no changes you're going to make in the contract B, because you are trying to inherit that contract and you are getting the result in this contract, and you can execute the function the way you want, the data the way you want. So hope this makes sense. If you still have any confusion, try to analyze the code, that what is we had doing here, how we are accessing this contract. Just try to analyze this one. So hope this is making sense to all of you. Still have any confusion, any doubt, do leave in the comment section, and that's the only thing I want to cover. Let's move to the next video. One contract can create another contract, and that's what we're going to learn in this video, that how you can execute a contract and that will generate another contract. and what is the keyword to create a new contract, what was the old method, and in which version this new keyword is introduced. So that's all we're going to learn in this video. So let's provide the general configuration, license identifier, pragma, solidity versions. Let's create a contract. We're going to call it car, and in that we're going to define a couple of variables. So first one is going to be address, string, and we have this address public car add. So these are the three state variables we have here. And now let's create the constructor to update this data. So we'll create constructor. In that we have to pass the address of the owner. We have to pass the string, memory, and the model. So these are the two data we are passing. It's going to be a payable. And in that what we have to do is we have to set that owner. We have to set the model. And then we have to simply add the address. And the address is going to be this address, which is a contract address. Our address is the contract address. And this is how you can initialize. If you want to know that what is the address of the contract which you are about to deploy, you can do in this way. You can simply add the address and you can provide this. This means the contract address itself. So this is our constructor. Now let's come down. Here we're going to create another contract we'll call car factory. And in that we have to define an array. We'll say public car. Inside that we're going to define a function create. In that we're going to pass the address, owner, string, and model is going to be a public. Inside that we're going to take the car. So right now we have an array. We're going to we have a contract. We're going to utilize this. We're going to call this car.owner, and in that we're going to pass this model. So owner and the model, the data we are getting from the user. So that's what we are passing here. We'll create a car.push, and we're going to push the entire data into the array we have created. Let's come here. Let's create a function. We'll call it car and send ether. Function create and send ether. It will take the address of the owner. It will take the string, memory, model, and public payable because we want to send the fund. So we have to use the keyword public, otherwise it will throw an error. Let's come here. We're going to create a car array, and this time we are creating another contract using one contract. So that's why we have to use this new keyword, and this is the keyword is introduced in Solidity 0.8 version. So if you want to generate a new contract from one contract, you have to use this new keyword, and that we are assigning that car and we are sending the value because this is going to be our constructor, and this is the exact value we have assigned in our constructor. So we have to pass the data. We have to pass the owner and the model. So this is the data we are passing in the constructor. Now we have to simply push the data into our array. And that looks fine. Let's create another function. We'll call it create2. So this is a one more method which allow you to create a contract. So let's check this one. And that we're going to simply pass the address of the owner. We have to pass the string, model, and we're going to say byte data 32 slot. And that we're going to make it public, and that we're going to simply say car dot, and we're going to use the same thing. New car, we have to provide the slots and owner and the model. So you have noticed one thing, that earlier we have used the value and that we are using the slot. Both exactly work in the same way. In that we're going to call this car.push, and we're going to simply push the data into our array. Let's create another function. We're going to call this create2 and send ether. Inside that we have to pass the function address. We have to pass the string, model. We have to pass the byte 32 slot, and we're going to make it public payable so it can transfer the ethers. Let's do the car, and we're going to follow the general configuration. We have to send the value, and we have to send the slot, owner, and model. Then we have to simply push the data. Let's create another function we'll call get car, and we need to provide the index of the data we want to receive from that array, because we have taken a car array and that we have all the data which we have created using this different method. So we want to find the data for a particular car. So we're going to take this push public value view return, and we want to return the data. So we want to return the address of the owner, and we want to return we have to return the address car, and we want to return the balance, and we simply going to take the car. We'll take the entire array, and in that we're going to pass the index, because every car will have a index, and the data will get back to this. And here we're going to simply return the owner. We're going to call this car.owner, car.model, and car.address, and all these data. So in this way we can easily able to access all the data, because our car object will have the access of each of this data, because of we have used the public keyword. Remember, our state variable is a public keyword, so that's why we can easily able to call it. and this will give us the data, and that looks pretty good. That's the entire code for this testing, that how you can generate one contract from another contract. This is a car factory, this is the car contract, this is the car factory contract, and we have bunch of functions. These are the two contracts we have written for creating one contract from another contract. So this is the first contract, which is a car contract. We have the state variable and we made it public, so that's why we can see here we can call that functions, so we can easily get the data. This is the first contract and this is the second contract. So let's try to deploy this and let's try to have a look. So what I'm going to do is, here we have this two car, and in that we have to define the constructor. So you can see these are the data we are passing in the constructor. So I want to set address. So I'm going to be the owner of the contract and I want to pass this string. So I'll say, hey, and I will say the transaction went successful. The transaction went successful. If you simply come here, and if you see the things, you can click on the owner. So this is the owner. If you call the model, this is the hey model. And if you call this address, so this is the address of the contract. So this is our address. So if I copy and if I paste here, you will see the exact address. So this is the exact address which is got updated to our contract. So if whenever you want to know the contract address, this is how you can utilize it. So this is the first contract we have. Now what I can do, I can simply deploy the contract factory, and in that we don't need to pass anything. So simply click on this deploy, and here we have the deployed contract. If you open that one, in that you will have all these functions. So we have this create to, and send. This is the car. So right now if I pass the 0 index, I won't get anything. I don't get anything. You can see the transaction is reverted because we don't have anything into that. If I pass the again here get, it will not do anything because we don't have anything into that. Now let's click on the create method, and if I come here we need to pass the two data, address and the string. So this is the method we are using. We have to pass the owner and we have to pass the model name. So for the address purpose, I'm going to use the my address. So I will copy that one and I'm going to paste it, and I'm going to say buddy buddy. I can hit on the transaction and the transaction went successful, and if I call this one, I'll get that data. You can see this is the address which I have assigned, used to create the account. So we have that in our, if I click on this, you will get this exact data. You can get the entire data, and that's what we are returning. That's what we are returning because we have access of this state variables, and that's how we can simply call that. So we are getting the entire data, and that's the pretty simple things you have to know. You have to declare the state variable, you can call it here, and you can easily able to get the access of the data. Right now you can see here we have defined the data called byte 32. I don't want to convert, otherwise it will take me a lot of time to convert the data into 32 to byte and simply call this one. The only thing you have to keep in mind that there is a way to create another contract using this new keyword, and you will find this a lot in most of the contract when one contract is dependent on the other contract creation. So this is the things take into an account. This method is an old method, create to, which you will not find in most of the contract. To creating a new contract, this method is a very new one. Right now it sounds very complicated. You can see a lot of things are going on, but these are not that important. The only thing you have to focus in this new keyword, that you can utilize it to access the contract which you want to create by the definite value, and that's the only thing you have to keep in mind. So with that, I'm ending this video. Hope this makes sense to all of you. If you still have any confusion, any doubt, do watch the video one more time, and if you still have any confusion, do leave in the comment section. I'll try to help you in that. With that said, let's move to the next video. In Solidity, we have try and catch block to catch an error into our smart contract. So let's try to understand how we can create try and catch in Solidity smart contract. Now we're going to use the external contract to use try and catch block. We'll come here, we'll create a contract called foo. Inside that, we're going to take an address and we're going to create a constructor. In that, we're going to pass the owner address, and here we're going to simply do the check. So we'll say require owner is not equal to the 0 address, means the owner is not should be the contract. It should be the normal wallet added, but it should not be the contract. And here we're going to display the address in message invalid address. That's the first check. Here we're going to pass this assert to compare, and that will say owner is not equal to this, means 0 address. This is not the address we want. This is the second check. Now let's do update the address. So whatever the address we are getting, we need to update it to the owner. That's the simple constructor we have written. Let's come here. We'll create a function called my function. In that, we're going to pass a variable called x. It's a UNT type. We'll make it public, pure return, and it's going to return the string. Inside that, we're going to create a required statement, and we have to check that x not equal to 0. We want they should provide any number. It should not be equal to 0. Otherwise, we have to throw this error message. Here we're going to do the return. So we want to return that my function was called. That's the only function it does. What it does, it will take a number. If it's 0, then it will throw the error message. But if it's a valid number, then it will return this string. Let's close that one. Let's come here. Now we're going to create another contract. In that, we're going to test the try and catch block. So this is the simple contract we have written. We have this function. We have the constructor. Now let's create a contract. We'll call bar. Inside that, we're going to take an event. In that, we're going to pass this message. We're going to take another event. In that, we're going to pass this byte data. Now we're going to take the contract foo and we'll say foo. So in this way, we can easily able to have the contract which we have defined above. And here we can come. Here we can create a constructor, empty constructor, and in that we're going to pass this. This foo contract is used for example of try and catch with the external call. Inside that, we're going to call the foo, and this is how we can use it. So we'll say new foo. And we have to pass the message.sender because that's what it needs. It's need the address, the person who is calling that. And we're going to make him an owner. So that's the constructor. We are updating our foo owner. We can come here. We'll take this example of try and catch with external calls. In that, we're going to try and catch external is equal to 0. And this is the check we're going to do. If it's going to be 0, then we have to simply fail that. And that's what we're going to log it. Here we're going to define try and catch. But if it's provide the valid number, the function we have in the foo, if they provide the valid number, then we want to simply log this text message. We can call the function. We can say try catch external call. In that, we're going to pass the UNT public. Inside that, we're going to take this try foo. This is how we can define. To use the word try, it's similar to JavaScript. We have in try and catch, the same thing we have to do here. Try, then we have to call the contract. In that, we have the function called myFoo. In that, we have to pass the ID. And in that, we're going to return this string result. And here I have defined the variable name. So later I don't need to name it. I can simply pass it. So this is the variable name I have taken, string. And I'm going to initialize the log, the event. And here we're going to attach the catch block. If anything goes wrong, we have to simply get the error message. So internal call failed. Now we have to do a couple of check. First thing, we have to check that the contract creation should be not having this 0 addresses. If we have that one, then we have to display all these error messages. Now let's create the function, and that will say try catch new contract, and that we have to pass the address, and this address should be the valid one. It will say public, and in that we're going to take this try new. That's how we refer our contract, and that we have to pass the owner. That is we are getting, and we have to simply return foo the contract. And here we're going to emit the log. So foo created, and we have to simply catch the error. So this is how we can do it. We can define the error keyword we have in Solidity, and we can define the string, the error message we want to log. And simply come here. We have to simply the error, and this error can be thrown by using this two method. We have revert and required. So let's come here. We're going to say this event, and then we're going to pass the reason, and simply come here. We have to pass the byte data memory and catch failing assert, and that we have to simply event this log error message, and that's looks pretty fine. So this is pretty huge contract. Hope this makes sense. Pretty simple. All we are doing, we are checking for the addresses and doing some transaction into other contract by following general conventions. This is the entire contract we have written. So this is the entire foo contract and bar contract we have written to test this try and catch. Deploy the contract. Here we have the two contract. We have to deploy the foo contract, and that we have to pass the address of the owner. So I'm going to be the owners of the contract. So simply pass the in the constructor and click on deploy, and the transaction went successful. If you see the logs, this is the owner, which is me, and the transaction went successful. If you open that, you can able to find the owner, and here you can call this function. This is the function we have created. So in that, if I provide this 0, you can see this is the error message I will get. So the transaction got reverted, and if you open this log, you can able to find the failed transaction decoded. this is 0, and because of this it's got failed. But if I provide the right number, if I provide 1, the transaction will went success. If I click on the function, here you can see the data got updated, and this is what we are returning here. So this one is looking fine. Now let's come here, let's create a go on the bar contract, and in that we have to simply deploy the contract. The contract got deployed, and let's have a look what we get. Tree function, this is the foo try catch by example. So let's come here, and this is the first contract we have. In that we have to pass the unt. When we pass the unt, we're going to call this foo function, foo.my. So if we come in the foo contract, and this is the function we are calling, in that we are passing this I, and we are having this return. So what will happen here, so we're going to return the result, and we're going to initialize that into our event. But if it's right, then we're going to initialize this result, otherwise it will throw the error. So let's do one thing. If we provide 1, the transaction which went successful, because here we are checking for 1. If it's 1, then it will display the right message. Let's type for this, and the transaction went successful. You can see here, you can come, and here you can see the log. We have my function called, and this is the message we have here. But if I still provide 0 here, the transaction will fail. 0, and this is the message we'll get back here, external call failed, and this is what we have explained here. This is our failed message we'll got, and this is how we catch from this catch block. So that makes sense. Now let's understand this function. So here we have this try and catch, and here we are going saying that try catch new contract. So when in this contract, if we pass this address, this is the invalid message we will display, invalid address, because we don't want to have a 0 address. We don't want to have the 0 address. So in that, what I'm going to do is, if I simply grab this entire address, and if I call this function, if I call the honor, you can see the error I will get. So the transaction went successful, and if I open this one, this is the error message I got, invalid address, and that's what we are logging here. If we pass this one, if I copy this, I'll get the byte log, and I can simply pass it here, and I can simply get it. If I click on this, I will get this error message, the transaction went successful, and we are catch this reason that why it's got failed. And here you can able to see is say that this is the address, this is the data, and it's not valid, the byte log. Now if I want to catch the data which is in byte format, and if I simply copy that one, and I'm going to pass this one, I'll get the third reason, the third error message, which is that foo created. This is the foo created. If I pass this one, if I paste here, I can click on this, the transaction went success, and here we can easily able to have the message. So on the base of these condition, you can catch different error. You can see we have 3 blocks. First this, and this. So this makes sense, hope, I believe. And that's the only thing you have to know. If you click on this, this is the address of the foo you will get. And that's the only thing you have to keep in mind. That's the only thing you have to keep in mind. So hope this makes sense, how to use a try and catch block. Here you can see here we have tested for 3 different conditions. You can add in any logic, and that's how you can define. So here we have defined on the base of the contract, and we are validating the contract address, but you can build any statement like transfer fund or any data or any logic. So hope this makes sense. If you still have any confusion and doubt, rewatch the video and do leave in the comment section that what do you have the problem. I'll try to explain that. What is library in Solidity? Most of you guys have found different libraries in different smart contract. If you talk about OpenZeppelin, if you talk about Uniswap, they have libraries in their contract and they're using in their smart contract. Then how we going to create and how we can initialize the library, and that's what we're going to learn in this video. That how you can create library and how you can use that library in the contract. Let's provide the general configuration. We have to provide the Pragma Solidity version, and now we're going to create a library. So to create a library, you have to use the keyword library, and you can call whatever you want to the name. So I'll call it math because that's what I'm going to do. I'm going to perform certain calculation in the library. So let's create a block. In that, we're going to create a function. We'll call it square. UNT, it will take a Y, it will run internal, pure, return, it's going to return the Z. And that's a very common practice in the library when it's come to Solidity smart contract. You want to perform certain mathematical calculation to prevent any kind of hack. Take this if statement, and in this we'll say that if Y is greater than 3, then we want to do this. In that we're going to say Z is equal to Y. Simple. And we're going to take this X variable and we're going to assign And we'll take a uint variable x, and we're going to assign the variable to that. We're going to say y divided by that plus 1. We'll run a while loop. We'll say x is smaller than z. In that scenario, we can simply take the z and make it equal to x. Here we're going to define the x, and we're going to assign y divided by x plus x1 by 2. That's the simple library function we have here. Now we're going to write the else block, and that we're going to check for a condition y is not equal to 0. And in that, we're going to update the z value of z, and we're going to perform the certain calculations. So else z, by default, the value of z is going to be 0 because it's a uint type. And this is the simple library we had created. What we are doing, we are assigning a couple of variables, checking for a condition, running a while loop, and making variables so we can utilize it into the contract. So let's come here, let's create a contract. And we're going to use this library in this contract, test math. We'll come here, we're going to take this function, we'll say test square root. In that, we're going to pass the uint x public pure return, and it's going to return the uint. Inside that, we're going to return this math.square, because this is math is the library which we are using, and we are calling this square function. And in that, we have to pass the data, which is the x, and this will return the calculation, entire calculation which is happening. That's a very simple function. Let me give this comment: array function to delete element at index and reorganize the array. And we have already talked about the deleting array in Solidity, that when you delete any element into an array, it will leave a blank space. It will make the value of that particular element which you want to delete to 0, and there is no changes in the length, but we want to make the change in the length once we delete any element. And that's what I have mentioned here. This is the problem we have in Solidity when it's come to array deleting an element. So now we're going to create a library. That library will delete the element, and it will also change the length. So if there is a 10 element, if we delete one, the length would be, let's create a library for that. So we'll say library array, and that we're going to create a function. We'll say remove uint, because we have to reset the array, storage area, uint index, and public. Can you guess why we have used this storage keyword? Because we are directly manipulating our state variable, and we have to pipe the index. In that, we'll say now we're going to remove the last element. Whichever element we want to delete, we want to shift that element to the last, and we're going to delete it from there. If you still have any confusion about shifting the array, make sure to watch the array section. In that, we have talked about in detail that how you can shift the array and delete it, and you can change the length as well. Here we have it. Now let's come here. We'll say required.length should be greater than 0. If it's not, then we have to throw this error message, can't remove from an empty array. And that we're going to take the array, we're going to pass the index, so we can easily able to identify that which array we want to remove. And here we're going to call this array.length, and we're going to shift that to the end. So we have to subtract that. As you all know, that array start from the 0 index, so that's what we are getting, -1, so we can get the last one. So that's what we are doing here. We are shifting, and then we're going to simply call this pop method to delete the last element. Simple JavaScript. And that's our library. So this is the library we have designed. Now we're going to use it in the contract to delete. So let's create a contract. We're going to set a test array, and that we're going to take this using array, because we have to initialize the library by using this using keyword, which is there in the Solidity. And we're going to say the for uint. So we have to define the type, that what type it is. It's a uint. Let's take the uint public array. This is going to be our array. We're going to create a function. We'll say test array remove public. Inside that, we're going to create this for loop. We'll say uint I is 0, then I is greater than 3. Then we have to simply increment that. So we got our loop. Inside that, we're going to simply call this method array dot. In that, we have to simply pass the I, the element inside the array. We can come here. We can simply say array dot remove 1, the method, and we have to simply check for the length, that we have the 2 length or not. Then we have to simply check the data, that what data we have in what location. So check the 1 is 2, and that's it. That's the entire smart contract, that how you can build a library and how you can test it and how you can utilize it. So hope this makes sense to all of you. Now we're going to test this out in the Remix ID. This is the entire smart contract we have written to understand the library concept in Solidity. So this is the first library we have declared. This is the test math contract, and this is the second library in which we are checking for the array length, and this is the last contract, test array, and that we are utilizing the library. So let's deploy the contract. Let's come here. We're going to deploy the first contract, deploy the math contract, do the transaction. It's went, And let's call this first one test math contract, and then we're going to deploy that one. Here we have the contract. Let's come here. If you call this math library, you can see we have nothing here because it's just a library, but we have something in here. Let's close this one. We have something in here. We can simply come here, and here we need to pass a data. So what it takes is take a unt, which is an x, and it will perform all this calculation because we are using this square library. So if we come here, if we pass less 5, if I make a request, the entire calculation will happen and I will get this 2 back. So first it will take this y, then it will check that y is bigger than 3, is not, because we have provided this 2, provide this 5, yes, it's bigger than y. So if we have provided this 5, yes, it's bigger than 3, then it will execute this, update the value of the z, and thus it will do the calculation, run the while loop, and do the performance of this. And finally, it's going to return that. The default value is going to be 0 of UNT type. And that's what I have mentioned. So it's working fine. You can see we got an output. No matter what you passed, if you pass this 52, if you make a call, and you can see this is the 7 you will get. So this is the square root of that. Square root functions, and that's looking fine to me. Now let's test this out contract. So let's come here. We're gonna come to this. We have to simply, so this is the library we have declared. Let's deploy that one. So we got deployed. Now let's come here. We have to test the array one, and if I come here, right now we don't have anything, so let's test and call this contract. The transaction went successful, and here we have the contract, and that we have these 2 functions. So if we call this test array, so if you come here, you can see this is the array we have declared. Right now we don't have anything into that. If I call that one, I'll get an empty, which is not there, nothing. Now here I have this test array and remove array. So right now you can see that we are updating our array. We have 3 elements into that. So when we call this function, it will run this for loop, and it's going to update our array, this one. So let's call this function, and here you can see the transaction went successful. And if you call this one, you will get the length. So we have 0, so because initial value is 0. If you pass this 1, you will get this, the value is 2. So this for loop is working fine, and the transaction went successful because we run the for loop. We add 3 elements into our array. After that we remove the first element, which is a 2. So right now you can see, right now we have, if I pass this 0, call this, I'll get a 0. But if I pass this 1, we are getting this 2. But by default we need to get 1, because here we are calling this remove function. So it's removing the first. When this loop will run, it will start from 0, then it will become 1, then it will become 2. If I call this 2, what I will get? I'll get nothing, because we have only 2 elements. And this remove function is working fine, and we have also confirming here that the length is 2 after deleting. So this library which we have used, we have created this array library, is working fine. It's giving us the actual length of an array after deleting. Hope this makes sense that how the library work. These are the simple library we have created to understand the entire concept of library and removing. So if you still have any confusion, any doubt, make sure to watch this code again, retype, change with the value, and try to understand that what exactly happening and what we are exactly doing. With that said, let's move to the next video. Already we have ABI encoded. Most of the time you will find in different contract that they use ABI encoded to generate data and get data, or get any type of contract. And that's what we're going to learn in this video. Everything about ABI encoded. Let's follow the general configuration. We have to provide the Solidity Pragma version, and that we're going to create an interface. This will say ERC20, IERC20. Inside that, we're going to define a function. We'll say transfer address UNT external, and that's how we define interfaces. I believe you guys haven't forgot in the previous lectures. Now let's declare a contract, and that we're going to take a contract token, and in that we're going to create a function. We'll say transfer. It will take the address and the amount we want to transfer. That's the simple things we have done here. We have created an interface, and we have created a contract token, and now we're going to use the method ABI encoded method to access each one of these interface and the contract. So let's come down, let's create a contract. We'll say ABI encoded. In that we're going to create a function. We'll say test address contract. So in this we have to pass the contract address. We'll call it byte call data external. Inside that we're going to check bool okay. If that's true, then we're going to call the contract and we're going to call the method to transfer the fund. So we'll say data. That's the simple check we are doing here. So what this function is doing, it's first will take the address of the contract, it will take the byte data, and it will simply do the transaction by calling this call method. So that looks fine here. Now let's do the check that whether the transaction went success or not. That's the first function we have. Let's come down. Let's create another function. We'll say encoded with signature. And this is the function you have found in very small number of contract, but they utilize it. Some programmers, some smart contract developer, they use these functions to identify the contract based on this ABI encoders. In that we're going to pass this. So address to and the UNT amount. We have that one. Now we have to make it external, and here we have to say pure return, and we want to return the byte data once the transaction went success. And here we're going to call this typo is not checked. We're going to assign this transfer address and UNT. So when you use this function encoded with signature, this is the way you have to access the functions. We'll say return ABI encoded, and in that we have to simply call the functions. So this time we are targeting the contract. So we have the function, this transfer function in the contract, and that's what we're going to call it here. So transfer the address and the UNT amount 250. And here we're going to provide the to and amount where we want to send and the amount. So that looks fine to me. That's the first function. Let's create another function. We'll say encoded with selector. So there are a couple of methods we have. First we have discussed about the ABI encoded with signature. In that we are calling the contract address, pass a targeting contract, and with that contract we are getting the access of the functions with the help of this ABI encoded signature. In this selector we're going to pass the address to and the amount, then we'll make it external, pure, and this will become return, and it will return the byte memory. And here we can come and we can simply do this check. So typo check is not ERC20 interface selectors and true amount. So this time we're going to target the interface. So this is the interface we have declared ERC20, and with this selector method which we have, with this we can easily able to target that interface and we can access the function to do the transaction. So that's the difference between the signature. Signature is basically a contract address, and the selector is the ad interface itself. We can come here, return ABI encoded with selector. In that we have to take the interface, we have to call the method we have already in that, and we're going to call the selectors. In that we have to pass the amount and the to address, and that's the simple function we have here. Let's come down, let's create another function. We'll call it encoded call. It will take the data, amount to, UNT, amount, external, pure, return, and it's going to return the byte memory. We'll pass this. This will not compile. Now let's do the return ABI encoded. We have to take this ERC20. We'll have to pass the function. We have to pass the to and the amount, and that's pretty much. So these are the three methods we have when it's come to encoded ABI encoded data. You can see all the function we have written, all the three selectors we have. So what we have learned about the encoded with signature, in that we pass the address of the contract. Now we have the encoded with selector, in that we pass the interface, and we have encoded call. This is the entire contract we have written for our ABI encoded. This is the first interface, this is the first contract, and this is the second contract ABI encoded. And in that we have this three functions. We have first, we have the normal test function. The second one we have with encoded with signature. The second one we have, third one we have it's with selector, and the last one we have call. So let's deploy the contract and let's test this out. Let's come here, click on this, and first we're going to deploy the token contract. Simply call deploy, and the transaction went successful. You can see that we have this. So simply close this for a while. Now come here, we have to deploy this interface. Simply click on this deploy. Okay, so we don't need to deploy that. That looks fine. Now we have to deploy this ABI encoded. Come here and do the transaction. The transaction went successful, and this is the two token we have. So let's come here in the first one. Inside that we need to pass two data. We have to pass the address and we have to pass the amount. So let's come here. This is the two things we have to pass. So I'll come here. I'm going to simply copy this one. I'm going to paste this address here, and I'm going to pass this data 5. I'll make the transaction, and the transaction went successful, and you can check the logs. So that's the successful deployment of this one. Now we have this ABI encoded, and in that we need couple of data. Here we have the for function. So let's test this function first. Encoded with signature. In that we have to pass this to data. We have to pass the address and we have to pass the amount. So the address I want to pass is this, the first contract. In that I'm going to simply call it, open this one, and that I will pass the address, and I'm going to pass the amount. So amount is going to be the 5. Hit enter, hit call, and that's looks pretty fine to me. What's happened here? Let's open the log and let's try to understand. This is the two data we have passed, and here you can see this is the output we got, our byte data, and that's what we are returning here. So this byte data contain the information we have provided about the addresses and about the amount. So if you decode this one, you can easily able to get the exact data which you have provided, and that's how exactly this encoded with signature work. So if you have a data, you can easily able to convert it into a byte code, and you can easily able to access that, because sometimes you need to convert the data into a byte code to have a memory efficiency. So that looks fine to me. Here you can see the typo check, and that's what we are simply passing here. This is the function we are calling, and you can see this is the output we have got, the entire byte. And let's close this one, and okay, let's close this one. This is the data we have. Now let's come to this selector one, and in that we need to pass the address and the amount. So this time the address I'm going to provide to this one, and I will simply come here, open this, and pass the address, and the amount I want to provide is, let's say, 3. Make a call. The transaction went successful. We got this byte. If you look at this is the entire data we have in that. If you open the logs, you can able to see that byte, what you have paid exactly. And this time we have used this selector method, and the last one we have is this encoded. So let's close this one, and now let's do this last test. So in that we're going to pass the address. We can pass the address, and we have to assign the amount 8 and make a call, and the transaction went successful. You can see the outputs we got it, and this is the amount we have assigned 8. You have 8 here. Here we have assigned 3. You have 3 here. Here we have the 5. This is the 5, and this is the address we have assigned. Actually this represents the 4 bytes, and this will contain the information about the account which is calling the address, and here is the address which we have provided. So first I have provided this, and the second one I have provided this, and the first one we have provided this, the second one we have provided this data, and the third one we have provided the same account to do the transaction. So hope this makes sense. You can understand that how you can get the data into the bytes and how the data exactly flow. So this 4 represent the address of the wallet which you are using, the data you are providing, and the amount you are sending. So this is how the data is actually get stored on the EVM. So hope this makes sense. Still, if you have any confusion, try to see the code entire, retype the entire code, try to understand the data, what exactly happening, check the different variables, that how it's flowing and why we are doing in such a way. So you will find in most of the contract that this is the method is highly used, not this method, but not this method, but this one is the recommended method in most of the smart contract when it's come to identifying the contract and passing the data and calling the functions. So hope this makes sense. If you still have any confusion, do leave in the comment section and do let me know what is the problem. I'll try to explain that. With that, in the last video, we have learned about the ABI encoded in Solidity. In this video, we're going to learn about the ABI decode. So in ABI encoded, you convert the entire data into bytes, but in this time, we're going to convert the byte data into a readable format. Let's follow the general configuration, and we have to provide the license, identifier, and Solidity version. Now let's come here. Let's create a contract. We'll say ABI Decoded, because that's what we're going to do here. And inside that, we're going to declare the struct, and we'll call my struct. And the data we want to take is the string name. We want to take a unt. It's going to be an array 2. 2 data we'll take into that, and that's the struct we have. Let's create a function. We'll say encoded, and that we have to pass the x, and we have to pass the address. We have to pass the complete array, which is a call data array, and that's going to be a unt type. I believe that these are the similar things we have already done. And let's take a my struct, and we'll call the call data my struct. And now we're going to simply make it external public pure return, and we're going to return this ABI bytes memory. Let's return this ABI encoded, in that we need to pass the entire data. So we have to encode this. So we have to x, address, array, my struct, And let's come down, we create another function we'll call decode, and that we need to pass the entire decoded data, so bytes, call data and data. We'll simply come here, we're going to create external, we'll make it pure, we'll make it return, and we're going to simply take a couple of variables, untx, address. We want to return the unt complete array in the memory, and we have to take the struct, memory struct, and that's the data we want to return. And here we're going to do certain things. So we're going to take and we're going to call this, we're going to use the deconstructor method. I believe that you guys are familiar with JavaScript, so we are deconstructing that x address and the array my struct, and this is coming from here because this ABI, the byte data, will have the entire data, and in that we need to pass the data and the unt address, array, and the struct. Looks fine. Let's come here, close this one, and that's the only thing we have to know. We have written this smart contract. We have this two function, coded and decoded. In Solidity, we have a function called KK256. That's what we're going to learn in this video. But before we start, you have to know a couple of things. When you use this KK256, it will take an input. And the common use case we have of this KK256 is that it will create a dramatic new ID for every single input you provide into the functions. And you can have a common schema model which you have to use to using this functionality of KK256. So I know it sounds abstract, but let's have a look at how we can code into our smart contract. Provide the Solidity versions. Let's create a contract. We're going to say hash function. In that we're going to take a function, we'll say hash. In that we're going to pass a couple of variables. So text, we're going to pass the unt num, and we have to pass the address. So these are the three data we need. We make it public, pure, return, and we want to return the byte 32 data. So we're going to provide these three data, and we're going to get back a byte 32 data. So that's what we have here. Let's return this. We're going to use this function KK256, and it's there in the Solidity. And in that we're going to call this ABI encoded method. Then we'll get the data into a byte 32 because that's what we want to have an output. So we'll call it ABI encoded. So it will give us the ABI encoded pack, and in that we're going to pass the data. So we want to encode the text, number, and the address. We want to encode into a byte 32 as an output. So that's the first function we have here. Now let's come here. So this is the simple things you have to keep in mind when you use any example of hash collations. So this is what exactly happened. So let's see in the code. So we'll create a function. We'll call this collation, and that we're going to pass this string is a text, and we're going to pass that another text. These are the two data we are passing into this collation function, and in that we're going to simply call this public pure, and we'll say return, and we want to return the byte 32. Inside that we're going to call this encoded pack, and in that we're going to pass the data. So we have to pass the two data into this, then we'll get an output like this. This is the output we'll get, AABB, and that's called pack, encoded pack. Let's give this comment. But when you will do something like this, like you'll pass this way, you will get the output as this. So it will always work in this exact length which you are providing, and that's also depend on the output. We'll use this return, and we're going to use this KK256. In that we're going to use this encoded packed, and then we have to provide the data. So text, another text, and that's the data we have, and that's what we're going to get into return. Let's create a contract, and that we're going to say guess the magic word. And in this we're going to take this byte 32 public answer, and we're going to take this data. So this is the byte 32, simple byte 32 which I have found on net. That's what I'm using here. Let's create a magic word which is a Solidity. So this is the word we're going to generate from this. Let's create a function. We'll say guess string number word public view return, and that we have to pass the boolean because we want to return a boolean as a true or false. And in that we have to say return KK256 encoded pack, and we have to simply pass the word answer word, and that's equal to answer. So that's the check we are doing. We have this answer we have taken, and we're going to take the string and we try to convert. So the string we're going to generate is the Solidity. So we're going to compare that this answer and the word we are getting from here, both are same or not. This is the entire smart contract we have written for hash generation using KK. So you can see this is the first contract, in that we have this hash function, in that we are passing these three variables, and we are getting an output as a byte 32. This is the second function. We have a collation, in that we are passing this two secs, we are converting into the gigabyte, and we are getting an output. Here we have another contract. In that we are taking this variable byte32 answer, and this byte32 represent a Solidity text word, and this is the function we're going to provide the text Solidity, and we're going to compare that this byte32 which we generated for Solidity and the one it's getting generated by this function are equal or not. So let's deploy the contract. Come here, this is the only function we have. No, we have two contracts. We have to deploy the first one. Let's call deployed, and here you can see this is the first deployed contract we have. In that we have these two functions. In that we have to pass the name. I will pass hey, I will pass I'll pass DAULAT dollar. I'll click on this call, and the transaction went successful. You can see this is the byte32 data we have got it. If you open the logs, you can see that same data we have as an output. So this is the data we contain all the true information we have provided. So that looks pretty fine. Now let's call this hash one. This is the function we have checked this. Let's check this hash one. So in that we have to pass the data. So we have to pass the string SHOAIB. We have to pass the number. So the number is going to be 6, and the address we want to provide to the address which I'm calling. And now if I call this, I'll get the byte32 which contain all the information. If you open the logs, you can able to see the inputs which you have provided and the output you got into byte32. So that's the pretty simple things about these two functions. Now let's come here, let's deploy this contract. Guess the magic number. So let's deploy the contract. The contract is got deployed. Let me close this one. Here we have the second contract, and that if I call this answer, you can see this is the output we got, and this is what we have defined, the exact output. And let's compare this output and the output we get from this function is same or not. So in that I'm going to pass this keyword Solidity, because that's what we want to compare. If I pass this keyword Solidity and we pass this guess, you can see it's true, because this is the byte32 which is for Solidity, and the code is got generated, it's Solidity. So here we are getting the boolean. If I do some changes here, so if I pass something else, so if I pass DAULAT, if I make a request, I'll get the fail. Let's say false, because the byte32 we are comparing and that the one is getting generated is not equal. So that's how you can use the byte32 and you can compare the data on the base of that. And this is very useful when you will actually send the data on the blockchains in the byte format. It will cost you way less compared to the what amount you have to pay when you will use the exact string variable or a uint variable, something like that. Okay, so hope this makes sense. If you still have any confusion, rewatch the video, try to understand that what function we have created, and do leave in the comment section that what's your query. I'll try to cover that. With that, let's move to the next video. Welcome to blockchain chat application. In this project, you're going to build your first ever blockchain chat application where you can register yourself, where you can register your friend, where you can make friend, and where you can send and receive messages. And all these things will happen behind the scene based on the smart contract. So I believe that you will learn something new in this project, and this project is going to be a huge push in your portfolio. Okay, so if you have this kind of industry ready project, you will have a better understanding of the smart contract and the blockchain behavior. So let's have a quick overview of the application which we are about to build in the next 3 hours, and after that we straight away move to our code editor and start building this phenomenal applications. So hope you guys will enjoy, and if you are new to my channel, hit like and subscribe. That will motivate me a lot to come up with this new project. And if I get thousands like, then definitely I will planning to make a new project video. Here we are back in Visual Code Studio. So what I have done so far for this project, I have created a folder by the name chat app. Okay, I haven't done anything in that. I'm opening that folder in my Visual Code Studio, and in this I'm going to initialize. So first thing I will do, open up my terminal and I'm going to clear it, and I'm going to initialize next app. Okay, so npx create next app in the same directory. This will take a little bit time, so just be patient. And here you can see it's happening. So here we have initialized Next.js in our project. Okay, let's click on this pages and delete this folder. Okay, so we're going to clear all those folders and files which we don't need in this project. Okay, so we can start from clean. So we don't have this, simply come here and we need to remove this. Type RAFCE, React Functional Based Component, and simply change this to chat. Okay, because this is will call chat app. Okay, close this one, and let's come here. We have to delete this as well because we don't need this one, and we have to delete this one as well. Delete this one, slint, and let's come back to the
terminal, open up your terminal, and now we have to initialize hard hat. Okay, npx hard hat. So I have already installed hard hat in my computer, so that's why I can directly initialize. If you haven't installed, so you can watch my complete course on hard hat, in which I have explained you how to do the testing. Okay, in that I have explained everything. Okay, so make sure to follow that if you haven't installed hard hat. Okay, so in this I'm going to create JavaScript project. Okay, so you have three options, but I will go with the JavaScript one. So hit enter, and it will recommend you some plugins of packages. You have to install that one. So let's simply paste and install. It's happening. This process generally take a little bit time. I'm using the power of editing, so you can see it's happening very quick. And here we have successfully initialized all the packages. Here we are in packages and file, and here you can find we have this hard hat, slanes, and we need to remove this one because I want to keep things clean. So let's remove this. Simply copy that, and we have to uninstall this. npm uninstall inslint, and we have to uninstall this part as well. So copy and simply clear the terminal, and we have to uninstall this as well. Okay, this looks pretty cool. Just wait, and here we have successfully uninstalled the unnecessary package. Okay, so we can start something from clean. Okay, so that looks pretty good. Now close this one and come back to the script and just make this script clean as well. So we don't need this one as well. Simply remove this one, and we do not need to pass, and we don't need to pass any argument in the deployed, and remove this comment as well. So our deploy script looking very clean. Now let's come back to this is the hard hat config file. We don't need to do anything here because we do going to do things here, because when we connect with the Avalanche and we're going to deploy the contract to the Avalanche test network, on that time we're going to do the configuration, but that's the topic of the next later part. Okay, close this one, and now let's come back to the contract and simply delete this old file. Okay, simply delete this file, and now we're going to create a new file, and we'll call it, let's say, chat app sol. Okay, in that we're going to write the entire smart contract for our chat come social media application. Okay, and now we can start writing the smart contract. Okay, so we need to follow the general convention. We have to provide the license identifier, which is going to be, let's say, MIT. We have to provide the Solidity version, which is 0.7 points, and it's less than 9. Okay, we'll define the contract name, so we'll call it chat app, and in that we're going to define the variables. Okay, so first thing we have to define the use struct. Okay, so first thing is going to be the user. Every user will have a unique property. It will have the name, and it will have the list of the friends. Okay, so let's define the string name, and it will have an array. It will call friends. So all the friends of this particular user will be stored inside this friend array. Okay, let's come down, let's create another struct, and this will call friends. Okay, and in this we'll take the address, and we'll take the string name. Okay, so this is for the friend. Now we'll take another one. We'll call it, let's say, message, because obviously we're going to send message and receive message. Okay, so we need to have a struct to store the data. So we'll have an address, sender, and we'll take the, let's say, UNT256, and we'll take the timestamp because we have to display the time of the message as well, and we have to take the message itself. Okay, so this is the three struct we have. Okay, so simply close this one, so it will take less space. Let's come down, and here we're going to take a mapping, and here we have to take a mapping. We'll take an address, and we'll say, let's say, user. It will say list, user list. Okay, so all the users will be registered in our application. That's all we're going to store inside this. Okay, and we'll take the address of them, and we can identify all the properties, and we'll take another mapping, and this will call, let's say, bytes, and this will be message. And this mapping will provide us all the communication which happening between two users, two friends. Okay, in this we're going to store all the information, so all messages. Okay, just remember one thing, that this array will contain the messages between two users. Okay, we have mapping. Now let's come down, let me give this comment, and now we can start writing the functionality. Okay, so first function we have to write that we have to check, okay, that the user exists or not in our application. Okay, check user exist. Okay, and how we're going to do that? We're going to use the address. We're going to take the address. Okay, we're going to identify by the address, public view, and we have to return a boolean. Okay, If we get true, that means the user already exists in our database, sorry, in our smart contract, in our chat application. If we get false, that means the user doesn't exist. Okay, user list, in that we have all the users. Okay, this mapping contain all the users who got registered into our chat app. Okay, and we get this specific user by providing this address and name. Okay, if we have the name of that person, that means it's already there. Okay, less than 0. So that's what we're going to return. Now let's create a create account function. Okay, and now we have to create a function which allow us to register user. Okay, so let's create a function for that. We'll call function and let's call create account, and we want to create an account on the base of, let's remove this one. We'll take this string call data, and the reason why we have used call data because we want to save gas fee. Okay, and we'll call it name, and we'll make it external so anybody can call it. And here we're going to check for a couple of conditions. So those who want to create an account, we have to check that whether they are the user or not. Okay, so if they are the user, then only we are allowed them to create an account. So first they have to be user, then they can create their account. And we can check, we have this function, in that we're going to pass the address of the function address of the person who is calling this function, and that's what we have. And here we're going to simply check for that. Okay, and we're going to return this message, user already exists. Okay, so if a person is trying to create an account who already created the account, so it will throw this error. Okay, now let's do the second check, and this time we're going to check this one, byte name length 0 greater than 0, and then we have to simply display this message, username cannot be empty. Okay, so they have to provide the name, Now let's come down, we'll take this user list, and now we have to update the data. Okay, we'll take this name to name. Okay, that's our create account function. What this function is doing, it's creating a name for the user. Okay, that's what we have. It's looking fine. Now let's close this one, come down, and now we have to create another function, get username. Okay, and now we have to create a function which allow us to get the username on the base of their address. Okay, so every address will have its name in our chat application. Okay, so let's create the function for that. Function I'll call, let's say, get user name. It will receive the address and we'll make it external so anybody can call it, return, and it's going to return the, let's say, it will return the string memory because we want to return the name of that user. Okay, and here we're going to check for the condition. So first we have to check that whether that person, the address is exist in our smart contract or not. Okay, he is the user or not. Okay, so in that we're going to pass the address, and we'll have to pass the error message, user not register. Okay, so first thing he have to be registered, then he can get the name. Okay, and we have to simply update that in our complete user list. Okay, so that's the get user function we have. Now let's come here, let's write the another function, add. So that's what we're going to do. So we'll create a function, we'll say add friend, and to add a friend we have to take the address of that person. So we'll say friend key, and we're going to take the name of that person. So we'll use this call data name, it's going to be external. And here we're going to check for a couple of conditions. So the first check we have to do is that person is already a user or not, or whether he has created an account or not. So these are the two check we have to do. So let's do it for first. So we'll do this message.sender. If he hasn't created an account, then we have to throw this error message that first he has to create the account. Now the second check we have to do is, let's say, friend, that key, the person who's trying to make friend, add friend, he or she is created account or not. Okay, so we have to do that check as well. The person who's calling this function, we'll say user is not register. Okay, so you can see these are the two check we are doing. Once it gets succeeded, we have to check for the final one, and this time we're going to check for this message.sender is not equal to friend key. Okay, so someone cannot add themselves as a friend. Okay, so we have to do the check as well. So here we can say user cannot add themselves as a friend. Okay, so these are the three check we have. Now let's come here, we have to do the third check, and this check will allow us to check already friend. Okay, so what this function will do, we haven't created this function yet, we're going to create this function. So what this function will do, it will allow us to check that whether we are already in friend or not. Okay,
Okay, so that's what the check we have to do. In that, we're going to pass this message.sender, and we have to pass the person who is calling the function. Okay, friend key, and it will return false. It will say the error message is these user are already friend. Okay, we have to create this function, so simply copy that, and here we're going to do the update. Okay, if it's pass all this check, then we have to simply update and make them friend. Okay, so we have to call this add friend, and that we're going to pass this message.sender and friend key, and we have to do the vice versa as well. Okay, because we have to update the data for both the one who's trying to add the friend and the one who's getting added. Okay, so we'll say message.sender, and we have to pass the, let's say, user list, and that we have this message.sender.name. Okay, so that's what we are doing. Again, we're going to create this add friend function right now, and this function will run internally. That's why you can see I have given this slash notation, and that's the general convention you have to follow in your smart contract in any programming language, which function use internally. It's working fine. Now what we can do, simply copy this, and now we can simply start creating this function. Okay, functions will say check already friend, and that it will take the address, it will take the address of the friend, and it will run internally view, and here we're going to do a couple of check. Okay, so here we're going to return the boolean. So that's what we have here. Now we'll say if user list public key 1 friend list length greater than user list dot public key 2 friend list length. Okay, so this is a very simple check. All the user we have inside this user list, and from there we are trying to identify based on the addresses. Okay, very simple logic, the same kind of logic we have already followed in JavaScript. The same thing we are doing here. Okay, once this condition get fulfilled, all we have to do is we have to simply get this temp public key and the same 1 to 2 and then 2 to atom. Okay, so this is what we are doing. We are simply updating with one another and making connection between them. Okay, so that looks pretty fine to me. Okay, simple logic we have here, and we're going to run this for loop. unt256 I is equal to 0, I is less than user list public key. Okay, 1 friend list, we have the length, then we have I plus plus, so we have the loop. Now here we have to make this comma, and here we're going to run this if statement because we have to do the another check. We'll say public key 1 friend list I dot public key is equal to public 2. Okay, so we are trying to see the connection in our user list, that whether the friend 1 is connected with the friend 2 or not. Okay, I know this sounds complicated, but just follow along with me. Everything will make sense when we'll get the data. Okay, so we're going to simply come here and we're going to return it. So we have to return true because that's what we are checking. Okay, and here we're going to say false. Okay, so that's the simple logic we have built. So far things are looking pretty good. Now let's create this function add friend. It will take 3 data, so it will take the address, address of my friend, and it will take the, let's say, it will take the name, memory name. It will learn internally, and we have to do this friend memory new friend. Okay, this is the variable we have taken. Now we have all the data in here, friends key, and we'll pass the name. Okay, we'll take this user list, pass me, my friend, and we're going to push all the data to this. Okay, very simple logic we have built here. We are simply updating our struct. Okay, so whatever struct we have defined above there, we are simply updating that. Okay, now let's come here, let's write the second function. We'll say get my friends, friend will say get my friends. If it sounds complicated right now, just follow along with me. Okay, I know there is a lot of codes going on, a lot of logics are getting built. Okay, just follow along with me. Everything will make sense when you will see that how things are coming together. Okay, so we here with this function we'll try to find out the friend. Okay, suppose I'm the user and I want to find out all the friends which I have in this application, so this function will allow me to do that. Okay, I want to call it external view, and I want to simply return the friend array. Okay, so remember I have taken the array above. Okay, that's what I want to return. So I have this user list message.sender, and in that I will simply pass this friend list. Okay, so that's the complete data I will get of my friends. Okay, now let's create another function. We'll say get chat code. Okay, so this chat code will run internally because we have to identify the particular user when we do the communication, when we'll send the message. Okay, just follow along with me. So we'll call this get chat code, and it will receive the address. Okay, public key 1, and we'll receive the another address to public key 2, and internal will use pure. We have to return this byte, and it will return this. Okay, we have to check if public 1 is less than public 2, then we have to simply return this gigabyte 256, and in that we have to use this ABI. Okay, ABI pack coded, and in that we have to simply pass the addresses. Okay, address 1 and address 2. Simple logic. We have to do the same thing in the else statement as well, but this time we're going to pass the address 2, then address 1. Okay, 2 and 1, vice versa. Okay, so that's this very simple logic. In this way we can able to get a chat code, sorry, and that's we can use to identify the messages. Okay, now let's come here. Now let's create a message function which allow us to send message. Okay, so we'll send message. This will receive the address of the friend who you want to send the message, and it will receive the message itself. Okay, so we have this message. It will say external. We'll have to check for a condition. Okay, so first check we have to do that the user is already exist or not. Simply copy and paste. We have to pass the address, and we have to display the error message. Okay, create an account first, then you can send. Now we have to do the second check that the person who's trying to make this call, he's also registered or not. Okay, so we'll say user is not registered. Now we have to do the third check, and in that we're going to call this function. Okay, whether they are already friend or not. Okay, so message.sender, and we have to say friend key. Okay, and we have to simply type our message. Okay, you are not friend with the given address or user. Okay, so that's the 3 check we are doing, and now finally we're going to simply call this byte 32. We're going to call this chat code, and now we're going to simply call the function we have created above. This will give us the code. Okay, and in that we have to simply pass the addresses, so message.sender and the friend address who I want to send the message. Okay, once I get the data, I want to simply pass this inside this message. Okay, because message is an array, and I have to pass this so I can easily able to get the all the messages to that particular user. Okay, simple message.sender, and I have to pass this block.timestamp. Simple logic. We are updating our struct, and here we can have all the messages. Okay, this is the array we have. Inside that we're going to pass this chat code, and we're going to push this data into our message, new message. Okay, so that's the send message function. I hope these things are making sense to all of you guys. Pretty simple logics we are building here to get it. Okay, now let's write another function which allow us to read. Okay, so we'll say read message. We'll have a function read message. It will receive the address of the friend, and it will run externally view, and we have to return the or let's say all the message. Okay, so message array and memory. Okay, and we're going to take this byte 32. We have the chat code, and we're going to call the same function, and we're going to simply pass the same data here in message.sender. We have to pass the friend address. Okay, it will return us the code, and we have to simply use this in all message, and we have to pass here so we can easily able to get that particular messages. Okay, you can see we are build this entire logic. Everything's working fine. I think we are getting an error. So let's try to find out that where the error is happening. So here we are in this send message. Okay, here is the problem we have in our get chat code. Okay, so I have provided this extra bracket. Simply remove this one and remove this one as well. Still we are getting a okay, my bad. Let's try to find out what's the problem we have here. And here I forgot to add this, so provide this one more. Now it's look good. You can see no more error we have. So make sure you have to do all these fix to be on my first step. You can see we have written this powerful smart contract which can handle all the communication which happening between the two peoples store the data, display the data, and keep it private. Okay, so things are looking pretty good. Let's have a look. I think I'm forgetting something. Okay, so these are the mappings we have. Let's try to have a look what I am forgetting. This is the create one we have. Close this one. This one is get username. This add friend we have. Check all friend. We have add friend, friend list, chat code, message send, and this is the read message. And we have to add one more function to the smart contract because we have to fetch all the users who got registered into our smart contract, into our chat application. Okay, we haven't have any functionality like that in our smart contract. Okay? So let's create that, and this is the function I was missing. Okay, so let's create a struct which can keep all the users. So we'll say all users struct, and that we have to define the name and we have to define the addresses. Okay, so these are the two data we are taking from the user. You can define as many information as you want. You can take their profile images, you can take their contact details. Okay, you can take their like short description, something like that. Okay, but here we are only focusing on the two data. Okay, name and the address. You can take a lot of data from them. So that's the struct, and now we have to create an array, and we're going to call it get all users. That's pretty simple. We have our array ready, and now we have to simply update this array, and that's what we're going to do inside this create account. Okay, because that's the place where the user is going to be registering themselves. Okay, open up, and here we're going to define that. Okay, so we're going to take this get all user, we're going to push all the data, we'll use this all struct, and we have to simply update name, and we have the address message.sender. Okay, so that's the update we are doing. Simple, not that complicated. And now we have to write a function which allows us to fetch all the users who got registered into our application. Okay, so let's create the function for that. So I'll say function get all app users, and in that we'll say public view return, and we want to simply return the entire struct. Okay, all the users. So we have to simply return get all users. Okay, so this function will give all the user who got registered into our application. So that's pretty much we have to write about the smart contract. Hope you guys have got the entire notion that how everything is working. If still there is any problem, any confusion, don't need to worry. Just follow along with me. Everything will come together when we actually render the data and fetch the data in our live website. Okay, so let's come here. And now we can start here. We can create another folder. So let's create this one called utils folder in the main directory, and this time we're going to call it component, and in that we need to create couple of components. Okay, so we are exactly working on the folder and file structure of our entire application. We are done with the smart contract, and now we are working on the folder and file structure. So let's create the first component is the navbar, and in that we have to create this navbar.jsx, and we have to call it the css file as well, modules.css. Okay, type rfce. That looks pretty good. Now we have to import the css file as well, and that's coming from the same directory, navbar component. Okay, now let's create the couple of more components because we have close to 5 to 6 component in this application. Okay, so let's create that. This one is going to be say filter, and we have to create the jsx file, and we have to create the css file as well. Okay, now let's create another folder which we'll call, let's say, friend. Okay, this is the friend component. We have to create the jsx, and we have to call the module.css file as well. Okay, so we have this 3 component. Let's create more, and this one will come model. Let's create the jss, and we have to create the css file. So I'm going a little faster here because we are just creating the folder and file structure here. Let's create the one more component. This will call user card, and this will have this jsx, and it will have the css file as well. Okay, that looks pretty good. Now let's create one more component. This will become loader. Okay, because when we'll do the transaction, and we are doing with the blockchain, so it will take a little bit time. Okay, so we have to show the loader. So it will have the jsx file as well, and it will have the css file as well. Now the final one is the error component, because we have to handle all the errors which is happening in our web3 application. Okay, so it will have the jsx, and it will have the css file as well. Hope this folder and file structures are making sense. So all those folders we have created, they are the components of our application. Okay, so we have broke down all the entire application into a small components. Okay, and you can see that how we can easily able to reuse this component over and over again. Okay, and by the way, if you haven't watched the NFT market project, I must tell you that you should watch. Okay, I'll link that video in the I button in the description, where we have built this entire NFT marketplace from scratch, and where I've explained that how you can build scalable application and how beautifully you can design. Okay, so let's focus on this. Now let's simply close all these open folder and files. So that looks pretty good. Let's close these folders. And now what we can do, let's come here into the pages, and here we are in the app.js file, and now we had to simply convert it into a arrow function. Okay, I'm going to remove this block, simply remove it, simply cut and paste here, take a div and paste inside that. Okay, that looks pretty good. We have this arrow functions, close this one. Now let's come back to the component. Inside the component we have to create this index.js file, because in that we're going to import all the component, and from that index.js we're going to export into different places. Okay, so we'll call index.js, and let's come here, and here we're going to import the navbar. Okay, the same structure we have following, which we have followed in our NFT marketplace. Okay, so that's what we have, navbar, and we have to simply export. Okay, so navbar, so that's the one we have here. Now let's come here, close this one, come back to the error, and we have to simply type RAFCE and close this one. We have to do the same for the filter as well, type RAFCE. Do we have to do the same for the friends as well? Close this one, do this to loader. Now we have to do this to model, RAFCE. We have to do this to the user card. Okay, RAFCE. So that looks pretty good. All the structure is ready for us to build. Okay, close this one, and now we can import all this. So we have this filter that's coming from the filter folder and the filter component. Let's import the error component. Now we have to import the loader component. We have to import the model component. We have to import the user card component. Okay, that looks pretty good. Now simply export all of these components. So filter, error, loader, model, and we have user card. I think we are missing one more, so let's come here, and we have to import the friend component. And actually this one is going to be a very important one. Okay, so let's export this one. So these are the component we going to use in this application. Okay, so we are just looking fine. Now let's close all these open folders so it will become a little nicer. So now what we can do, let's come here, and we have to create one more folder called context, and in that we're going to create two files. So first one is going to be constant, same structure we are following. Now we have to create the context for our chat app. Okay, chat app context.js. Okay, looks pretty fine. Now let's come here into the utils folder, and we have to call API feature. Okay, so that looks pretty fine. Now close this one, and now we're going to start working on our API feature. So in this API feature we're going to create all the general function which we need in our application. Okay, so before we do that, let's come here in package.json file, and we have to install a couple of packages. You can see we have all these packages. Let's open up your terminal, clear your terminal, and we have to install the ether package as well. Okay, because that will allow us to do the communication with the smart contract and front end. Okay, so let's install that. Okay, it's happening, just wait. And now we have to install one more package, which is a web3 model. Okay, model. So we need these two packages to communicate with our smart contract. Just wait, this will take a little bit time, and it will happen very soon. And it's happening. And here we have installed both the packages in our application, and here you can find them. Okay, these are the latest version we have used. Now here we have in the deploy script, and now we can simply do the changes in the deploy script. Okay, so this is the contract name we have. Simply come up here, copy the contract name, and let's come back to the deploy script, and here we have to change the name to simply chat app, and here we have to say chat app. We have to change this name, select all these one, and we have to replace this one and simply remove this capital to small. Okay, that looks pretty fine, and I don't need to log this out, this information. I simply going to remove this huge console log, and I would say contract address. Okay, so this is our deploy script looking perfect. Now let's come here, and now let's try to deploy the contract. Okay, so let's come here, split your terminal, and now we're going to initialize our local blockchain. Okay, so let's do it. Type npx hard at node, hit enter, and here you will find like close to 20 accounts provided by Hardhead which we can use. Okay, and here we're going to simply write the deploy script. Okay, so this is the deploy script, nothing new to all of you guys. You guys have already seen me a lot of time. Okay, npx Hardhead run script deploy, and network is going to be localhost. So hit enter, and it's compiled successfully, and here we got the address back. Okay, simply copy this address, and now we can utilize it. Okay, so let's come back to the context, go to this constants, and simply paste here the address. And here we're going to simply export the address and the ABI of the contract. Okay, so let's come here. Here we're going to say export const, let's say chat app address, and just pass here. We have to take the one more, we'll say chat app ABI, and the ABI we are getting from here. Okay, so inside this contract we have this ABI, simply drag and drop into this context, and that's what we're going to import it here. Okay, so we'll say chat app JSON, you can call whatever you want, and that's coming from the same directory. And here we're going to call the chat app JSON, and in that we have this ABI. Okay, so hope these things make sense to all of you guys, because this is what we are doing in most of our project. So that's our constant file is ready, everything's looking fine so far. Close all of these. Okay, now we are back in API feature file, and now we're going to create those general function here. So first thing, we have to import the important packages. So we need ethers, and that's coming from here. Now we have to need the web3 model. Okay, web3 model, contract address, and the ABI, and that's coming from the context. So simply copy this address and paste, come back and copy this ABI and paste here, and that's coming from the same directory. Okay, now we have to create the function. So we'll say check if wallet is connected. Okay, so this function will allow us to check constantly that whether the application is connected with the wallet or not. Okay, so here we're going to target the MetaMask. Okay, so we'll say async, we'll say to try and catch, and in that we have to simply console log out the error. If there is no address, we'll say install MetaMask, and here we'll say if window.ethereum is not exist, then we have to simply do one thing, simply grab this message and place it here. Okay, and simply replace this with the current error message. Okay, let's take a variable accounts, and we can get wait window ethereum dot request, and we have to pass the method. So method is going to be, let's say, eth dash accounts. So once we have that all accounts, we have to take the first account. So we'll say first account. This is how, because the accounts will come in the form of array. Okay, so we have to get the first account, and that's what we're going to return from this function, so we can receive wherever we are calling. Okay, so that's our export if wallet connected function. And now we have to write the other function which allow us to connect with the wallet on the base of the click event. Okay, so we'll say connect const connect wallet. Okay, it's gonna be async, we'll have a try and catch, it will have an error message, and the same check we have to do here. Okay, so let's come here and simply grab this all and paste here. And now this time we have to change the method to eth request accounts. Okay, and same thing we have to follow. We have to take the first account. So first account 0, and that's what we're going to return from this function. Okay, first account. So that's our connect wallet function and check wallet function. Both the functions are ready. So these are the two functions we have. Now let's come here, and now we have to write a function which allow us to fetch the smart contract. Okay, so let's say fetch contract. It will have a signer or provider. We're going to use the package new ether dot contract, and in that we're going to pass the, let's say we have to pass the ABI and the contract address, and we have to pass the signer provider, the one who's trying to interact with our application. Okay, so that's what we have. So this is the simple function fetch contract function we have written, and now we're going to write another function. This will call, let's say, connecting with contract. Okay, async function will have this try and catch. We'll say console.logout error, and here we're going to simply use the packages which we have used, like web3 model. Okay, so we'll say web3 model, we have new web3, we'll call it we have the instance of that. Now we'll say connections, await, web3 model. In that we'll call this connect. Now we have the connection, we have this provider, new ether dot provider dot web3 provider. In that we have to pass the connection. Now let's come down, we have to simply take this signer, and we are getting from provider dot get signer. Okay, once we have the signer, and that's what we're going to provide in our fetch contract. Okay, just provide that. And once we have that, now we're going to simply return this contract so we can receive wherever we are calling this function. Okay, so we'll call contract. So this is our connecting with contract function is ready. The reason why I have abstracted these function as a API feature, because these are the function is very general. No matter what kind of application, web3 application you are building, these are the general function you have to create to have a communication with the smart contract. Okay, so that's why I have converted this into a API feature which you can reuse wherever you want. So these are the three functions we have. And now what I want that in our application we are displaying the time that when the user send the text message. Okay, but that time will come in the form of timestamp, so we have to convert that time into a readable time. Okay, so let's create the function. So I'll say export const and say convert time. It will receive the time, and here we're going to simply no try and catch. So we'll take a variable, we'll say new time, and this time we have it here. Okay, so we'll take this new date, and that we're going to pass the timestamp, and we're going to convert this into a number. Okay, because the timestamp we get from the contract, it will come in the form of big number. Okay, so we have to convert into a readable number. Okay, so we'll say to number we have. Let's come down, and we're going to take this const, we'll say real time. Okay, now we have this new time, and that we're going to call this get hour function. So this is a very simple JavaScript. Okay, I hope you guys are familiar with this JavaScript, so that's why I'm just going a little faster here. Okay, plus then we're going to use this new time. We're going to call this get minute functions plus, and bring it down, and let's say this plus, and we have to get the, this time we have to get the seconds. Okay, simple JavaScript. We have to say date, so we have the time, now we have to display the date as well. So we have this plus, we'll say new time, and we have this function called date. Okay, we got date plus, we have to get the we have this new time, and that we're going to call the, let's say get what function, we have month, and we have to get the year as well. Okay, so let's provide this one. Okay, wrap this in a this way, so it will start from 1, and now we have to get the year as well. So slash plus, we have this new time, and that we're going to call this get new time get full year. Okay, once we have the entire readable time, and that's what we're going to return from this. So we'll say return real time. So this function will allow us to give the readable time which we can display in the message. Okay, so simple JavaScript, nothing complicated here. Okay, I believe that you guys have understood all the things whatever we have done here so far. Okay, so we are done with this. Close this one, come here, and now we can start working on our context. Okay, so now let's start writing all the functionality which allow us to communicate with our smart controller, like creating account, fetching account, sending message. Okay, that's all we're going to do inside this context. Okay, and we are using context API in this project to share the data. Okay, so here we are. We'll come down here, we'll type this RAFC, we'll remove this portion, and we have to import couple of things from React. So we need use state, we need use effect, and come down, we have to import the, let's say, use router, that's coming from next router. We have to do couple of internal imports, so we need all the functionality we have created. Okay, so let's come here, close this one, and here we have created all the functions in our API feature. Okay, and that's what we're going to import. Simply copy and import one by one, and that's coming from the API, sorry, utils / API feature. Come copy and paste here, and we need this one as well. That's the 3 function we are getting from the API features. Now here we're going to create the context. Okay, so we'll call it chat app context react dot create context. Okay, this is our context. Now we have to create the provider, chat app provider, and that we have to pass the children. It's gonna be an arrow function. Okay, and here we're going to take this data variable, okay, because I want to show you variable. I'll say, hey, welcome to blockchain chat app. Okay, now we have to return this, and we're going to take this context provider, and that we have to pass the children. Here we're going to pass the value, so all the data we're going to pass inside this. So let's pass this title so I can show you that it's working. So that's the general setup we have done in our context. Come here and we go to the API, okay, and here we're going to utilize the provider. Okay, so let's import that first. So internal import, so we have to call it, let's say, what is the name we have called? So chat app provider. Simply copy this one and simply paste here, and that's coming from our context and context. Okay, so we got this. Simply copy that one and bring it here, and we have to wrap our application with this. Simply cut and paste here. So now we can easily able to access all the data which we shared in that values. Okay, looking fine. Now we have to import the navbar as well, because that's what we're going to highlight here. Okay, and that's coming from our component, and that we have this index. Okay, index file. So where it is, this one. Okay, so here we have the navbar, and that's what we're going to pass it here. Okay, navbar component. So that's the general setup we have done in our app.js files. We are done with that. Now let's come back in the context, and to check this out, let's come back to this index, and here we're going to simply import a couple of things from React to check. Okay, state, use here, and use context. Now we have to do the internal import. So we need to import the, let's say, this is chat app context, and that's coming from our context, app context, and that's what we're going to simply receive the data here. So we are using this chat app context, and here we have taken this title. Okay, simply copy, and that's what we are passing and receiving here. Okay, and that's what we're going to try to display here. So I believe whatever we have done, that makes sense. Okay, so simply open up your terminal and try to start the application. npm run dev header and open in local 3000. So here you can see, just wait, it's loading, and boom, here you can see it's working fine. Hey, welcome to blockchain chat app. So our context API is working fine, and we can easily able to access data in different components. Simply bring this down, and what I want, that's looking fine. I don't want to have this data. Okay, so simply remove this. I just put this to show you guys. Okay, remove this one and remove this from here as well. Type hey, come back to the context and simply remove this one, and that's what we have to do here as well. So that's our context absolutely working fine. And now we're going to take the couple of state variables, and now we have to define couple of state variable in which we're going to store the data which we get from the smart contract. Okay, all the communications. So let's start that. Okay, so I'll define this, let's say, state, and here we're going to take this account. Initially it would be empty. Okay, why I'm getting this error? Okay, my bad. Simply cut this one and paste above this. Cut this one here and bring it here. Okay, so here we're going to define all the state variables for this application. So we have the account. Now let's define the others. So we'll take another one. We'll say use state. We'll define the username. We'll take another one. We'll have the, let's say, friend list array. We'll have another one. This will call, let's say, friend message. It will have an array. We'll have another one. We'll say, let's say, loading false, because we have to wait and display the loading when the transaction is happening. Okay, we have a loading. Now let's take another one. We'll have this, let's say, user lists. It will be an array. We'll have another one. We'll say error, because in this we're going to save the error message. So these are the general state variable we have taken. Okay, now we have to take one more. Let's come here and we'll take the chat user. Okay, so here I'm going to take two state variable which allow me to display that who I'm chatting with in this application currently. Okay, so their name and address I'm going to store. Okay, so current user name, and I will take the address as well. So current user address, it would be a string. Okay, and that's what we have here. So these are the user data. Now we have to take the router, because that's what we're going to use once someone will create an account. So we have to redirect to the home page. Okay, so that's what we're going to use router for. We have the router. Now
That looks pretty good. Okay, so these are all the variables we have defined. So far things are clear to all of you, I believe. Now let's come here. We're going to write the functionality first. So the first function we'll create which allow us to fetch all the data at the time of page reload. Okay, so let's write the function. So we'll take a variable fetch data, and it's going to be an async function because we are dealing with the smart contract behavior. Okay, try and catch. So it will have an error. So here we have already taken the state variable, so we're going to set the error message. So we'll say, okay, so let's type the error message: please install and connect your wallet. Okay, so we already have this error state variable, and that's what we are using from the beginning. And here we're going to first call our contract. So we'll say get contract. So that's what the function we have here. We'll say const contract await, and we have to call the functions. Okay, so this will give us the contract, and now we have to get the account. So we'll say connect connect account, and we have this connect wallet function. Okay, so connect wallet function. So I'm going to call this function at the time of page reload. Okay, so I'm going to call this connect wallet function. Okay, you have two options, whether you can call check if wallet is connected, or you can call this function. Both will work, but I'm going to call this one. Okay, so once we have the connected account, we have to simply set that account to current account. Okay, so we got the account, we are setting up. Now we have to simply get the username. Okay, and we already have a function of smart contract. We'll say username, we have to await, and contract, and what's the name we have given to that function. So let's come here in the smart contract. Okay, this is the function we have. So all we have to do is to pass the address of the user who, and we get the name back. Okay, simply copy the function, come back and call the function, and that we're going to pass this connect account function. So we'll get the name of that user. Once we get the name of the user, we have to set that name. Okay, set username to username, and now we have to simply write the third function, get my friend list. Okay, so the person who's connected with the application, we have to try to fetch his friend list. Okay, his or her friend list, sorry. So we'll say const, we'll say friend list await, and we have a function in our smart contract. So let's come back. So this is the function we have, get my friend list. Simply copy that, and that's what we're going to call it. Okay, and then we have to set that. So these are the general function we are calling every time. Okay, now let's type the another one, get all app user, and we have a function for that as well. So we'll say user listed await, we'll take the contract, and we have the functions. So what is the name of the function? Get all app user. Simply copy, and boom. So all this function we are calling at the time of page reload, because this are the information we have to display when the user will visit to our application. Okay, and we are setting up. Okay, so that looks pretty good. Okay, this is the all function, all the contract interaction we are doing here. Now I want to call this function whenever someone will reload the page. Okay, so let's do that. We'll say fetch data, and we're going to call this empty array. So that's the first feature function. You can see our MetaMask is open, and we can simply do that. So let's simply stop this application from running, because I don't want that every time I save the code and my MetaMask get popped up. Okay, so I don't want to do that. So simply stop this application from running. Let's focus all on the functionality, and later we go to check that. Okay, that's the first function we have. Let's write that on the function. We'll say read message, and it's going to be async function, and that we have to pass the address of the friend to read his messages. Try and catch, we'll send the set error message to, let's say currently you have no message. Okay, we'll have to make the connection with our contract. We'll say await, connecting with contract. Once we have the contract, we have to simply call this read, and we have a function in our smart contract, this read message. Okay, and that we have to pass the friend address. Simply copy that function, come back here, and in that we're going to pass the address of my friend. Okay, so friend address which we receive from this function. Okay, so that's the function we have, and now we have to set the read message. Okay, so hope things are making sense to all of you guys. Simply copy this, and that's what we have to pass here, so we can receive wherever we want in our application. So that's the very first function we have, read message. Let's write the another one. We'll say create account,
Okay, we'll say create account. It will receive couple of things. So async function, it will receive the name and the address of the user. Okay, and it's gonna be an arrow function. We'll have the try and catch. If anything goes wrong, we have to catch that as well, and we have to display the error message as well. So we'll error while creating your account, please reload the browser. Okay, let's come here. We have to take this if statement, so we have to check that the user are providing the data or not. Okay, so name and the account address. If they don't provide any one of these, we have to throw the error message. So we'll say set error to, let's say, name and account must be there. Okay, cannot be empty. And then we have to simply call the function. Okay, so we'll take const, we'll call the contract await. We have to call the contract function, and now we have a contract. So we're going to call this get created user await contract, and we have to call this create account. In that we have to simply pass the data. Okay, so this is the create account, and in that we have to pass the name only. Okay, name, come here, and we have to pass the simply name of the user. Okay, and then we have to simply set this loading, because this will take a little bit time. So as this transaction is happening in the background, we have to show the loader. Okay, so set loading to true, and here we'll say, let's say, await get created user await. Once this get success, we have to simply set it to false, and then we have to simply reload the browser. Okay, that's simple logic we have doing here for the create account. Okay, simply close this, copy and paste here. So these are the two functions, we got it. Now let's write the third one, and this will say add your friend. Okay, const add friend, and to add the friend we need couple of things. So it will have a try and catch, and that we'll set the error message. We'll say something like something went wrong while adding friend, try again. And in that we have to receive couple of things. We need the name and we need the account address, and this time we have to do the check. Okay, so come back here, we have to check if account and name exist. Okay, then only we can call. Okay, set the error message, then we have to call the contract. So we'll say const contract, and we have to call the connecting contract functions. And once we have that, now we have to take another variable. We'll call it add my friend await contract, and we have a friend function. So here we have this add friend, and that we have to pass this friend name, friend address, and the name. Simply copy this and paste here, and in that we have to pass the data. Okay, so let's pass this account address and name. Okay, so make sure order is very important. Okay, so you have to pass the same order in which you have defined in your smart contract. Okay, so now we have to follow the same logic. Set loading to true. We have to wait for that transaction getting completed. So add my friend await, then we have to simply call this false, and then we have to simply send this to the home page. Okay, slash push this, and then we have to reload the browser. Simple logic, nothing complicated. Okay, simply copy, and that's what we have to pass here. So these are the three functions we are done with. Now let's come here, we have to write the send message function to your friend. We'll say const, we'll say send message. It will receive the, let's say, message and the address to whom I want to send. Try and catch console, we have to set the message, error message to, let's say, please reload and try again. And here we have to check for the data, that there is a data or not. So message.send message and the address, then return this error message. Same general convention we are following here. Please type your message, then we have to get the contract. So const contract, and we have this connecting with contract. We have to take another variable, we'll say add message await contract, and we have a function. Okay, the send message function. In that we have to pass these two data. So we have to pass the address of my friend and the message itself. So these are the things. Now we have to say set loading to true, and we have to await it. So await add message wait, and then we have to set loading to false, and then we have to simply reload the browser, location.reload. Okay, so this is our send message function. Simply copy that and simply pass it here. Okay, so these are the 4 functions we have here. So far everything's looking good. Let's come down, and now we have to write down one more function which allow us to read the user info. Okay, so we'll say const, we'll say read user async function, and it will receive the address, okay, of the user. We'll have this try and catch. Let's not have, we'll take this variable const and contract await. We have to make the connection with the smart contract. Then we have to take this variable, we'll say user name wait contract, and we have a function in our smart contract. Let's come here, get user. Okay, so this will give me the name of the user, and this function will going to use to fetch the data like account and name from the person who are we chatting with. Okay, so for that we are creating this function. We'll pass the user address, and we'll simply come here, we'll say set user name to be the username, and we have the address his. Okay, so we are setting up. Simply copy and paste here. So I believe whatever we have done so far, things are clear to all of you guys. These are the pretty simple things. You guys have already seen this kind of logic we have work in our NFT marketplace, so make sure to check that as well. Okay, but work along with me. So that looks pretty good. All the functionality is ready for our application. So this is the fetch, read, create, add, send, and read user info. And now we have to send all these data. Okay, so we can receive in our component. Simply copy this one and come here and simply pass one by one. Okay, account. So let me do it very quickly. Okay, I'll go with this username. Let's come up here. I'll go with this friend list. Sorry, I'll get this with friend message. I'll get this one loading, this user list, and I have to get this loading as well. I have to get the error as well. I have to get this current username and current user address. And that's it. That's the only thing we have to do here in our context. Here we are communicating with our smart contract, fetching all the data, all the logic, everything is working absolutely fine here. Okay, so we are done with the most important part of this complete project. So we have built the smart contract, we have built all the logic to make the connection. Okay, you can see all the function is working absolutely beautifully. Okay, so that's the fetch data function. We have the send data. Okay, now simply close this one, and now we can start working in our component section. Okay, so we have our smart contract ready, we have our context API ready, we have our smart contract ready, we have our context API is also ready, and now we can start working on our front-end UI part. Okay, so we can display and bring all the functionality into life, so you can come and you can chat with your friend. So let's come here, close this one, and let's come back to the component, and we're going to start with the navbar first. Okay, so let's come here, let's zoom a bit, and that's how things are looking right now. You can see, let's come here, and before we do that, I'm going to use pop-in, okay, for the font. So let's come back to the Google Fonts, click here, and here I have already predefined the Google font. Don't need to worry, you guys will get in the starter file. Okay, so this is the font I'm using, and I will click here in the media. I will simply grab this one, copy, and come back. So let's go back to into my global style file here, and I'm going to paste on top. So this is the font family which I'm using. Okay, now let's come here in the body, and here we're going to define the font family. Okay, so let's simply copy this one, font family Roboto, and paste here. Now we have to define the background color, and this is the primary color which I'm using, 2E292F3F. okay, we have to define the color for the text, so I'm going to use completely white. These are the general setup in the style file, and now I'm going to remove all the scroll behavior. Okay, the side scroll bar. Okay, so let's write the webkit for that. Webkit scroll bar display is going to be none. So that's the only thing we have to do in our global CSS file. So things are looking pretty good. Now we can come back and we can start working in our navbar. Okay, so click here and we can start writing the navbar code. Okay, so we're going to import a couple of things from React: use effect, use state, and use context. We have to import the images. Next images, we have to import the link, and here we're going to do the internal import. So first thing, we have to import the style file that's coming from the same directory, Okay, and we have to import our context. Okay, so if we come here, this is chat app context. That's what we're going to receive here. So bring this down, and that's coming from our context chat app context. Okay, now we have to import the, let's say, model and error component, and that's coming from our component slash index. Okay, because these two component we're going to use in our navbar, error and the model. And now we have to import the assets we're going to use in this application, all the images. So here I have created a folder, in that I have all the images which I'm using in this application. So I will simply copy and drag and drop here in my main directory. I'm going to copy it. Okay, so don't need to worry about it. You guys will get all this starter file. In that you will have this folder, image folder as well. So if I open this asset folder, in that you will find that I have close to 20 to 30 images. Okay, so if I open this one is account, user, avatar. So all these images which we have here, which we are using in this application. Okay, so you can find that here as well. Okay, so I have already done this setup for all of you guys. You can see this is the naming convention I have followed, image 9, image 10. Okay, so I'll explain you why I have done in that way. So that's all looking fine. And here I have also created an index.js file. Okay, this is our loader. In that I have imported all the images. Okay, so you can see this is the images, all the images I have imported here, and I have made here default exports. So you can see, and here you can see I'm following a very general naming convention, image 1, image 2, image 3. Okay, because when I'm going to render the information for the user, so every user will have a different image, and we're going to simply manipulate this number to change the images. Okay, so that's the logic I'm followed here. Okay, it will make sense, just follow along with me. So that's the entire images we have here. Now that looks pretty fine here. Close this one, and now we're going to simply import the images here. So we'll say images, and that's coming from / assets. Okay, that's the one we have. Simply come here, delete this part. Okay, so that's the external and internal import we have here. And let's come here, let's remove this part, and here we're going to take this one, div. It will have a class called navbar. Inside that we'll have another div. It will have a class called navbar dash box. Okay, and here we're going to take a couple of data. Okay, so we need a menu. Okay, so we'll take this menu item, because we need our navigation bar where we can have a different menus. Okay, so it's gonna be an array of objects. So it will have a menu name, and it will have a link. Okay, so it will have a link. So I'll say all user, simply replicate this couple of times and simply change the data. So select all this and make this slash. I want to change this to chat. This will become, let's say, contact. This will become setting. This will become FAQs. Replicate one more time, and this will become, let's say, terms of use. Okay, these are the menu we have. Simply close this one, and here we're going to define a couple of use states. So we'll have a, let's say, active account, active. Okay, so we have to display that which menu is active. Okay, so initially I want to open the chat. Okay, so do, and we'll have another one is going to be open false. We'll have another one, we'll say open model, and this will become false as well. So these are the three use state we have here. Looking fine. Now we have to take the context. Okay, use context and chat app context, and in that we're going to import the account, username, and we have to import the connect bullet function. Okay, so these are three data we are importing for our context. Looking fine so far. Let's come here, go back to the context, and what else we need here. Things are looking good. Now we have to simply pass this connect wallet here, and we have to pass this, let's say, what else we can pass. So let's come here, and we have to pass this check if wallet is connected or not. Simply copy and paste here. Things are looking good. So we are exporting all this data from here. Account we have, and username we have. Okay, now let's start working on the JSX part. So let's bring this down. We'll have this another div. It will have a class called box left, and this will become right. Let's say right. In that we're going to take this image. It will have a source image, and the image we want to use the logo. All tags will say logo. Width is going to be 50, height is going to be 50. Okay, pretty cool. And now we'll come to the right side, and here we're going to take a div. It will have a class called navbar box right, and it will call menu. In that, we're going to take this dynamic block, and we have this menu, and we go to map over it, okay, loop over it, and we want to instantly return. So in that, we're going to take another div, okay. It will have a, let's say, it will have a on click function, and the function we want to call is this. So with the function I want to call is set active, okay. So this is the active, and it will become I plus 1, and it will have a key I plus 1, and it will have a class as well. So the class I want to assign is the template literal, okay. So we're going to add a dynamic classes. So once the menu is active, we have to display the color and the bottom on the line, okay. So we have to take a dynamic class here, and that's how we're going to define. So we'll take this one, nav bar right menu items, okay. And we're going to take one more class. We'll say active. If active, I plus 1. If the menu is active, I plus 1, then we want to call this class, okay. We'll say active button active, okay. Otherwise we have to say empty, okay. Active button and then empty. Simple logic we are following here. If the menu is active, then we are adding a special class to that, okay. That's the simple logic we are doing here, and that's what we have here. And let's come here. We have to take this link tag, and in that we have to simply pass the class. So we'll say style dot navbar menu items link. It will have the href path. So let's say element dot link. So that's what we are getting here, and here we're going to pass the name of the menu. So element dot menu name, okay. That's simple logic. Now let's test this out. Let's open up your terminal and type our npm run dev. Come back to the browser and simply reload that, and here you can see we have the logo, we have all the menus, everything's working absolutely fine. Things are looking pretty good. You can see our redirection is also working fine, okay. Our router is also working fine. Now let's bring this down, and now we can start working. Continue, okay. So simply close this one, and this one is going for the desktop, okay. So our menu will have two versions, one for desktop and the other one is for the mobile device, okay. So let me comment this, and I will say mobile. Simply grab this previous one, and here we're going to do a couple of change, okay. So we can say that if the open is true, then only we want to display this. Means that if we are on a mobile device, then we only want to display this menu, okay. And simply paste here, and here we're going to say, okay, simply, and here we have to change, okay. So the changes we have to do into this component. So instead of navbar right, we can simply select this part and we'll say mobile, okay. Mobile, 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 okay. So that's the change you have to do. Make sure to do the same changes, you guys. So that's our menu, how it's look. So our menu is ready for the mobile device as well, and here we're going to take a p tag, and it will have a style because we want to show the close button as well, okay. Mobile button, and in that we're going to take this image. We have our src. Inside the images folder we have this close image, okay. Button is exactly, we have to provide the alt tag. Width is going to be, let's say, 50. Height is going to be 50. Simple. And we'll have on click function. So on the base of the click, I want to simply turn off the menu, okay. Close it out, okay. Set open to false, okay. Simple logic, nothing complicated. So that's the mobile menu we have. Okay, so that's the mobile menu. Let's come down, and we have to take this connect vault function, okay. So we'll have a button in our menu which allow us to connect. So we'll have a button in our navigation bar which allow us to connect with the vault, okay. So let's create that element first. So we'll say div, we'll say style nav bar box right connect. In that we're going to take this account. If account is empty, okay, if account is empty, then we want to render this button. Okay, so button, it will have a on click function on that, and we're going to call this function. Okay, so we'll say connect wallet function if the account is empty. Okay, so we have already have this function here, and that's what we are calling here. Okay, and we'll say space, and we'll say stick a spam, and we'll say connect wallet. Simple. But come here and we'll take another dynamic block, and we'll take this button. It will have a on click function, and this time the function we want to call is, let's say, set open model and true, because you can see this is the model we have, set open model. Just code along with me, everything will make sense. Okay, just code along with me. And that we're going to take this space, and we're going to take this dynamic block, because here we have to do two check. So just write, we'll take the src, we'll take the image, not image, we're actually looking for the account, sorry, username. Okay, means the person who try to connect with the application, if he has already created account, okay, then we want to display the different image. But if he hasn't created account, then we want to display different image. Okay, so we'll say if username exists, then we have to display this image, account name, and if doesn't exist, then we have to display this. Okay, create to, and it will have the alt, it'll have the width 20, height 20. Okay, simple. We'll take this space, now we'll take this span small, sorry, and in that we have to check for the condition. Okay, so if we have the username, then display the username, otherwise display this create account. Simple. Hope things are making sense to all of you guys. So we are done with these buttons. Now simply come down here, we're going to take this div class, and we'll say style dot navbar right open, and in that we're going to simply have this on click function, and on the click of event we want to simply set open to true. Okay, we want to open that, and in that we're going to take this image src, we have to take the images we have inside this open alt, and this is the open, width is going to be 30 and height is going to be 30. So this is our hamburger. Okay, so if we click on this, we can open our menu. Okay, things are looking good, and you can see this is how everything's looking. So we have the menus, we have the create account, because we are already connected with this, but we haven't created the account. So you can see this is what we are getting. We have the our menu button, you can see it looks pretty good. If you can see here, we have the MetaMask, it's already popped up. If you type this message, sorry, credential, and here you can see we are connected with this application. And right now you can see this create account, because we haven't created the account. So that's why you can see the moment we create, things will work fine. Okay, so things are looking fine here. Come here and close this one, and now we can start working on the css file. Okay, so let's start styling this. So let's target this navbar. We'll say let's make this side by side so you guys can see. Width is going to be 80%, margin 3 auto, position is going to be relative, navbar box, display is going to be grid template column 1fr, align item center gap is going to be 2 ram. We'll take this navbar box right, display is going to be flex, align item center, justify content space between. We'll take this navbar box right menu, display is going to be flex, align item center, gap is going to be 2 ram, border bottom 2 pixels solid, and we'll have this transparent, transition all 0.3 second easy in. We'll target the navbar active button. We'll say color is going to be our F18303. Why it's not working? Okay, we have to fix this one. Okay, things are looking fine, not a big deal. Come here and we'll target this border bottom 2 pixels solid. We'll have the second primary color, padding bottom 0.4 ram. Okay, these are not working. We have to fix this. Let's come here. Things are looking good here, no problem we have here. So this is the active button, we have simply copy and paste here. So still we have some issue, it's not working, but everything else is working. Let's zoom out. Okay, now you can see this is how it will look. perfect. Okay, let's continue working. We'll see what's the matter. We'll target the navbar box right connect. Display is going to be flex. Justify self is going to be flex send, and right connect button. We'll target the background color is going to be, let's say, RGB 000 0.25. Okay, padding is going to be 1 RAM, border none, border radius 0.5 RAM, font size 1.1 RAM, color is going to be our second primary color, font width is going to be 700, cursor pointer, and this will display is going to flex, and align item center, and gap is going to be 1.5 RAM. So that's how it will look. Pretty good. Let's come down. Navbar box right close. Display is going to be none because we don't want to display on the desktop. Okay, we'll say navbar box right open. Display is going to be none. Okay, navbar box mobile, and we'll say display is going to be none. Come down, we'll take mobile menu, display is going to be none. Okay, so do one thing. Let's simply remove that. Okay, and take the media query. Okay, only width is going to be, let's say, max width 35 em. We'll target the nav bar. Width is going to be 90%. Margin 2 RAM auto. Nav bar box. We'll target the grid template column 1.6 FR and 2 FR. That's how it will look. Justify content space between. Okay, these styles are not taking place, not a big deal. We'll take this button. Font size 1 RAM, and padding is going to be 0.8 RAM. Navbar box open. Display is going to be block. Okay, let's come here, and the problem we have, so these things are looking good, no problem we have. So this is the one we have, navbar box right open, simply copy, and that's what we are targeting here. Things are looking pretty good. Now let's come here, navbar box right menu, position fixed, z index 11, background color our 292F3, first primary color. Width is going to be 100%, and flex direction is going to be column. Height is going to be 100 VH. Inset is going to be 000, and padding is going to be 4 RAM. Display is going to be none. So that's how it will look. You can see looking perfect, absolutely. Okay, that looks good. That's how it will look on our desktop, and our media query is also working fine on a small device. That's how it will look. Okay, let's do the expect element. Things are looking pretty awesome, and let's come down. We have to target the mobile menu. Display is going to be block, and here we have that. So let's turn it to true. Okay, provide this exclamation mark, and here we have that. Okay, and now let's start styling this. Okay, position is going to be fixed, z index on top of everything, and background color is going to be our primary color, inset 00, and we'll have align item center. Padding top is going to be 4 RAM. We'll target the mobile menu button. Padding top is going to be 2 RAM, and we'll come here. So our still the active state is not working, and this is the problem we have here. Okay, it's I. Okay, I. And here, from here, we have to remove this extra bracket, and because of this we having this issue. Okay, simply save it, and now reload the browser, and boom, you can see our active state is working fine. Looks pretty good, but it looks weird on a mobile device. We have to fix this, not a big deal, we can do that very easily. Okay, things looks pretty good so far. Things are looking good. Now let's provide this. Okay, it's came back again. Okay, remove this, reload the browser, and here you can see it's working fine. Okay, but they're very close to each other. We have to make a little bit space. Okay, so let's make it side by side, and we have to grab this one, and that's what we're going to target. And we'll say margin top is going to be 1, so it will have some space. You can see it's looking perfect, and it's not working. So let's come here, and here we have return back to the false. Remove this one, save it, and if you click open close, or navigation is working fine. Okay, you can look, it looks beautiful. It looks beautiful. So reload the browser, and if I click on this, nothing is happening. Why so? Let's come here, let's try to find out in our console. Okay, here we are getting something. So let's click on this. Okay, here we are getting an error. It says syntax error. So I made some mistakes in my code, and because of that we are getting an error. Simply click on this. So this is the error message we are getting. So there is a problem we have in our API feature. So let's come here. From here we are getting the error. In this function we have the problem. So let's come here, go back to this API feature, and here we have an issue. Okay, so you can see this function is looking pretty good, no problem we have in it, and this looks good. Okay, here we have the problem. Okay, so make sure you have to make the order in right way. Okay, so this is the order we are following: chat app ABI. Okay, so simply grab this. First the address will come. Okay, so that's the one thing will come. Actually I was stuck for half an hour, and I was trying to find out that what's the problem is happening in our code, why it's not working. But what I have found that this is the issue we have. Okay, so you can see this is the contract. Simply grab this code and place after address. Okay, so we have to place after that, copy that one and cut this one and paste here, and now it will work fine. Okay, if you reload the browser, because when we are reloading the browser we are calling one function in our context API, and in that function there is a one function we are calling from the smart contract, that's called get username. Okay, and because of that we are getting this error message. Okay, so we'll fix this later. Okay, everything is working so far, is good. We are getting this error message. That means we are successfully interacting with the smart contract, and whatever code we have written, that's working absolutely fine. Okay, okay, you can expand this and you can have a look at what exactly going on. Okay, okay, things are looking pretty good. That looks pretty awesome. Okay, that's how it look. Let's come back to the code, bring this down, and let's close this one, and let's come back to the component, and we can go back to this navbar, and now we can start working on the model. Okay, so this is the entire navigation we have here, and here we have taken this model and error message, which we're going to use in our navbar as well. Okay, so let's create the model first. Okay, so let's come here all the way down, and we're going to do it right up here. Okay, so we'll take this component, model component. If open model is true, then we only display this component. Okay, so we'll have this div. It will have a class called, let's say, model box, and that we're going to use the model which we have created, model component, and in this we're going to send the props, and in this model we're going to pass props, because we're going to use this model in two places: one at the time of creating account and at the time of adding friend. Okay, so I want my model to dynamic. Okay, so let's send the props. So first thing, we have send this open model. We'll set open models. We'll have to send the title of the model. So welcome to, we have to send the head, chat body, we have to send the info. So I'll come here, I'll take this paragraph and I will take Lauren some dummy text. Simply grab this text and paste here and delete this one. Okay, so this is the info we have. Now we'll take this small text, small info, in that we'll say kindly select your name. We'll take the images and we'll get this image from the hero. Okay, and we'll have this function name, because in both the places we're going to call two different function, when the user will create an account and when they will going to add a friend. Okay, so in this we're going to pass this create account function. Okay, so that's the props we are sending here. Okay, so we need a couple of more data, I think so we have this account, username, and connect wallet. Let's come back to the context, and here we're going to receive this create function. Okay, create account, and we need to receive this error component as well. That looks pretty good. No problem we have so far here. And things looking good. Now let's come here. We're going to take this error component. So if we have an error message, if we don't have an error message, then we don't want to display. But if we do have an error message, then we want to display the error component. Okay, in that we're going to simply pass the error as a prop. So these are the two components we are here. Things are looking good. Now we can simply come here in our style file, and here we're going to target that our model box will say something like position is going to be fixed, insert 000. It will have a background color to our primary color. It will have a Z index, so it will be on top of everything. 77. Now that looks pretty good. And the same thing we have to do in our media query. So we'll say box position is going to be absolute, insert 0 minus 70% and 0. Okay, so that's how it will look here. If I try come here, so things are looking good here. No problem we have here. Let's close this one, and to show you that things are working fine, let me turn this to true. Okay, and save it, and here you can see, boom, it's working fine. So to show you it's working fine, let's try to type a text. So let's get into the model component, and in that we're going to simply type, let's say, model, and here you can see it's working fine. And now we're going to receive the props which we have sent in our model component. So let's save it. Let's come here, and we have to grab one by one. So let's come here and simply copy this open model, pass here. We have to simply pass this title. So let me do it very quickly. Head info. So this is all the props we have here. Now we have to import a couple of things from React. Use state, use context. We have to import the image. Now we have to do the internal import. So we have to import the style file that's coming from the same directory. Now we have to import the images that's coming from the assets folders. We have to import the, let's say, come here in the context. We have the context. What is the name? Chat app context. Copy and paste here, and that's coming from the context, chat app context. Okay, now we have to import the loader. Okay, so, and that's coming from the index, component index, from dash component index. So these are the external internal import we have here. Now we can simply come here. We have to define a couple of use states. So first thing we need is the name. We need the, let's say, account address, and we have to import the data. So we need the loading state, and that's coming from the context. Okay, chat app context looks pretty good. Remove this and take a div. It will have a class called style.model. We'll have another div, model dash box. Inside that we'll have another div. It will call model box left. We replicate it. This will come right. In the left we're going to add the image. So src, we're going to display the hero image. Actually we have here the image. Okay, so we have this image and we have this image. So what I want to do, let's come back to the navbar, and here you can see we are passing the props. So images, I want to remove this s. Okay, grab that, copy and paste, replace this and replace it here. So we have the image. Alt buddy, you can type whatever you want. Width is going to be 700 and height is going to be 700. Now let's work on the right section. We'll take this h1. We have the title. We'll have the span. Inside that we're going to take this head. Okay, that's what we have here. We'll come down. We'll take this paragraph. In that we're going to tag this info. Down below we're going to take this small. It will have the small info, and down below we're going to have another div because we want to take, and now we're going to take the input from the user. Okay, so we'll have a div, it will have a class called style model box right name, and in that we'll have another div, it will say style model box right name info. In that we'll have the image, we'll say source image, we have the username, all tag is going to be user, width is going to be, let's say, 30, and height is going to be 30. Now we have to take the input, so we can take the data from the user, and it will be, let's say, type text. It will have the placeholder, will say your name. It will have on click on change function. In that we have to simply update that. Okay, so state name. Okay, and that's the name we go to assign to our e.target.value. Okay, so here we are assigning that. Simple, nothing complicated. We'll come down and we're going to simply we need one more input field. So for that we're going to simply replicate this and paste here. Okay, and we have to change this data. So we'll change this to account, and here it will become set account address, and here we have to change this to dynamic one. Okay, so here we're going to display the account address, and we have to display this enter address. Okay, so when someone will try to add a friend, in that we want to display the enter address, but when someone try to create an account, on that time we want to display this address of him, and we display this empty input for the entering the name. Okay, so simple logic, it will make sense, just walk along with me. So that's the entire logic we have. We don't have the account, so we have to send it as a prop address account. Okay, now simply change this one is, let's say, open box. Okay, make sure to do this, simply copy and come back here, change this one, and now we have to simply receive the address as well. Okay, things are looking pretty good, not a big deal. Now let's come down here, we're going to take another div, it will have a class called style navbar box right name button. In that we're going to take this button, it will have an on click function, and the function we want to call is this function name, and in that we're going to pass the name and the account address. And okay, here we have that data, name and the account address, and we're going to call, let's say, we'll have a space and we'll call, say, image. We'll have an image and image dot send, it will have all text send, width is going to be 300, height is going to be 30, and it will have the simple submit text. Okay, so this is the submit function now replicated, and this is called cancel close, and this will become cancel. And here we have to change this function name, so all we have to do is to set open box to false. Okay, so we can close that model. So that looks pretty cool, and that's the only thing we have to do here in the model section, and that's how it's looking. You can see we have the images, and right now you can't able to see the other data because it's down below, because we have hide the scrolling thing. Okay, now let's come here, and things are looking pretty good. Now simply grab the model and let's start working on the CSS part. Okay, so we'll take the model and we'll take the width is going to be 85%, margin 1 rem auto, model box, we'll say div is going to be fr and 1fr. We'll take this align item center, we'll take this media query only, and max width is going to be 35 em, width is going to be 90%, margin is going to be get template column 1fr. Okay, that's how it will look. Now let's start working here. So model box right h1, and font size is going to be 3 rem, color is going to be our second primary, and we'll have the line height 2.9, model box h1 span, and we want to increase the display is going to be block, and font size is going to be 5 rem, so a little bigger, and we have to get the box right small, and in that font size is going to be 1.2 rem, color is going to be second primary, and we have to get the box right name info, display is going to be flex, align item center, margin, block is going to be 1 rem, gap is going to be 1 rem, background color is going to be RGB, and 000 0.25. Padding 1 RAM, border radius 0.5 RAM, cursor pointer. So things are looking pretty good. You can see things are taking shape. Let's come down. We have to take this right menu info input. Width is going to be 100%. Background color is going to be transparent. Outline none. Border none. Color is going to be our second primary, and we'll take this model box right name button, and we're going to display is going to be grid template column 2 FR gap 1 RAM. We'll target the button itself. We'll say background color is going to be transparent, outline none, border none, color is going to be our primary, and font size is going to be 1.2 RAM, and font width is going to be 700. And let's take this text transform to uppercase, and let's assign a background color. Okay, so I want to have my second primary, okay, the light one. Okay, I remove the other one, transparent one, and things are looking good now. Padding is going to be 1 RAM, border radius 0.5 RAM, and display is going to be flex, align item center, and justify contains center. Okay, and gap is going to be 1 RAM, cursor pointer. Okay, so things are looking pretty good. You can see it looks beautiful. Okay, now we have to work on the media query. So we'll target the model box right H1, and we'll say font size is going to be 1 RAM, line height is going to be 1.2 RAM. Okay, model box right H1 span, and this will become, let's say font size is going to be 2.5 RAM. That is smaller, beautiful. And we'll target the name button. Display is going to be grid column 1 FR Z index highest. Okay, that looks pretty good. And we can come here, we have to make it 95, sorry. So that looks pretty good. You can see pretty big. This looks good. And this is how we look on a desktop, 100% responsive for both devices. If I click on this, nothing is working. Okay, we have to make it work, and the reason why it's not working, we have to come back and go back to this, close this one, and go back to this. Come on, where it is. So here we are in the here we have calling the function. So I know what's the problem is happening here. So let's come here in the nav bar, and here you can see here we have to remove this, and now it will work fine. Click, and now you can close, open, close, open, close. Things are looking pretty good, and this model is looking absolutely fine. And let's try to add the loader. Okay, because when the transaction will get completed, okay, when the user will register themselves in this application, so that the function will take a little bit time. Okay, so we have to display the loader. Okay, so let's take a dynamic block, and we'll say if loading equal to true, then we want to display the loader component. Okay, simply take this, and we have to call the loader component, else we want to display the normal component. Okay, take that, simply grab this code and paste inside this. Okay, things are looking pretty good. Hope these things make sense to all of you guys. Okay, things are looking pretty fine. Let's close this one. We are done with this model, and now we can start working on this loader. Okay, so let's click on this, and let's do the internal import. So we'll take this import style. We need the style file. We have to import the image. We have to import the images, and that's inside the asset folder. Here we'll take a div. Okay, it will have a class loader. Inside that we'll have another div. It will have a loader box, and in that we'll have the image. Okay, has source image dot loader all tag, and we have to provide the width and the height 100. Okay, not big, pretty small. So that's the loader component. Nothing else we have to do here. Simply come here, go back to the CSS file, and here we have to write a basic CSS for this. So we'll target the loader. Let's say target the loader box. We'll say text align center, margin 1 RAM and 0. Okay, and that's our loader component working fine. And now we have to work on the error component. Okay, let's come here, because these are the very small component we have to write very quickly, and we have to finish it up. Okay, here we have to receive the error as a prop, and here we go to follow the same general convention. Okay, so we have the prop, and we're going to do the internal import. We have to import the CSS file as well, and that's coming from the same directory. And here we'll take a div class, and we'll call it error. Inside that we'll have another div. We'll have a class error dash box, and that we'll have this h1. Please fix this error and reload browser. Okay, and here we're going to display the actual error message. Okay, so that's the entire JSX part for this error component. Now we have to work on the CSS. Come back here. We're going to target that error. Position is going to be fixed. Insert 30%, 30%, 45%, and 30%. Z index top, and margin 0 auto. Background color is going to be our, for our primary color, we have the text align center. Border radius 1 ram, padding 2 ram, border radius 50 pixels, and background color is going to be our this second primary, and box shadow. And this is what I have generated from one of the box shadowing tool. Okay, so this is the value from where I've got it, and that's the same thing I'm writing here. Okay, so I have to place this value, and it's minus 5%, minus 5%, and 5 pixels, sorry. And here we have to pass the color value. Okay, so this is our error component. Let's write the media query for this. Max width 35 em, error, and we have to simply do this 10%, 10%, 55%, and 10%. Okay, so that's the entire error component we have. It's looking absolutely fine. Okay, close this one, and this looks pretty good. No issues we have so far here. Close this one, close this one. So far what we have done, we have worked on the model component, we have worked on the error component, we have worked on the loader, we have worked on the nav bar. So we are already done with the 4 components here. Okay, so let's come here, and you can see everything's working fine. Okay, so currently we are not connected with the application, that's why we are getting this error message. Okay, if you reload, we are getting this error message still. Let's do this console log. Okay. And if we come here and make this side by side so we can see, so this is the error message we were having. Okay, and now it's time to fix this one. Okay, so let's come here, and here you can see here we are in this chat app context. So what we can do, so I'm simply logging out the entire error and click here, and here you can see, so this is the problem we are having here. So this error message we are getting from the our smart contract. You can see user is not registered. Okay, so this is the problem we have. Let's come here, and here we are calling this function. So let me drink. Okay, so here we are calling this function get username, and because of that we are getting this error message. Okay, so simply comment this, and now it will work fine. So let's reload the browser, and you can see no more error we have, because currently we haven't created an account, and we are trying to fetch the name of that user according to this address. Okay, so things are working fine. Now let's come here. No more error we have here. Simply come here. Here you can see, let's log out and reload the browser, and we are getting this error message because we are not connected, and here the MetaMask is open, and now we can simply log in. Okay, you can see the error logs here. Type your credential. So we are connected with the application, reload the browser, and you can see no more error we have. Okay, so we're going to fix this weird problem. Okay, you can see every time someone will open the application in their browser, this error message will pop up. Okay, but we don't want that kind of behavior. We're going to fix that as well. Okay, so things are looking fine so far, so good. Let's click here, and you can see this is the entire our create username model is working fine. Okay, so you can see we have the predefined address, and you can type your name. So what we can do, let's create a name. Okay, let's create the user. Let's register ourselves into this application. Okay, so I'll type Daulat Hussain, click on submit. Okay, I'm getting this error, and I know why this is happening. Okay, so let's come back to the code, and here you can see at the time of creating the account, we are checking for the data. Okay, we are checking for the name and the address, but we are only passing name, not the address. Okay, but actually we don't need the address. So what we can do, we can simply comment this part. Okay, we don't need to check it for this. Okay, now if we reload the browser, and if I click on this create, and everything's working fine. Now let's type the name. So I'll say Daulat Hussain, Let's click on this, and you can see it's working fine. Here we are making the interaction with the smart contract and this function create account. Okay, this looks fine. Let's click on confirm, and you can see our loaders got activated, and here we are on the home page. Things are looking fine, and finally we have created our account into this application. Okay, right now you can't see that, but we have that. Okay, everything's working fine. Let's come back here. So if I simply try to uncomment these functions, you will see that I will get the name, my name back. Okay, because this function will only execute if the user is registered themselves into this application. Okay, so let's turn this back, and you can just focus on here. Okay, so you can see I got $Hussein. Okay, I got this $Hussein, I got the name. So that looks pretty good. No problem. We have this one is also looking fine. Now what we can do is, let's close all this tab, and now we can start working on the get all user. Okay, on the home page. So let's create a page called all user. Okay, in this page we're going to display all the user who have created their account into our application. Okay, so we'll type rfce. We have to create the css file for that, all user dot module dot css. That looks good. Now let's import a couple of things from React: use state, use effect, and use context. That's what we have here. Do the internal import. We have user card, we have that's coming from the index. Now we have to import the style file, and that's coming from the style folder. So where it is, style, and we have the all user models. We have to import the chat app context, and here we're going to simply call the user list. We have to call the add friends, and that's coming from our chat context. Okay, nothing complicated. We are following the same old school logic here. So here we have this functions, we have this user list, and we have this add friend. Okay, so this function will allow us to become friend. Okay, and now we can start working on the JSX part. So div, it will have another div. Inside that we'll have a class called, let's say, all user info, and that will have this h1, will have this find your friend. Okay, that's the title. We'll come out of the div, we'll take another div, and we'll say all user. In that we'll have this dynamic. So we have the data of all the user who got registered themselves into this application in this, okay, user list. We're going to map over it. Element I, we have to do instant return. Okay, we'll take a card. Okay, this is the user card component we have created. Okay, and in that we're going to send the data as a prop. So we have to set the key and element and the I, and we have to send the function as well, add friend function, and that's what we're going to pass it. Okay, so that's the entire component here. If you come here, you can see our router is working fine, and here we are back on the home page. It's working fine. You can switch back, come back, forward. Okay, it's working fine. That looks pretty good. So that's the only thing we have to do here in this for time being. Let's come here, and we have to do the styling for this. So we'll say info, width is going to be 80%, margin 4 RAM auto, font size is going to be 1.5 RAM, all user, width is going to be, let's say, 80%, margin 2 RAM auto, display is going to be grid template column repeat 3 1FR, gap is going to be 3 RAM. Okay, that looks pretty good. You can see everything's perfectly aligned, everything's working fine. Let's write the media query. Okay, so only and max width is going to be 35 EM. We'll target the all user info, width is going to be 90%, font size is going to be 1 RAM, and margin is going to be 2 RAM auto. Okay, let's target the all user, width is going to be 90%, and grid template column 1FR. So that looks pretty good. Okay, things are looking good and 100% responsive for all the devices. Let's do and let's check. You can see it's looking absolutely fine. no more error we have. Okay, so now let's close this one and come back to the user card component, and here we have to receive this props. Okay, simply come here, and here we have to go import couple of things. We need to import the images. Okay, we have to import the images. We have to do the internal import, so we have to import the style file. We have to import the images that's coming from the asset. Okay, now let's come here, and we have to receive all these props. So let's receive this element I and this. Okay, we have this props. Let's take this dynamic block and let's start working on the JSX. So we'll take this user card. In that we'll have another div. We'll have a called user card dash box. Okay, and we'll have an image. So image, and here we want to assign different images to every single user. Okay, so that's how we can do it in React. In Next.js. So we'll take this array. We have the name of the images. Okay, and we're going to simply change this number. Okay, I+1. You can see if we come back in the asset, you can see all the images I have defined img1, img2. Okay, so I have defined this. If I come back to the index, you can see this is how I'm exporting imag, image1, image2. Okay, so I'm only changing the number, and that's what I have talked about in the starting point. Okay, and now we have to add the property. So all tag user width have to assign, height have to assign. So this is also already working. Okay, now let's take another div. It will have a class, let's say user box info. In that we're going to say the name of the user, and we have to display the account address. Okay, so simply comment this and let me show you that what data we have got. Okay, so just remember that I have already created my account. Okay, so here I'm going to log out the data element. Okay, in which I have the data of the user. So let's come here. You can see right now we're displaying this image because we have one account. Here you can see that. You can see here we got this array. You can see it says 2 array, but we have the one data. Okay, so we have the name, we have the account address. Okay, that looks pretty awesome, and that's what we are trying to display right up here. Okay, so let's comment this one, and we have this element dot, what is the name we have? Okay, sorry, my bad, comment this out, and let's get back the name. So the name, we have this account address, copy and paste here. If we come here, you can see here we got the images, we got the name of the user who registered. So I'm Daulat, I register myself, and this is my address. It's looking fine. Okay, and I want to add more thing. I want to slide this down, so I don't want to display the entire message. I want to display on 25, and I will have a button. So when someone will click on this button, he or she will become friend. Okay, so it will have an on-click function, and we have the add friend function here. Okay, simply that's what we're going to call, and we have to pass the data. So we have to pass the name, and we have to pass the address. Okay, so here I'm passing in the form of object. Okay, so name, and we have to pass the account address, which we have inside this element dot account address. Okay, so make sure you have to pass this in this way format, because if you come in the add, that's the exact data type we are following here, the convention we are following here. Okay, okay, you can see we are doing all of this, looking absolutely fine. And let's type this message, sorry, name, add friend, and we'll take one more. We'll take this span, and it will have a class called number, and it will take this I+1. Okay, so this will tell me that, like, what is the count of the user. Okay, you can see right now we are getting this error message because you can't be friend to yourself. Okay, so this is my account, and I'm trying to become a friend of my. Okay, so that's not possible. So that's why we are getting this error message. Okay, so the entire logic is working fine. Now what I want to do, I don't need to check for this data. Okay, so I can simply comment this part. Okay, I don't need to check this. Okay, now if I reload, no more error I have. You can see everything's working fine. If I click, I'll get this error message because I can't be friend to myself. Okay, so our logic is working fine. Okay, it's working fine. You can come and you can see that what the problems you are having. Things are looking good. Now we can simply come here and we can start styling this card component. Okay, so we'll take user card. Let's make this side by side so you guys can see what we are working on. We'll say background is going to be RGB 0.25. We'll have the border radius 0.5 RAM, text align center, padding 1 RAM, position relative, user card box image, and border radius 50%. And I forget to assign the classes to the images. Let's assign that. Copy and paste here. So it's looking fine. Now let's come here. User card box info, line height 0.6, user box info button. Color is going to be this background color, and color is going to be this, our second primary. Width is going to be 50%, padding 1 RAM, border none, border radius 0.5 RAM, font size 1 RAM, cursor pointer. You can see everything's working fine. Open, close. Things looks beautiful. Okay, it's already taking shape. Let's take the num. Position is going to be absolute. Right 1 RAM, padding 1 RAM, 1.3 RAM, border radius 50%. Background color is going to be our second primary, and top is going to be 1 RAM. That's how it will look. Pretty good, you can see, and that's how it will look. So right now we have one user and we have displaying their data. Okay, things are looking good. You can switch front and back. Things beautiful. Close this one, and come here. So we are done with the most of the part, but now comes the most important things, which actually creating the chat functionality. We have already created that. Now we have to simply add that. So that's what we're going to do here inside this friend. Okay, so let's close this folder, and here we have this call filter component. Okay, so let's start working the filter component first. And this one is very simple. We have to import a couple of things from React. Okay, use state and use context. We have to import the image. We have to do the internal import. We have to import the style file. We have to import the images. Okay, now we have to import the card chat app or context, and that's coming from our context department. Okay, context. Okay, we have to import the model, and this model will attach to add friend. Okay, and that's coming from our index. Things are looking pretty good. Now let's start working on here. So we have to import the data. So use context, app context, and in that we're going to use the account, and that's coming from here. Okay, that's the account we have. Okay, that's also we're going to import. Let's take this use state, and we have to define. So we need the add friends false. Let's start working on the JSX now. Take a div. It will have a class called filter. It will have another div. It will have a fly filter box. Inside that we'll have a div. It will say filter box left, and we'll have another one right. In the left section we'll have another div. It will have say filter box left dash search. In that we'll have the image. So we'll have the search image, alt tag. We have to assign the width is going to be 20 and height is going to be 20. In that we're going to take a input, so user can search. It will have a type to text. It will have a placeholder, so we'll say search. Okay, that's it. And now let's come here on the right hand side. We'll have a button. It will have the images. We'll search. We'll say image dot clear. Alt tag is going to be clear. Width is going to be 20. Height is going to be 20. And it will also have a text called clear chat. Okay, simply replicate it. This will become, let's say, add friend, and we have to change the, it will have a on click function, so we'll have to call this function, say set Okay, set add friend to true. Okay, this looks pretty good. And we'll come here and we're going to call this model component, okay, because that's the component we're going to display. So let's take a div dynamic block. We'll say add friend. Okay, if the add friend is true, then only we want to display this model component. Okay, so we'll take this div and it will have a class called style dot filter model, and that we're going to call this model component, and we have to send the props. Okay, so first thing we have to send this open box, and then we have to send this set add friend title welcome to, we have to send the head, and this will become, let's say, chat buddy. Now we have to send the info. We'll type this low response, simply copy, and that's what we're going to say. Remove this one, and we have to take this small info, and that we have to pass this kindly select your friend name and address. Okay, we have to send the images, so we'll say image hero image, and we have to send the function name. So the function we want to call this add friend. So these are the props we are sending and receiving in the component. So it's already working fine. Okay, as you can see, if we reload the browser, okay, that's weird, nothing is here. Here we can see, but here we don't have anything. Oh, I guess why it's happening. Okay, so that's look absolutely fine. So let's come here and we have to get back into this in the pages in the index, and here we have to call this component. Okay, so let's come here, we have to import the component. So we have to import the, let's say, filter and the friend component, because those are the two components we're going to display in this index. Okay, and that's coming from the, let's say, component slash index. So we have this components. Now I want to simply come here, comment this to one, because right now we don't need this. If we need, we can definitely uncomment this. Okay, let's write this JSX path. Simply remove this one. We have to take this div. It will have the filter component and it will have our friend component. Looking fine. If we save it, come back here, and here we are getting an error message. Okay, so maybe I have done a spelling mistake. Okay, cart app context. Okay, I think I have done my spelling mistakes. So to fix this, simply copy this one, and that's the problem we have done here in the filter. Okay, and that's what I'm going to paste here. Simply copy this, and okay, here is the problem we have. It's not X, it's C. Okay, I realized that I made a spelling mistake in the context. It's CONTEXT, context. So I wrote the right spelling, but in the entire application we have used C instead of X. So let's go with the wrong spelling. I hope you guys have noticed this. So it's working fine. Okay, if you relate, you can see this is our filter component. Okay, if you click on this add friend, you can see this is the model we have open, and the data is changed. Like, kindly select your friend and name, your name, and the enter address. Okay, looks fine. Looks fine. Okay, now we can start styling this portion. So that looks pretty good. Now let's get this filter, and now we have to style it up. So we'll type the filter width is going to be 80%, margin 1 ram auto, filter box, display flex, justify content space between, filter box left, search, display flex, align item center, gap 1 ram, border radius 2 ram, padding inline 2 ram, 1 ram, background color RGB 00002.25, color is going to be our second primary, Let's add a media query only, and max width is going to be 35 em. Filter is going to be, width is going to be 90%. Box is going to be filter direction column, gap 1 ram. Let's come here, and we have to target the filter box. Left search, input, background color is going to be transparent, outline is going to be none, border is going to be none, padding is going to be 1 ram, and color is going to be our second primary color. Width is going to be 20 ram, so that's how it will look, pretty good. Let's come here, we have to target the filter box right. Display is going to be flex, gap is going to be 1 ram, box right button, background color is going to be RGB, this, outline is going to be none, border none, padding 1 ram, 2 ram, color is going to be our second primary, border radius 2 ram, font width is going to be 700, and display is going to be flex, align item center, that's how it will look, pretty good. Cap is going to be 0.5 ram. Okay, we have to target the filter model. Position is going to be fixed, insert 000, background color is going to be our primary color, and Z index is going to be this number. Okay, that looks pretty good, not a big deal in that. If you reload the browser, you can see it's looking good. We can come into the media query and we'll target that filter box. Filter model, position absolute, insert 000. This looks fine. You can see we can easily able to scroll and things are looking pretty good. Now let's come here and we have to take this button. Font size is going to be 0.5 ram, so that looks pretty good. I think why the button is not working. Okay, let's keep it like that for time being. You can see everything is working fine. You can come, you can click on this. Okay, I have given this delete image. I think I have to change the image. So let's come here, and the image I want is, let's say, account, not this one. I need this username, not this one. I need this user account, no, not this one. I want user. Okay, I guess user is the right image. User. Okay, I got it, this one. Look, this is pretty fine. If you click here, you have that, and close it. Okay, so right now we have this one friend, okay, which is myself. I have created this account. Now let's come here, and this time what I want to do is, let's come here and let's switch to the next account. Okay, let's switch to account number 3 and let's create an account. Okay, so we have to, so if you have no accounts in your MetaMask, simply copy and paste the accounts from your, like from your terminal, all the 20 accounts which Hardhat provides you. Simply copy the private key here and import it. Okay, I have already imported a couple of accounts, that's I'm going to use it here. Okay, so I'm going to use this account number 3, and make sure you have to remove the history. And this is the problem we have in MetaMask. Okay, if you don't do that, your transaction will get failed. Reload the browser, and you can see that we are getting this error message. We're going to fix this one. Okay, please fix this error and reload. Please install and connect wallet. Okay, click on this and let's reload this one. Okay, and again we are getting this error message. Let's do the inspect element, and what I want to do is, let's come back here and where we are calling that function. So here we are, and so here we have this. So this is the functions which is causing the problem. So simply comment this, and now you will not have any issues. Okay, it's looking fine. Create account, and I have to call the name. I want to say Schwab by. Okay, click on submit, and here you can see we are interacting with the smart contract. Click on confirm, and boom, here you can see we are redirected to the home page, and here we have created one more account, Schwab by. Okay, it's working. Let's switch to account number 4 and let's create one more. You can see it's looking beautiful. Okay, we have this different avatar. Let's create it, and this time I want to call this, hit Ryan, hit enter, confirm, and boom, here So here we have Ryan as well. Okay, so we have created this 3 account, and this is the account which I have. Okay, Ryan, and right now you can see we don't have the name. And now if I comment out this, you can see I got Ryan back here. Okay, so right now I'm connected with this account Ryan, and let's make a friend. So the friend I want to make with Daulat. Okay, so let's come here, and here we are calling this add friend function, confirm, and here the transaction went successful, and now we are friend. Now Ryan is friend with Daulat, and that's the friend list we're going to display here. Okay, on the right hand side, sorry, on the left hand side. So things are looking fine so far. Things are looking good. Now that's how it will look on a mobile device, 100% responsive. And now we can simply close this one, and we can start working on the friend. Okay, so here we have this friend component. In that, okay, all the things are looking good. Now we have to create 2 more folders, 2 more components here. Okay, so let's create a file folder, and we'll call it card. And in that we have to create the JSX, and we have to type RAFCE. We have to create the CSS file for this card as well. So card.module.css. Okay, simply import that CSS file here. That's looking fine. So we have the CSS file as well. Simply close this one, and now we have to create one more, which is a chat component. Okay, chat. We have to create the JSX file for this. RAFCE. We have to create the CSS file for this as well. So module.css. Okay, that looks good. Now we have to import the CSS file as well here. So that's coming from the same directory. Close this one, and now we can start working on this card component. Okay, so now we're going to import couple of things from React. So looking so far so good. We have to take this use effect. We have to import the images. We have to import the link, and we have to do the internal import. Okay, actually we already have this internal import. Here we're going to import this images that's coming from the assets folder. Okay, and that's what we have here in the card component. Let's come here and go back to this friend component. Okay, in this we're going to import those card component and the chart component and all the data here. Okay, so let's do a couple of import from the React. So use state, use context. We have to import the images. We have to do the internal import. So style coming from the same directory. We have to import the images. We have to import the card component, and we have to import the chat component. Okay, which we have in the same directory. Okay, chat/chat. Okay, so these are the internal external import we have. Now let's import our chat app context, and that's coming from the context. Okay, so far so good. Now we can simply start working on here. Okay, so let's come here. We have to take this data array 1 2 3 because we want to render as a demo data. Okay, so that's why we are taking this demo data. Okay, actually we have the data. Okay, so we can simply import the data. So let's come here, and we have all the data here in this. Okay, so we're going to import one by one. So send message, and that's coming from this context. And let's import all the data. We need account, and what else we need? We need this friend list, and we need this read message, and we need this we need username, and we need this loading, and what else we need? Last one is this current username. Copy both this one and paste it here, username and user address. Okay, so these are the 3 things we have here. Now I think we need this read user as well. Okay, so these are the props we are receiving from our context data. Sorry. Okay, simply comment this one because we have the data in our friend list. So now we can start working on the JSX. Okay, we'll take a div. It will have a class called friend, and that will have another div. We'll say friend dash box. Inside that we'll have a div, we'll say friend box left, it will have a right. Okay, in the left one we'll have this dynamic block. Okay, so we have this all friend in this, so we'll say, let me console log out and let me show you what I get. Okay, friend list. So currently I'm friend with Daulat, so you will find that data here. Okay, so let me console log out this. So right now I'm friend with Daulat. Let's do the console here and let's make it side by side so you guys can see. Here you can see I got the logs. Okay, so this is Daulat Hussain, I'm friend with now, address. Okay, things are looking pretty good. You can see how everything is coming together. And just remove this and now we can start working on the block. So we'll take this dynamic block, we'll say array, we're going to map over it, and we're going to instantly return. So we'll have a card which, and in that we're going to send this props. Okay, so will this key, we'll have the element, we have the I, and we have to send this read message, and we have to say read this message, we have to say read user. Okay, so these are the props we are sending in the card component. So that's the card component. Now let's come here in the right, and we have to call this chat component, and in that we have to pass this all this data. Okay, function name, and the name we want to pass is send message, we want to pass read message, we want to pass this, let's say what else we want to pass, what else we can pass. So there we have the data. Let's come here, we have to get this friend message. Okay, copy, and that's what we're going to pass here. So let's send this as a props. So these are the three props we have, and we can pass the account as well. We can pass the username because we need all these data. Okay, we have to pass the loading states, loading, and we have to pass the current username, and we have to pass the current user address. Okay, so these are the address, these are the props we're going to receive in the chat component. Okay, so that's looks pretty good. So far so good. Now we can come here, and here we go to receive the props. So let's do it very quickly. Element I, and we have to read user as well. Okay, so things are looking pretty good. Now that's the only thing we have to do here in the friend. So here we are back in the card component, and now we can start working on the JSX. Okay, so we'll have a div, so we'll have a link, and it will have this href, and we have to set the couple of properties. So path, the path we want to redirect to the home page, and we have to send the query as well. Okay, so query, in that query we can send the data. Okay, we want to send the name, and we have to send the query, and in that query we're going to send name and the address. So we're going to fetch that query, and we're going to render the data on the base of this name and the URL. Okay, so that's the entire logic. So we'll say name, and here we're going to say, let's say address, and we have the address in this element dot pub key. Okay, public key. So that looks pretty good. Let me show you the data. So element, and you can see that's what I have here. Let's reload the browser, and okay, so okay, what's the problem we have here? So here we are in this, and here we have, you can see we have this pub key. Every friend will have this unique one, and that's what we are doing here. So far so good, but what's the problem? Let's come here, let's start working on the JSX. Okay, so we'll have a div, it will have a class called card, and that will have another div, will have a card dash box. Okay, it will have the card component will have an on click. Okay, and in that we have to simply call this one. Okay, read message, and in that we have to send the address, and we have to simply call this function as well, read user information. Okay, okay, that looks pretty good. So we'll have another class, and card box left and right. In that we'll have this image, we'll have to pass this image, username, all tags. I'm going a little faster because these are the general things you guys are already familiar. Okay, so here we're going to take the class name, so style card box left image. Okay, and Here we will take a div. It will have a style, card box right middle, and then we'll take this h4. It will have the name of the user, and it will have the, let's say, address of the user, and we have to slice it down. We don't want to display the entire address, 21. Okay, that's pretty good. Let's take a small. Here we'll come and we'll take this div. It will have a class called style, and we'll take this card box right end, and it will have this i+1. Okay, simple logic. Let's come here, and if I reload the browser, okay, nothing is displaying. Why so? What's happening? Oh, I know why. What is the problem? Let's come here, and we have to simply, these things are looking good, but before we do that, let's start styling the friend component. Okay, friend, the main component. Okay, let's start styling that part. So that's copy and simply start dialing. So we'll say width is going to be 80%, margin 1, auto, friend box, display grid template column 1.4 fr and 3 fr. Gap is going to be 2 ram. Friend box left is going to be, let's say, background color RGB, and this is the color we are using. Padding is going to be 1 ram. Border radius 0.5 ram. Let's come here, take the media query. Max width is going to be 35 em. Okay, friend is going to be 90%. We have box 1 fr. So that's how it will look, but still it's not taking place. And can you guess why it's happening? Okay, because here we have to come in this index, and here we have to uncomment this. Okay, so simply remove the, bring it back, and here you can see we got the component. You can see with the dollar and the address and the account, because currently Ryan is friend of dollar. Looking fine. You can see if I click on swear and try to make him friend, confirm, and boom, come back to the chat, and you can see Shoaib is friend to me now. Looking absolutely good. And here you can see we have a problem in the URL. Okay, so we want to send the data in the URL, the name and the address, but it's not working. So we have a problem in that. We have to fix this one. Okay, if we reload and let's do the inspect element, and here you can see we got this data, so it's working fine. We have this to friend list. Okay, that's the public key. Okay, let's come here and let's go back to the card, and here we have the problem. So this is the query we are sending. We have to take this bracket, remove one, and things are looking good. No, we have to remove this bracket here as well, and we have to take this one. Okay, take the name. Okay, take the name, name this. It's okay, make sure to do this change. Okay, make sure to do this change in the query. So we have this name and we have the address. Okay, and we are wrapping it. So make sure to do this change, and now it will work fine. Now if I click here and just have a look on the URL. Okay, if I click on this Daulat, you can see the query is got populated. So we have Daulat Hussain and we have the address in the query. Okay, so we can use this to fetch and render the data in our chat component. Okay, so that looks pretty good. That looks pretty awesome. Let's come back to the code. So that's awesome. Close this one, close this one, close this one, and now we can start styling this component as well. Okay, so we'll take this side by side so you guys can see what we are working on. So we're going to target the let's say card box. Display is going to be flex, align item center, line height is going to be 0, gap is going to be 1 ram, padding 1 ram 0, and border bottom is going to be 1 pixel solid, and we'll have our second primary gram. Okay, so this is the opacity, less opacity, and we'll have a cursor pointer. Now we'll take this card box right, and display is going to be flex, cap 3 ram. We'll target the right middle, and we'll say margin top is going to be minus 1.2 ram. We'll take this card box left, Border radius going to be 50%. This looks pretty good. You can see this is how it will look, our card, and this looks awesome. Click on this, you can see the data is also changing fine. Okay, let's come back to the code, and that's the thing we have to do here in this card. So now we can close this one, and now we can start working on the chat component. Okay, so here we're going to receive the props. So let's come here and receive all the props which we are sending. Function name, read message, friend message, account, username, loading, current username, and we have this current user address. So these are the props we are receiving. Let's import a couple of things from React. Use state and use effect. Okay, import the image, import the, let's say, use router, because we have to fetch the data from the router. Okay, and we have to import the images that's coming from the assets. Okay, we have to import the, let's say, let's come here, and here we are in the utility, and this is the function we have created. You can remember this is the convert time we have created. Okay, and that's the function we go to import. Simply copy and import here, and that's coming from the API. Okay, API utility features. So that's all the imports we have. Now we have to import the loader, because we have to display the loader when the message will send. So these are the all internal external import we have here in the chat component. Looks pretty fine. Now we have to come here and we can take this use state. Okay, so we'll take this use state, we'll say message, we'll take another one, we'll say chat data. Okay, and this data will get from the URL. Okay, so we'll say name and we'll say the address. We'll come here, we'll say const use router, and we have this router. We'll call this use effect, and that we're going to call this if router is not ready, then we have to return this. But if the router is ready, then we have to set the data. Okay, router query. Okay, so that looks pretty fine, and it's gonna be named router query is ready. Okay, so that's the entire logic we are doing. Now let me show you what the data we get. Okay, let me console log out this, and we get the chat data address, chat data name. Okay, now if I do the console log, and let's come up here, and you can see here we got the data, we got the address, we got the name shared by, and that's what we are getting from the URL. You can say the moment you will reload and you will get the data. Okay, it's working fine. Okay, it's working fine, but right now it's not working on the click event, but we have to reload. Okay, we go to fix this weird behavior. Okay, so it's working fine. We are getting the data from the URL and we are updating in our states. Comment this. Now let's start working on the JSX. We'll take a div, it will have a class, we'll say chat. Another div, it will have a less dynamic block. We'll have a dynamic, we'll say if we have a current user and we have a current user address, then only we want to display this block. Okay, class, we'll say chat user info, and that otherwise we don't need to display anything. Okay, empty. And that we're going to take this image, source image, we'll say account name alt, okay, that's the image we have here. Let's take a div, and in that we're going to display the information. So we'll display the name and the address. Okay, we'll say chat user info box, and that will take this h4 and will have the current username, and it will have the current, will have a p tag, because I want to hide this on a mobile device. I don't want to display the address in the mobile, so that's why let's say show, and in that we go to display the address. Okay, current address, and we have to simply looking good. So that's the very first component we have. Now let's come here, we have to take another div, it will have a style, we'll say chat box, In that we'll have another div, we'll say chat dash box. In that we'll have this div, it will have a class called style chat box left. This will become only left, let's say. Let's come here and we'll take this dynamic block, and here we're going to render all the messages. Okay, so we have the messages inside this friend messages. I'm going to map loop over it. Instead return, we'll take this it will have a this element. Okay, in that this element we have the address of the person who's sending the message. Okay, if the person who's sending the message and the message who's receiving, if they are equal, okay, if both are equal, then we want to display this dynamic block. Okay, this div. So class style chat box left title. Okay, and let's bring this down, and in that we're going to take this image. We'll take this, provide the source of the image, username, alt tag, width and the height, and down below we're going to take this span, and in that we're going to display this data name of the user, and I want to display the, let's say, time, okay, when the user is sending the message. Okay, so we're going to call the function. So let's take this, and here we have the function. Okay, remember this is the function we have imported. That's what we're going to use it. Simply copy and call the function, and in that we're going to pass the timestamp. Okay, so element dot timestamp, okay, to number. Actually we don't need to pass this to number, because here if we come in app API, you can see here we are converting that. Here we are already converting, so we can send it as a big number. Okay, so that's the one thing we have here. Now what we can do, simply, else we want to display this, simply grab this one and same thing we're going to paste it here, but here the change in the condition. Okay, so here what we're going to do is, instead of chat data name, we'll say username. Okay, means in my case if I'm sending the message, so I'm going to be the username. Okay, and here we'll say time, and here we'll say time. Things looking good so far, so good, things looking beautiful. Okay, now we'll take this p tag, it will have a key and it will have the message, so element dot message. So this will already work. Okay, and inside that we're going to take this dynamic space. So you can see here we are, reload the browser, and if you click on this, you can see here we can see the name. So if we click on the $, here we get the address, the name of the $, and if we click here, you can see you can switch back to your friends. Look fine. Okay, you can see this is the URL we have. Simply change this, hit enter. Okay, so that looks fine. Now we'll come here and we can start stalling. Okay, so we'll take this dynamic block, we'll say current username if we have and current user address we have, then we want to display this send message box. Okay, so in that, else we don't want to send anything. Okay, so here we're going to take this block, and in this we'll take this div, and this div will have a class called style. We'll say chat box send. Inside that we'll have another div, we'll say chat box send. Send, this will become send, and this will become image. Inside that we'll have the image, so we'll say image dot say smile, alt tag, we'll have the width, height. Okay, we'll come here, we'll take this input. Inside that we'll have this type is going to be text, and it will have the placeholder. So we'll say type your message here. It will have a on change function, so we can store that data in our message. Okay, set message e dot target dot value. Okay, so we can update our state. And now here we're going to take another image, and this will be the source. We'll say image dot file, all tags, and where this will have, so the width I want to assign 50, the height I want to assign is 50. So both looks pretty good. Okay, So that looks good. Now we'll take another this dynamic block, and the reason why we are taking this dynamic block, because when the user will click on the send message, we have to display the loader message. Okay, they will say loading is true. If the loading is true, then we want to display the loader component, else we want to display this image. Okay, the send image. So simply grab this part and paste here, and we have to change the name of the image. Okay, and we'll say send, and it will have a on click function. So we'll call this function, let's say function name, and in that we have to pass this data message, and we have to pass the address to whom I want to send the message. Okay, that looks pretty good. Okay, and that's the entire thing about the JSX. Okay, so that's the only thing we have to do here in the JSX, and that's how it will look. You can see if I simply come here and remove and reload the browser, you can see nothing here, but if you click here, we have all this. Okay, looking fine here, not a big deal. Now we can start working on the style part. Okay, so this is the last component which we are styling. Okay, let's come here and let's start styling it. Let's make it side by side so you guys can see what we are working on. So with this chat, padding is going to be 2 RAM, background color is going to be our primary with opacity, border is 0.5 RAM, overflow Y is going to be scroll, chat box is going to be display is going to be grid template column 1FR, height is going to be 50 VH, width is going to be 80%, margin 0 auto, overflow Y is going to be scroll. You can see it's going to be again scroll, chat box right P, and chat box left P. Background color is going to be our second primary with opacity light, padding 1 RAM, border top right radius 0.5 RAM, and this become the left, and we have to do the same thing for the bottom. Okay, position is going to be, let's say, relative. So that looks pretty good. Let's come here. Display is going to be flex, align item center, cap is going to be 1 RAM, font size is going to be 1 RAM, chat box send image, display is going to be flex, align item center, gap is going to be 1 RAM. That looks pretty good. Chat box send image input, width is going to be 100%, background color our this light, outline none, border none, padding 1 RAM, color is going to be our second primary. That looks pretty good. Border radius 0.5 RAM, chat user info, display is going to be flex, align item center, gap is going to be 2 RAM, line height 1 RAM. So that looks pretty good. Okay, we'll say chat user info box H4, and this will become P. We'll say line height is going to be 0. Okay, that looks good. Let's add a media query. So media going to max width is going to be 35. That's the one we are following. So chat is going to be, let's say, padding 1 RAM. Chat P is going to be font size 0.8 RAM. And we have to take this chat small is going to be, let's say, font size going to be 0.8 RAM. Show is going to be display height. Okay, we don't want to display the address. Okay, show is going to be display height, and that's how it will look. We have some problem in the images. That's the one we have to fix. Okay, and that's a very easy one, and we can do it. So here we have a problem in the image height. So let's try to find out where it's happening. So here we have things are looking good. Okay, here is the problem. Remove this, not 500, only 550. Okay, so that's looking fine. You can see we can change. That looks pretty good on a mobile device as well. Let's reload the browser, and let me simply change this one and remove this one, and let me show you how it looks. So let's reload the browser. Let's try to test this out. Okay, click on this. Let's come here, and I'm going to take this some Lawrence bomb. Okay, text, dummy text. Simply grab this one here and simply come and paste here, and now we can make a request. Hit request. Okay, please type your message. Okay, I know why it's the problem is happening. So let's come here. Here we are in the, simply come here in the context, app context, and here we are in the send. Simply remove this check. Okay, so that looks pretty good. Okay, reload the browser, click on this, and we can simply send, and boom, here you can see it's working fine. Now we are interacting with this, and boom, the transaction went successful. We have sent the message. You can see here you have the dollar to send, and we have the message, we have the time and date. Everything's looking fine. You can see Ryan, I'm Ryan connected with this account, so I'm Ryan, so the account name is Ryan, and Ryan is sending this message. Okay, look fine. If I call this one more time, and boom, that's pretty awesome. If you click here, so I want to do one small fix, because every time I have to reload the page when the transaction is getting complete. Okay, so we're going to fix this issue. Okay, not a big deal, but things are looking fine. You can see we can easily able to send message. Okay, now what I want, if I go to my $1000 account, okay, account number 2. So if I go to account number 2, and first thing I have to do, I have to reset my account, and if I hit enter, so currently you find that I'm friend with Ryan, and the account name is $1000 is displaying here. If I click on this, and here you can see we got the name Ryan, and here $1000. Okay, no, this is not what I want. We're going to change this behavior. It's not $1000, it should be Ryan. Okay, so what we can do here, we can simply reload the page. I think this will fix the issue. Click on this, and here you can see it's Ryan back. Okay, we're going to change this behavior, but things are looking fine. Okay, guys should appreciate that things are looking fine. Click on this, and here we have Ryan. Now if you send the message, you can do it very easily. Hey Daulat, click on this, and boom. If you click here you can see here we have sent the message. Hey Daulat, the timestamp. Things are looking pretty good, awesome. And from here you can easily able to add your friend. So you can see these are the 3 friends we have created so far. Things are looking pretty good, everything's working fine. Okay, let's add some more friends. So we'll take this Shweb Bhai in my friend, click on confirm, and here we got one more friend, Shweb Bhai. So this is Ryan, and this is Ryan we have. Okay, this is Shweb Bhai we have. If we send message to Shweb Bhai, we can do it very easily, and boom, and boom here. Okay, why? Okay, oh, by mistake I've sent back message to Ryan as well. I have to send message to Shweb. Okay, so let's select this one, reload the browser. We're going to change this behavior. Okay, and let's send the message to Shweb. Hit enter, and boom, and boom, here you can see we have sent message to Shweb. So things are looking pretty awesome. You can see things are looking pretty awesome, and that's how it will look on a mobile device. You can see 100% responsive, 100% responsive. You can open, you can close, you can go to wherever you want. Okay, so things are looking pretty awesome. Hope you guys are enjoying this. We have built this beautiful application, and it's so powerful. Okay, stop the application from running, delete the artifacts and cache, and let's redeploy the contract, and let's have a look. Do it from the beginning. Okay, we have to delete this JSONs, and now we can simply start our local blockchain. Okay, npx hardhat node, and now once it start, we have to deploy the contract.
So just wait. Here we have that all accounts, and now let's simply deploy the contract. And here we have compiled successfully, and here we have deployed the contract. So let me simply drag and drop the artifact in the context. Let's move it, and now we can initialize the npx run dev. Okay, we have to start the application, and here we have to click on 3000, and here you are. So you can see this is how it will look. Our MetaMask is popped up, and we are getting this error message because we are not connected with this application. That's why we are getting this error message. We're going to fix this one. Okay, so what I can do, I can simply let me connect my wallet with this application, unlock, and just wait. And here I have simply reload the browser, and boom, here I'm getting this error message. So let me fix that. So let's bring this down, and let's come back to the context, and the error message we are getting from here. Okay, so fetch data, because as you remember that we have not registered ourselves into this application, and we are trying to fetch the name of the account. Okay, so that's why we are getting that error message. So we can simply remove this error. Okay, actually it's not an error. Okay, so I will simply comment this, and it will fix the problem. So that's the fix we can do. Simply reload the browser, and here you can see we have no more error. So make sure you do that, because it's not actually an error. Okay, so we can allow the user to click and connect. Okay, we don't want to display the error component. So that looks perfect. Now we can come into the MetaMask, and I will go here, and I'm simply log out. If I log out, you can see the MetaMask it pop up. We don't have any error right now, and we can simply log into the applications. Okay, you can see that we are calling this get username function, and still we are not getting an error. Okay, because this function will keep check that in the background. Okay, so it's working fine. Okay, so we'll go in this way. Now everything is looking fine here. Let's come here, provide the credential, and I'll click on unlock, and here we are. This looks beautiful. Okay, we are connected with this application. If we reload the page, and boom, here we are connected with the application. And now let me simply reset this, otherwise it will throw an error and my transaction will get failed. So make sure whenever you change your account, you have to do this reset. Okay, so reset, and now I can just create my account. Okay, simply reload the browser and just click here, and I will type Daulat Hussain. Okay, I'm going to create my account. Click on submit. Here you can see we are in interaction with the smart contract create account. Okay, click on confirm, and boom, you can see here we are redirect to the chat page, and you can see my name is displaying there, Daulat Hussain. Okay, so this is looking fine. If we come back to all user, here you can see this is the user which I have registered, and have registered myself. Okay, so it's looking fine. Now let's come here in the MetaMask, and what I can do, I'll simply create couple of accounts. Okay, I'll simply create close to 10 accounts very quickly. Okay, so just watch that with the background music. So here I have created close to 10 accounts. You can see all the accounts which I have. Okay, that's how it will look. Let's come here. Let's go back to the account number 2. Okay, and because I have registered myself as account number 2, let me reset my account. Let's come here and reload the browser. And right now what I'm going to do is right now you can see I have no friend, I have no chat thing. Okay, so I'm going to create couple of friends. So I'll click on this add friend. Okay, and I can add friend from here as well. Okay, so here you can see if I come chat here, I have my one friend Shoaib Bhai. Okay, I have this his account address. Let's add couple of more friend. Okay, I'm close to add 6 friend. So let me do it very quickly. You can create as many friends as you want. Okay, here I have created 5 friends. You can create, and now I will click on the swap by, and this is the account address. You can simply switch to your friend and you can have chat. Okay, now what I want to do, I'm going to simply take a dummy text and I'm going to start with that because I don't want to write. Okay, simply copy from here, and that's what I'm going to paste here. I'll simply paste and I will try to make a connection, and here you can see we have our MetaMask, and boom, here we are dealing with the send message. Click on confirm, and here you can see we have, click here, and here you can see we have the message. We have successfully sent this message to our swap by. Okay, and that's from me, Daulat Hussain. You can see we have the timestamp and everything's working fine. If you send one more time, you can see it will send the message to him. So let's send a couple of messages because it's really good to see that things are working fine. You can see we are getting this weird behavior that every time we have to click on this, we're going to fix this. Okay, if I click here, I can have the messages. Okay, we're going to fix this behavior. So if I come here in the contract, in the context, if I go back to the index, and here I have my get all users. Let's go back to the index, and here I have the friend component, and in that I have the chat and the have cart component. Okay, so I can do the fix here. So let's come back to the chat component, and here what I will do, here you can see that we are getting the data from the URL, okay, from the router. And what I want to call this function. So read, so where it is, so we'll call this here we have the name of the function. So we have this read message, and that's the function we're going to call here, and in that we're going to pass this router address. Okay, the person who are we talking with. Okay, we have to pass his address, so every time the page will reload, we'll have the history of the chats. Okay, so that's working fine. If I save here and if I come back to the application, you can see this is the error message I'm getting. Currently you have no error message, and it's actually not an error. Okay, so we can have to remove this as well. So let's reload the browser, and I'm still, you can see the message is displaying. Okay, and this data we are fetching from the URL. Okay, so the message is displaying absolutely fine, but we are not able to have the name of the person and the address. Okay, we are getting only the message, so we have to call this function as well. So you can see if I reload the page, I can get only messages, but I'm not getting that from whom I'm getting the messages. Okay, from whom, from which of my friend I text this message. Okay, so I can fix this very easily. You can click on this and you can simply do one thing. Let's try to send a text. So I'll say, hey Daulat, I will hit on the request, and you can see MetaMask popped up, and here we have to click on confirm, and boom, here we have successfully sent the message. Okay, if I scroll down, you can see here I have the message, but I have to display the name to whom I have sent the message. Okay, and that's very easy. We have to call this function read. So we don't have this function here. Okay, so we have a function read user. Okay, so we have to call the functions. So to get the function, what we can do is we have to come back to the cart component, and here we have this read. Okay, read user, this is the function we need. So simply copy that, and that's what we're going to simply come here, and that's what we're going to receive in the chat component, and that's what we're going to call here. In that we're going to pass the address of the person who I'm talking to. Okay, so route.query, in that I have the address. Okay, so that looks fine, and you can see reducer use is not defined. Okay, my bad, so I forgot to add in my friend component. Okay, so to fix this, I have to send this as a prop. So let's come back to the friend component, and here I have to send back as a props. Okay, and now it will work fine. So every time I will redo the page, I will get the name of the person and I will get the history of the chat. Okay, so you can see now it's working fine. Beautiful. Okay, beautiful. But in this way we have a problem. I'll show you what's the problem we'll have. Okay, so that's working fine. I'll type my message, hey boy, and if you guys haven't subscribed to my channel, do so. This will help me a lot and motivate me that you guys are really liking it. Okay, okay, so that looks pretty good. Okay, that's good, and that looks fine. You can see we have successful text the message, and now let me change the account to see the message I have sent it. So this is account number 3, which is Shoaib's account. Okay, so let me log into that account and let me clear the history, restore the account. Okay, reload the browser, and boom, here you can see I have one friend. So this Shoaib is connected with me from Daulat, and that's the data I'm getting here. Okay, if I click on this, so here I'm getting the Shoaib name, and if I reload the browser, still I'm getting the Shoaib, but if I click, I'll get all the history. Okay, so there are a couple of small bugs are there in this application, okay, we can fix that as well. So you can see we got the entire history of this. So the $1000 send this message, and from I can send that from as a strip up high. Okay, if you have not subscribed yet to my channel, please do so. That will help you a lot. Okay, if I'll click on this, and here I'm sending the message. So let's send the message, reload the browser, and boom, here you can see I have sent the message to buy. Okay, that's my account. But if I click on this, let's add a couple of more friends. So let's make a friend with Ryan Akhtar, and here I can click on confirm, and this looks fine. Okay, if I come back to the chat, and this is the problem I was talking about. You can see currently we don't have the name and the address on our chat page. Okay, and because of that because we are calling a function to fetch the read information and the data. Okay, and because of this we are getting an error. Okay, because we don't have the name and the account address in the URL. So that's a very easy fix. We can do that. So to fix that, all we have to do is to here we have this read message. So we have to simply change this one. Okay, we have to simply console log out this. So this is the one change we have to do, console log out, because this is not an error. Okay, it's not an error. If a user don't have an messages, it's not an error. Okay, so we can simply save it and reload the browser, and still we get an error because we don't have the address and the name. Okay, and we need that in the chat page. Okay, so let's come here, and you can see right now it will work fine because we have the query in the URL. Okay, so it will work fine. But if we don't have the URL, it will throw an error. So we have to add a guard class on that. So if I come here, if I send a message to something like let's come here, let me take this demo text and simply paste here. Okay, if I send this one, and here I have click on confirm, and here I have the message. Okay, so I have sent the message to Shoaib Ryan Akhtar. Okay, and this is for the Shoaib account. Okay, so it's working absolutely fine. So let's come here and let's go to the $1000 account, and let's try to see that whether we have received the message or not. So here you can see that's what I have. I will simply try to, so right now I will simply try to clear the history. Okay, reload the browser, and here we have, if I click on Shoaib, here we have the information, and you can see all these messages which I have sent. So let's reload the browser one more time, and here you can see we have the message from the Shoaib. Okay, it will take a little bit time to get. Okay, so finally we got the message back. If I switch, you can switch to, and you can send message to whoever you want. Okay, and let's send the message to Ryan Akhtar. If I reload that and just wait, click on confirm. Okay, the message is not got. Okay, sorry, I have by mistake I've selected to this. Okay, let's select Ryan and reload the page. And this is the one bug we have. Okay, because every time we have to reload the page, we have to fix this one as well. Okay, so let's click on confirm, and let's make that, and here you can see this is Shoaib, the messages which we have sent from $1000. Okay, dollar account. Okay, and from here you can easily able to create a friend. From here you can easily able to add your friend. Okay, and you can see everything's working fine. Let's close all these tabs, and let's try to check all the things are working fine. We have no issues in this. You can easily able to send the message to your friend. Like all you have to do is to select this. If I come back to the all user, and you will see this is the problem I was talking about. So right now we have all these friends, but if I see on mobile device, everything is working fine. It's 100% responsive for all the devices. Okay, this is the problem we have, because right now we don't have that name and the address in the query, and we are trying to call the function on the base of the query. Okay, so that's why we are getting this error. Okay, so to fix this, all we have to do is to come back to the index page, and here we have to run a use effect, and this time we have to look for the if. So we're going to cut this portion, and we'll say if chat dot address. Okay, so if we have the address in our object chat data, then we want to call this function. Okay, and this will fix the problem. So you can see if we come back and reload the page, and if we'll click on this, and you can see no more error we have. If you click, and you will get the data. Okay, it looks fine. Okay, and that's how things will work. Okay, it will work fine. You can see all the data we are getting here. If you click on this, you can easily able to send the message to your friend and click on confirm. Okay, that looks pretty fine. You can see we have all these messages and things are looking good. We are done with this. Now let me simply open GitHub and let me push this entire code to GitHub so you guys can get it. Okay, so let me type GitHub. This is my repo. Come back here and I'm going to create a repository by the name blockchain chat app. Okay, I'll say chat app. It will be public so you guys can get it. And now I have to initialize this command. Simply copy and close this one. I have to delete this git folder from here and I have to simply initialize the command. So stop the application from running. Okay, and I will say git init, git add. Oh, I forgot to add the dot, and that I have to paste, come back, copy the branch, paste, and come back the location and simply push this code. This will happen very quickly. And the code is uploaded to GitHub, and if I reload the page and here you find all the code we had here. Okay, so if you go to this assets folder, in this you will have all the images. Okay, you will find all the images which we are using in this project. Okay, so everything is working fine. So make sure come and give a like if you really like my work. Here you will find all the project which we have worked on, and just open up your browser and type $1,000. Okay, because I have powerful resources on my website as well. Okay, so this is my website. Click on this, you'll come to my site and here you will have a lot of projects. Okay, these are the projects we have already built. So NFT marketplace, we have web3, etherscan clone, okay, chat application or online voting organization, e-commerce. So all these projects which we have built, so you guys can come and have a look from your end, and if you like any one of these you can easily able to check from your end. Huge product. I know that you guys have learned something. So I believe that you guys have learned something really important in this complete project, that how you can build any kind of application, whether it's a chat application or an e-commerce store or any kind of contract big project on the blockchain. Okay, the possibilities are endless. You can build any type of application, and I believe that if you guys really build this application, you will have a lot of understanding that how to construct the smart contract, how to pass the data, how to fix the problem, how to communicate with your Ethereum node, and how you can run your own node and fetch the data, all those things. So hope you guys have learned something new. If you really have any question, any doubt, do leave in the comment section. And if you're watching this video for the very first time, and if you're new to my channel, hit like and subscribe. That will motivate me a lot to come up with this project. Okay, so make sure to watch the complete playlist, and I have a complete playlist on e-commerce like NFT marketplace. You can watch that, where we have built the smart contract, where we have built the front end, where we have built the entire API. Okay, so we have a lot of cool things on my channel, so you guys can have a look from your end. So hope you guys are having a great day. So that's the only thing I want to cover here. Hope to see you in the next video. Have a wonderful day.